What problem does a database solve? What is the difference between database and file storage? Why so many databases? What is a relational database? What are ACID properties? Are there any performance trade-offs due to ACID properties? What are the isolation problems? What are the isolation levels? How databases implement the isolation. Now let's discuss what is a transaction, what is indexing, why indexing is needed, how index works internally, when not to use the indexing, what should be the indexing strategy, how database uses index during the query execution. So more than one column, hence this is a type of composite index which is allowed. But when you have this multi-column index, you need to keep in mind about an important rule, which is leftmost prefix rule. Will too much indexing cause issues? What is normalization? Why do we need normalization? What are the various normal forms when we talk about normalization? Do we always normalize fully? When to normalize versus denormalize? What is a join? Why joins exist? What are the core join types? What is the difference between join versus where? And how to use each of these? What is the SQL execution order for the keywords like join, where, on, from, all such things? How database executes a join? What are the best practices for using join? What are the common join pitfalls? Scaling relational databases. Now the question comes, why do we need read replicas? How replication works internally? Why do we need sharding? What is the difference between sharding and replication? How the querying happens in the sharded system. Now what is re-sharding, which is hot shard problem? The doubt is, in normalization joins are fine, then why join is the issue in sharding? What is NoSQL? Why NoSQL exists? What is cap theorem? Is cap theorem applicable to SQL database? Can we decide for CP versus AP per request that we make? How is horizontal scaling built in NoSQL? What is a node and what is a partition in NoSQL? Why NoSQL partitioning is different from the SQL sharding? Why do partitions exist at all in NoSQL? If NoSQL can do DB level logic to do the horizontal scaling, why can't SQL database just do the same? What are the types of NoSQL databases? What is a key value database? How data is stored internally in key value NoSQL database? What is a document database? What is a wide column database? Why wide column database is used for time series storage? When to choose document database and when to choose wide column database? What is graph database? How graph database stores data? What is the difference between SQL versus key value database versus document database versus wide column database versus graph database? What is a search database? Why normal databases are bad for this kind of search? Now let's discuss about time series database. How data is stored internally in time series database? What is the difference between wide column database and time series database? Why would companies still use wide column database for storing the time series data? What is the difference between OLTP versus OLAP database? Why not always use NewSQL? What is Polyglot Persistence? Why do you even need Polyglot Persistence? Which database will you choose for Netflix? Which database will be used for Amazon? Which database can be used for designing Facebook or Meta? Which database will be used in Google Drive? Which database will be used to design WhatsApp? Which database will be used to design Google Maps? Which database will be used to design Google Ads or click advertisements? Which database will be used to design YouTube? Which database will be used for designing tiny URL? Which database will be used to design Leetcode? Which database is required to design Tinder? Which database will be used for payment system? Which database is required to design the ticket booking system like Bookmyshow? I am going to share with you a cheat sheet which can help you to identify the correct database. What's up everyone? Welcome to Mohit Chabra Tech YouTube channel. My name is Mohit Chabra, ex-Salesforce, ex-Walmart, and in today's video, we are going to talk about database. So if you're concerned about database, this is the only video that you need to watch till the end and you will get all the answers. Like why do you need a database? Why do we have different kind of database? SQL versus NoSQL, all the databases, when to use which one. We'll talk about everything in detail in this video. What I want from you guys is to show some love on this video and to this channel. Make sure you hit the like button, subscribe to the channel and share it with your friends and family so that I can create more such wonderful content for you. So let's first discuss why do we need database. I'll try to explain it to you in a very simple terminology, okay? So we know we have client and server. If you want to know in detail about client and server and the basics of the system design, refer to this video of mine where we have discussed about system design fundamentals in details in like 4 hours, okay? So you'll get the complete understanding of what is a client, what is a server. So go and watch this video out for the fundamentals of system design in very easy terminology, okay? But if in summary I have to tell, so client refers to the end user. Say you have an application like YouTube, okay? And the end user is using the YouTube on the mobile phone. It can be Android or iPhone in the application format. So that is acting as a client. Other way around is the end user can also use the YouTube on the web browser in a PC or a laptop, right? And that is also acting as a client. So the mobile apps and the web browser in the laptop both act as a client, okay, through which the end user can interact. And server, in very easy terms, you can say it's where you have kept your business logic which gets executed. So on small scale, even your laptop or PC can act as a server because you have kept your logic, like you have written a method or function there which gets executed, and through that you provide some output. But when we talk about scale, server means multiple powerful machines, and those are generally handled or provided by the big players like AWS, Google, or much more, okay? So generally when we talk about scale for server, it is on the cloud side. But if we talk about on small scale, yeah, even your simple computer or laptop can act as a server. But because in system design we talk about scale, distributed systems, so server is multiple powerful machines which are generally handled by the big players, okay? So they take care about the availability part and much more. Again, for more details, refer to this video. Okay. All right. So client and server. Now one more concept is like client interacts with the server using API, right? So what client sends is called request. So client will send the request to the server, and on server side, your application or your business logic will get executed, right? And server provides response to the client. So corresponding to the request, we have response. Okay. So the client sends request and server sends the response, and both of these are part of API, right? So these are the basics of system design. If you have any confusions about the basics of system design, don't worry. I've already created multiple videos on my channel where we have talked in very much detail in very simple terms like what is a server, what is a client, what is an API, request, response, everything. So go check out my channel and watch the videos through which you'll get the complete understanding, right? Okay, we mentioned earlier when we talk about small scale, even a PC or a laptop can act as a server. It can handle both of the things, like it can handle your business logic as well as maintaining the data, right? Now what data and why is that required? Let's see that with an example. So this is my YouTube channel, Mohit Sabra Tech, right? So you can see there are a lot of videos out there, correct? So this is all data. When we talk about the client side, like your application or the browser through which the end user can interact, now your mobile phone or your personal computer cannot contain all this data because we are just checking this channel right now. On YouTube there are so many channels, right? So your mobile phone or your laptop cannot contain all that data or information, and it should not even contain that because otherwise that would be a security concern. Why would your phone or laptop contain all the information about others, right? So with this we get to know that client does not have the data with it, right? Data can be, say, when we talk about the YouTube, the videos and the information related to the video, correct? And similarly for different applications, it can be different data, correct? So client does not have that data. But just imagine if you open the website or the application, you could see the UI, okay, you can click on the buttons and everything, but you do not have the data to interact to. It does not make any sense, right? Because you are not able to see any video. On YouTube, you come to see the videos, that is the data. If we don't have the data, then what's the point, correct? So that's why data is really important. So as we said, on small scale, your server can have the both of the things, like handling the business logic at the same time handling the data part. But when we talk about the distributed systems, when we talk about the scale, we know that one system cannot handle everything, right? That's where system design comes in. So as we said, server at scale will be multiple powerful machines, okay, and that will handle the business logic. But for the data part, we will have a separate component, and that will be database, okay? And that's where this video comes into picture, because today we are going to talk in detail about the database component. So basically the client will interact with the server and server will interact with the database, okay? And from the database it will get the data, and then on top of it, it can perform some other computations, whatever requirement is there, and then it returns the final output to the client as per the requirement of the client, okay? So one of the core benefits of database is that it will persist the data. For example, say I am using WhatsApp application, okay, and then I sent a message to person B, okay? So that message now, because I've sent, will be stored in database that provides like durability, persistent storage, and even after few weeks or months or even after years, I can go back to that message, which means the database is providing me the persistent storage. Similarly, you can talk about other apps, like I upload a video on YouTube, so that is persistent kind of storage, okay? It stays there, right? So this is where persistent storage comes, durability, and that is the role of database. Now because we are talking about this, let's discuss one of the basic questions, which is, what problem does a database solve? Okay, we know that we talked about the persistent storage, right? It provides you durability, but is that the only thing the database is doing? So not only durability, the database provides you multiple things, okay? The first one is the persistence, which we talked about, like the durability. Say for example, you had a note making application, okay, and you made a note and you saved it, and after that suddenly your phone restarted, okay, but because you saved it, there was database, hence the data survived even through crashes or the restarts. So the durability part, the persistence part is the first thing that we have already talked about. But apart from that, there are many more things that a database provides. One of those is efficient access. When we talk about CRUD operations. What are CRUD operations? Basically, C stands for create, R stands for read, U stands for update, D stands for delete. So the CRUD operations are basically performed efficiently using the database. So fast reads and writes, one of the core functionality of the database. Next thing, concurrency control, which means many users can use at the same time, okay? So concurrency. Next point is consistency, which means that the data will stay correct. And last but not the least, reliability, which means even after failures, your data will recover, which further means there is no single point of failure. So even in case one database fails, we have the recoveries which are present. Okay, so these all are the problems that the database solve. Now before we move to the other basics related to database, like the SQL, NoSQL and other databases, when to use which one, let's discuss about one more basic questions that comes into the mind, which is, what is the difference between database and file storage? So we are talking about data. So instead of database, we could also store it in the file storage. So why not use the file storage always? The reason is, like, the file storage is used generally for the raw byte storage, whereas database generally has the structured data storage. Apart from that, as we talked earlier, for the CRUD operations, for efficient access, for fast reads and write, so we use database for querying, okay? Like you can query and put filters on it, whereas in file storage you do not get an option for query. So no query is available in file storage. In database, we also have indexing. Don't worry about indexing, we'll discuss about it later in this video, but majorly it's used for fast read, okay? Whereas in file storage, you do not have any indexing. Next, as we talked, in database you have the concurrency control. So you have locks or MBCC for the concurrency controls, whereas in file storage you do not have any concurrency control. Next thing is like the file storage is cheaper as compared to the database, so database is expensive. Okay, and last point is the file storage is best for blobs, whereas database is best for the structured data. Now what is a blob? It's like binary large objects. For example, when we talk about videos or images, those are considered as like binary large objects, and file storage is good for storing that. So when we talked about YouTube example, right, where I am uploading the video, now because I'm talking about video which is a blob, right, and we said like blob is good to be stored in file storage, so which means that when I upload the video, the actual video will be stored in the file storage, where it is generally stored in like AWS S3 or equivalent kind of other platforms which are available out there, but not in the database. In the database, you generally store the metadata, like Mohit Chavda is the author, at what timestamp it was stored, what is the file type, all that kind of information would be present in the database, but the actual video would be present in the AWS S3, which is the file storage. Okay, now a question may come into your mind: why do you store images, videos or blobs into the file storage and not in the database? Because when we talk about a video or image, you generally don't require like CRUD operations on that, because you generally don't update the video, it generally stays the same, right? So you don't require that querying kind of part, you don't even require indexing on that. Okay, so the operations which are present in database, which are the basic functionality a database provides, that is not required in these images and videos. And on top of that, as you know, like the images or videos are quite big in size. Okay, that's why they are called like blob, which is binary large objects, right? So as we said, like the database is expensive, correct? So you don't want to store this like heavy items in database, because that would be expensive for you, and at the same time you are not actually utilizing the basic functionality of the database. You just want to store this, so for that the file storage makes more sense. Okay, so when to use the file storage? Like images, videos, PDFs, backups. And when to use database? When you have user data, orders, transactions, metadata, where you have the structured data, where you require querying, indexing, all that kind of stuff. Okay, so if we talk about the YouTube video, the actual video will be stored in the file storage, but the metadata related to that video will be stored in the database. Okay, so after this, the next basic question that comes into the mind is like, why so many databases? We know there is SQL, there is NoSQL, there is time series based and much more, which we will talk about in detail in this video. But why so many? Alright, the answer to that is like different systems have different needs, which makes sense, right? Some need strict accuracy, like you have the banking application where you have to do the financial transactions, right? So you need the DB according to that. But some of the applications required huge scale, like for example Instagram or WhatsApp. Like in WhatsApp, you can imagine the scale of the messages, so many messages every second out there, right? So you need to maintain that huge scale, so you need to have database that can handle that. But here comes the good part: if you want to know the system design of WhatsApp or Instagram, you can refer to these video of mine where I've discussed like how WhatsApp works internally, how Instagram works internally. Okay, go check them out. Okay, apart from that, another need of the application could be the fast reads. One example could be like the Twitter's user feed, correct? So it needs to be very fast, otherwise you don't feel like using that application, correct? Another requirement could be related to the relationships, like the social graph, which you could see clearly in Facebook application. And another different need could be related to the search, like Google, Amazon, correct? So you can clearly see different needs for the different features or the applications. So one database cannot do everything in the optimal way. So that's why you have many databases, right? So before going ahead, time for some promotion for myself only. Alright guys, show some love to the channel. Please make sure you subscribe to the channel, like this video and share it with your friends and family. Okay? Thank you. Alright, so next let's discuss the different types of databases that we have, and let's start with the most basic one and most known one, which is the relational database. So the first question that comes in mind, what is a relational database? So basically in relational database, we store the data in tables. So now as there can be multiple tables, so tables are related to each other using the keys. Don't worry, we'll talk in detail about each of that thing, but just to give the basic thing, we store the data in tables and tables are connected to each other via the keys. You can simply imagine it as like using the Excel sheet, right? Where you have like rows and columns, but there are strict rules in it. Okay, basically the word relational refers to basically the tables which are related to each other via keys. Okay, so let me try to make it more easier for you. Let's see the core building blocks which are part of RDBMS. So the first one is table, which we just discussed above, right? So you can imagine the Excel sheet. So that is the table, which is the collection of rows and columns, right? So each of the table will represent one entity. Now entity is a technical term which you give to table. Okay, so we say entity. Example can be you have the users table, orders table, payments table. All right, as we said, table consists of rows and column. So let's see the next core building block, which is a row. Okay, and in technical term, as we mentioned, table can be called as entity, right? In similar way, row in technical term is called as tuple. Now each row represents one complete record, correct? Similar to what we have in Excel, this is one record, this is another record, this is another record. So in similar way, when we talk about the RDBMS, one row represents one complete record. For example, this is one of the row which has data like 101 Amit at the rate gmail.com. So this is the complete record, which is one of the row of the table. Now because we mentioned table is the collection of rows and columns, and we have already discussed about row, next let's talk about column, and in technical terms we call it attribute. So for example, this was your table, this was the row, this is the column. Okay, these are the columns. So column represent property of the entity, like what property are we talking about, and it has a data type. For example, name is the property and the data type is varchar. Age is the property and the data type is int. Created at is the property, timestamp is the data type, right? So now you can clearly imagine you had the column here which was the property and had a data type, and here you saw the values. For example, this here you can see 101 Amit at the gmail.com. This is the row corresponding to it. The columns could have been the roll number, name, email ID, right? So we talked about table, row, column here, correct? But apart from that, we said like relational means the tables which are connected via the key, right? So we also need to talk about the keys. Alright, the first key that we are going to talk about is the primary key, or in short you also call it PK. See, I know a lot of things that we are covering are at the very basic level, so maybe you already know about this. So what you can do is like I've already provided the timestamps at the bottom of the video. So if you find that you already know some of the stuff, you can skip to the next section which you want to learn about. But what I wanted to make sure in this video is like we want to cover the database from very basic level to the detailed level, and I would recommend you to watch this video completely because you may be aware of some of the things already, but you might also get to know some of the things, or it can be a good revision for you. So depending on whatever you feel, you can either watch the complete video or go to the timestamps and switch to the section which you want to go to. Okay, let's come back to the topic. The primary key, what does that mean? It means like you can uniquely identify a row, right? We are talking about the rows and the columns in the table, correct? So we want to uniquely identify the row. So how do we do that? Using the primary key. So this means using the primary key, no two rows are same. We can clearly identify the row using the primary key, and because it is uniquely identifying a row, so it cannot be null and it must be unique. Of course it must be unique because its role is to uniquely identify a row. So it must be unique. One of the example could be, you can say the user ID is acting as a primary key. So every user is assigned a different ID. So by default it is unique. It cannot be null. And using the user key, each of the row is also unique, which means the data cannot be completely same because the user ID, which is the primary key, will be different for each of the row. Now why do we require the primary key? Because it is useful for the fast lookup. For example, you want to fetch the data of a particular user, and that can be identified by the user ID. So we can get the unique rows based on that user ID, and we can give the data of that particular user. Another important part is like it guarantees the uniqueness because the primary key will be always unique and not null, and that's why the complete data, all the rows will have the unique kind of data. All right, that's okay, but we are still not connected between the tables. We said that relational means tables connected via key, correct? We here talked about primary key, but we did not talk about like how multiple tables are connected to each other. Now that basically happens using the foreign key. Okay, in short you can say that FK. Now what does that mean? It basically means a column referencing to another table's primary key, right? So now you can see connection between two tables. So there was table 1, there was table 2. We had the primary key of this table as well. Now we also have a foreign key. Now foreign key is basically making a reference to the primary key of this table 1. So using this foreign key, this table 2 can get connected to the table 1. So this is the key through which we are making the connection or exchange between the multiple tables. Now why is it required? Because as we discussed, relational means tables connected via keys. So foreign key is the key which can connect multiple tables. So it maintains referential integrity and it prevents any invalid data. Okay, so apart from all this, one important thing that you need to remember about the SQL database or relational database is that it provides you structured data, which means in this table all the columns are kind of defined. Okay, so for a table columns will be defined, so you have the structure defined, correct? All the rows will be according to that only. Say for example, we set the columns as roll number, name and phone number, correct? So corresponding to it, all data will be related to this only, right? So we provide kind of a structure. So the data is actually structured in RDBMS. This is a property of RDBMS, you can say. Okay, let's discuss a very important and famous topic, which is what are ACID properties. And the interesting part is this is highly asked in interviews. So ACID stands for atomicity, consistency, isolation and durability. Now SQL database is famous for ACID properties. So let's discuss ACID properties in detail. Alright, first A stands for atomicity, okay, which means transaction is all or nothing. Let's take an example through which you'll get the clarity. Okay, so say A was trying to transfer some money to B. Okay, now here you clearly see there are two things. You will debit the amount from the account of A and then you will credit the amount in the account of B, correct? So what atomicity means is like if one of these fails, it will roll back everything. Okay, it's not like one thing will remain at the success state, other will remain at the failure state, because that will cause the discrepancy. Because if that happens, A will lose money but B will never get that, right? So A was trying to send money to B. In case B is not able to get it, A should get it back, right? And that is maintained via atomicity, which is a strong feature of RDBMS. So you can remember atomicity as all or nothing. An easier way to remember is like we remember that an atom is the smallest unit, right? Similarly, you can keep in mind here it keeps a complete transaction as one unit. If any operation inside that transaction fails, the complete transaction will fail. Okay, everything will roll back. So say A had like $100 and B had like, you can say, $80, and say A was trying to transfer $10 to B. Okay, so if we go through the step 1, so if we reduce $10 here, it will remain like 90. But if B doesn't get it, this part was not successful, then what should happen is like all the operations which happened in this complete transaction, because we are taking this complete step as one transaction. We'll discuss more about transaction later, don't worry, but just assume all of these steps we are taking as one transaction. So because this one failed, what we need to do is like whatever happened earlier we need to roll back. So again, instead of 90 it should come back as 100 for A, right? Which happens for us as well whenever you do the financial or banking transaction. In case you make the payment but it is not succeeded at merchant's end, or whatever failure happened, you get your money back. It's a refund that you get, right? But if we don't follow atomicity, then what can happen is like the transaction can fail and you can also lose the money, which is a very weird situation when we talk about financial transactions, correct? So atomicity makes sure that it is all or nothing. Okay, so after atomicity we have consistency. Okay, consistency means DB moves from one valid state to another. So basically we will always keep a check on the constraints. So let's see an example through which you will get more idea about the consistency. Alright, here you can see some of the constraints like not null, which means it is a mandatory field and it cannot be null. Then if we put unique constraint on any column, which means it will prevent the duplicates. So unique constraint will not allow any duplicates. Okay, similar to that there can be other constraints as well. In simple code level terms, if you talk about constraints, we have something like say age should be greater than 18, only then you are allowed to do the vote, correct? Something like that. So that is a constraint. You can imagine it very similar to what we have the setters, right? Getters and setters. We generally make the field private and use getter and setter, especially if I talk about Java programming language, so that in setter you can set the constraints like only if the age is greater than 18 you are allowed to vote, otherwise not. In similar terms, another example can be only if your balance in the bank is in positive, that is greater than 0, then you are allowed to transfer the money, right? So this was a consistency feature that we were talking about. Okay, so consistency means that rules are never broken. If we talk about one more example related to consistency, it would be say you are trying to book a movie ticket. Okay, and you are allowed to book a ticket only if the available count is greater than 0, correct? In case all the tickets are sold out, you are not allowed to book the ticket. So the database will reject all the queries with invalid operations. So basically the constraints prevent the wrong data. So in order to maintain the consistency, both the application logic and the DB rules, both of these combines for the consistency behavior. Alright, the third one is isolation, which is related to concurrency. Okay, we know like multiple transactions can happen at the same time on the database. So multiple people trying to book tickets, multiple people trying to do the financial transactions at the same time, right? So your DB will get hit by multiple queries at the same time. But what isolation makes sure is that although multiple transactions are running at the same time, these would behave as if they ran one after another, which means all of the transactions are independent of each other. They are not impacting each other. Alright, let's try to understand this with a very simple example. As we said, like in isolation, we talk about like concurrency, like multiple people are trying to do the transaction. So let's see an example of the seat booking case. Okay, let's first see without isolation what happens, right? So here is the scenario that only one seat is left, okay, and two users are trying to book the seat simultaneously, which is a very normal scenario, right? Just imagine like there is a new released movie which is getting really famous and there is only one seat left, right? So two people are trying to get that seat because it's a high rush kind of a state. Now if we talk about without isolation, like there are two people, T1 and T2. T1 will see one seat left, T2 will see one seat left, T1 will book the seat and T2 will book the seat as well. So the same seat, the only one seat which was left, will be booked by two people. That you might have also seen in real life. Sometimes that happens, like due to sometimes different platforms are not managing things properly and they book one particular seat to multiple people, and then there are of course issues. Only one can get the seat, for others that gets rejected and they get the refund, which is a very bad user experience, right? Now the same example let's discuss with isolation. Okay, here basically the DB is ensuring that say user T1 has completed the booking first, then T2 will see his seat as 0. Okay, so the transaction of T2 will fail. So which means only one person was able to book the seat successfully, and that happened via isolation. Now in isolation, we also want to discuss some other famous interview questions like what are the isolation problems and what are the isolation levels. We'll discuss that, but let's first discuss about the last component, which is the durability. But before that, isolation basically is really useful in terms of managing concurrency, like multiple people, multiple transactions are happening at the same time. So that is handled in a wonderful way using isolation. All right, the last one in ACID properties, D stands for durability. We have talked earlier about durability as well, which means once you have committed, it stays there for forever. So once you have committed the data will be stored permanently. And that means even if there is a system crash or power goes off, your data will be stored permanently. Okay, so for example, for that movie ticket you were just booking, you booked it, so it was successful, and after that the DB crashed, the system crashed, but even after that your booking will exist and it will survive because it has been stored in the database already. Now a question may come, how does the database maintains durability? We said like the DB may crash, the system may crash. In that case, how is our data surviving? So there are multiple ways. First, if we talk about is write ahead logging. Next is data is flushed to the disk. And third is the replication. Replication simply means that you have multiple copies. So say one database crashed and you had data in it. It's still okay because you have multiple replicas of that DB. Okay, so generally you can imagine like we have 3 or more than that replicas of a DB. Okay, so even if one of those crashed, your data will still survive. So using these 4 properties, atomicity, consistency, isolation and durability, the database stays correct and reliable. When I say correct and reliable, it will happen even in the cases when we have multiple transactions at a time, so multiple users using your DB or your system at a time, so that will be handled. Also in case some crash happened, if you have committed something, that will stay there in the system, so the durability factor. Also the constraints factor, we already have few of the constraints and that will be maintained throughout the system. Like for example, if all of the tickets are booked, you cannot book any more ticket. And last but not the least, just in case any one of the operation fails, we take all the operations in transaction as one single unit. So if anything fails in the operation, everything will be rolled out to the initial stage. Now we have understood about each of these component as an individual, right? What does atomicity mean, consistency, isolation and durability? Let's see an example which combines all the ACID properties. Okay, so we are taking Bookmyshow seat booking example. Okay, so a transaction, as we said, can consist of multiple operations. So all the operations which are part of one transaction will be taken as a single unit, which means if any of these fails, we will roll back all of the operations into the initial stage. Okay, so this complete transaction is a single unit. Okay, although it can consist of multiple operations. Now here we are doing begin means we are starting, and then what we want to do is like check seat availability. Then we want to lock the seat because multiple users can try to book one seat at a time, so we are locking the seat. Then we are creating the booking, then we are marking the seat as unavailable because we have booked it, and we then make commit, which means transaction complete. Okay, so if we talk about the ACID property and their role here, first of all atomicity, which means this transaction acts as a single unit. As I told earlier, all the operations inside this transaction will be part of one unit. Either everything succeeds or everything fails. Okay, so just in case operation 1 passes, operation 2 passes, but operation 3 fails, what we need to do is like we need to roll back operation 1 and operation 2 as well, because everything will go back to the initial state because everything is a single unit in this one transaction. Okay, so that is atomicity, and what it ensures is that there is no partial booking. So nothing like your money deducted but seat wasn't booked. In case your money was deducted, it will be refunded because we will roll back, correct? Or the other case is everything will succeed, so money deducted and seat is booked. Okay, So either complete success or either complete fail. So you can treat atomicity as 0 or 1, nothing else, nothing partial. Okay, next, consistency. We can set the constraint like you can do the booking only if the seat count is greater than 0, right? If it's a positive count, because you can only book a ticket if there is something left, right? So there should be at least one ticket available, only then you should be allowed to do the booking. So the constraints will be part of the consistency. Okay, one major confusion that comes is like generally we think of consistency as like the data remaining consistent, which we will see in other examples later in this video. I'll again remind you when we talk about that state. But here in asset properties consistency, you need to remember in terms of constraints. So for example, we are talking about the seat booking. So constraint like the available seats should be greater than 0, only then you are allowed to book. Similarly, you can never transfer the money from your bank if your bank balance is not greater than 0. All such kind of constraints like field is marked as unique, not null, all such kind of things are handled by the consistency here in the asset properties. So you need to remember that part. Okay, again, as I said, like when we come to that stage of what consistency I'm talking about, I'll remind you again, so don't worry about it for now. Okay, the third one, the isolation. It means like we are talking about multiple users are doing the booking or using your system at the same time. So what we need to make sure is that we handle that kind of scenario so there is no double booking. Correct. And last, durability. It means like say this commit has happened, so a user has booked the ticket, the seat has been allotted to a user. After that, even if your DB or the system crashes, this booking should remain in your system. Okay, how do we handle it? We just saw like replication is one of the things, write ahead logging or data flash to disk, multiple things that you can do for the durability factor. But the main point is that booking should also survive the crash. Correct. So these are the asset properties and their roles in any system. Okay, as I told earlier, RDBMS or SQL based database is famous for maintaining the asset properties across rows and across tables. Okay, so asset is a famous feature of SQL database. So here we discussed about the asset properties and we saw the use cases. But one question that may come into your mind is like, are there any performance trade-offs due to asset properties? Like if the database is maintaining the asset properties across, so are there any performance issues due to that? Yes, of course. I mean, everything has pros and cons, right? So let's see some of the performance trade-offs due to asset. So when we talk about the atomicity, it provides you features like all or nothing, right? But the cost you need to pay is the logging overhead, because you need to do this as you have to roll back to the initial state in case one of the operation fails, right? So you are doing that, so that is the cost factor for you. When we talk about the isolation, we talked about in isolation multiple people are trying to do the booking or using your system, and this basically handles that. But the cost that you need to pay is like if you are applying the lock. Say for example, we saw here like you locked the seat because there is only one seat and multiple people are trying to book it. So we are locking the seat for one person so that it cannot be locked by another one. So if we are doing that, then the locks reduces the concurrency. What does that mean? Of course, like multiple people won't be able to access that at a time, right? In a very brute force way, if I have to explain it to you, just imagine like in the Java programming language, when we talk about multi-threading, right? We discuss about multi-threading in these videos. If you want to refer to, you can check that out, you'll get some clarity. But a very simple example that I would relate here is not exactly the same, those are different things, but just to explain you, in multi-threading, say this is a method and multiple threads try to go inside this method, which is allowed, right? But if you use the synchronized keyword, right, if you use synchronized keyword with the method, then what happens is that at a time only one of the threads can enter the method. Correct. So there are many other keywords as well. But if we say like synchronize, so in that method or block, you can say only one thread can enter at a time, so that reduces the concurrency, correct? So you're not allowing multiple threads to go through the method at the same time. So of course, if you are applying the locks, you will reduce the concurrency, so that is the cost that you're paying, right? And the third one, when we talk about the durability, now because in durability you said like if something is committed, even if your server crashes, your DB crashes, this should survive. So how would that happen? You have to pay the cost for that, right? You would do the disk IO latency, or you would do the writes, you will have the replicas, all that kind of things. You have to pay for that. That is in the cost factor, right? So this means like high ACID properties means lower throughput. Okay, we said like SQL database follows ACID. At the same time, because there are performance trade-offs due to ACID, the NoSQL DB, which we are going to discuss later in this video, don't worry about that, they relaxes the ACID properties. Okay, so this is one of the core difference between SQL versus NoSQL. The SQL database follows ACID properties strictly, whereas NoSQL database relaxes the ACID properties. For now, don't worry about NoSQL because we are going to discuss in very much detail about each of those in this video, so you'll get the complete understanding. But yeah, I'm just giving a brief summary to you for now. Alright, so basically we discussed about the ACID properties, right? And when I was talking about isolation, I talked to you that in interviews there are some questions related to isolation that we would like to discuss. Now, one point I would like to say is like maybe these things like which I'm going to talk now, you might not be able to understand it in one go, but it's totally okay. Don't worry about it. It's just like an important interview topic, so I would like to cover because we are going through the ACID properties. In case you are going through the isolation topic or the ACID properties for the first time, if you don't get this, don't worry about it. Go through the complete video, try to understand whatever you get in the first time. Slowly, when you get more idea working on the DB, when you revisit the video, when you get more clarity, you can revisit this topic again, or you can read it about it later as well. You'll get more understanding, so don't worry even if you don't understand it properly for now. Okay, so a famous interview question related to ACID property is, and specific to isolation is, what are the isolation problems? So we discussed isolation deals with multiple users are using your system at the same time. So what kind of problems can happen at that time? All right, so these are the isolation problems: dirty read, non-repeatable read, phantom read, and the lost update. All right, first starting with the dirty read, which says read uncommitted data. Okay, so what happens in dirty read is like there are two transactions, okay, T1 and T2. So one of the transactions reads uncommitted data from another transaction. Like, it sounds like weird, right? But let's see with an example. So say the initial balance was like 100, okay? So the transaction one, it updates the account value to 50, but this is not committed yet. Now what is committed? We saw the steps, right? Like for example here, when we were talking about the transaction, right, these were all operations which were part of one transaction. All of these happen, and last you do the commit, which means this transaction is complete, this transaction is done. Okay, so what we mean here is like this transaction, it tried to update the value like 50, but it has not committed yet. So this was just one of the operation which was happening, but this commit step hasn't happened yet. Okay, so this is the current situation we are talking about, and before the commit has happened, another transaction, it basically tries to check the balance. So it has applied the select query. Basically it's trying to read the balance. Okay, we updated the balance from T1, but it has not committed yet, but the transaction 2 is trying to read the balance, and transaction 2 is able to see 50 as a balance. Why? Because this is a dirty read case where you are able to see uncommitted data. We said like we have not committed this transaction yet. The one of the operation has performed, but we have not committed yet. The transaction is not complete yet, you can say. But the other transaction is able to see the uncommitted data of the other transaction. So it can see 50 as a balance. So this is the dirty read, which means the balance was actually 100 because it is not 50 yet, as the transaction 1 is not complete yet because we have not done commit yet, correct? So the balance was 100, but the transaction 2 saw it 50, which was wrong, correct? And that is dirty read. When one of the transaction is able to read uncommitted data of another transaction. So you can say dirty read. Yeah, good term, I would say. Like, it tells you like dirty read means you are reading which is not committed. Okay, interesting. All right, why is it bad? Because we have made the decisions on the data that never existed, correct? Because like here T2, the transaction 2 saw the balance as 50, correct? Whereas the actual balance was not 58, it was 100, because it may happen that T1, the transaction 1, rolled back because it has not committed yet, so it can roll back. So once the transaction 1 roll backs, it won't be 50, it would stay 100 because it has rolled back, right? But transaction 2 saw 50, which was the wrong reading actually. So you are reading uncommitted data which may or may not be true, you can say. It's same as like, I mean, a very weird example, but again, you raise the PRs when in the development field, you in the GitHub, you generally raise the PRs. So there are two kind of PRs: the draft PR, which you generally do like just for testing or maybe for just for checking things, and then the normal PR that you publish. But on top of that, till the time you have not merged the things, that is not part of the code, correct? Your development branch or the main branch. So you cannot take that, okay, this would be part of the code, I am using this only, right? So I mean, weird example again, but you can assume like that. Let's take another example. Say I was booking a ticket, right? So me and my friend both were planning to book the tickets, okay? So say for example, my friend saw me that I was booking the ticket in the process, correct? So I clicked on book, but after that I have to make the payment, right? So I was in the process and he saw me, so he thought like, okay, he's making the booking, let's take a chill pill. Okay, so maybe he went away because he saw like I was doing the booking, so he took a chill on that part. And say I got a call in between and I forgot to make the payment, right? So I did not complete the booking or in the process, but I did not complete it. And later when I cut the call, it was already more than like say 10-15 minutes, and that window crossed, and there was no more seat available. So there was just an assumption that booking would be done, but booking was not done, right? Again, maybe a weird examples for few, yeah, but maybe some of you might like it as well. Okay, don't worry, I mean, you may see more such weird examples coming. Okay, so the main part is you can clearly see you are just reading some of the data which might not be true because it's not committed yet. Interestingly, you also have the commit command when you do the development work, git commit, right? So I mean, interesting things. But yeah, of course, so this is what you call as the dirty read, right? And after that, we have the non-repeatable read, which says that same read gives different value. Interesting. Let's see an example for that. All right, here we go. So here is an example. Two transactions again, T1 and T2. So transaction 1, so T1 is trying to check the balance. It sees the balance as 100. Then transaction 2 updates the balance to 150 and it commits it. Okay, so it has committed, so the balance would change to 150. We are not talking about the dirty read because we are not reading any uncommitted changes of another transaction, so we have used the commit here. Okay, so committed, and now T1 tries to check the balance again, and now it sees 150. Okay, so what's the problem here? The problem can be for transaction 1, it is just one single transaction, and in a single transaction, while reading the value from the database, you are getting two different values. First time you got 100, then you got 150, correct? So you got the inconsistent view inside the same transaction. It's not in a different transaction. We were part of the same transaction. As we discussed, in a transaction you can have multiple operations, and in the last you put the commit command or the commit operation to say it's a finish of the transaction, correct? So you can clearly see T1, which is a transaction 1, it was still going on. So in the same transaction, you got the different values. Okay, so this is non-repeatable read. So this is one of the problems that you face in isolation. Okay, all right, next is the phantom read, which means new rows appear. Let's see an example. Okay, the phantom read means like new rows appear or disappear between your queries. Let's see an example here. Sounds interesting, right? We are talking about SQL here. So transaction 1, we have done select star from orders where amount is greater than 100. So this means basically we are applying the read operation. We talked about the CRUD operations, right? Create, read, update, delete. So when we talk about the select operation, we are talking about the read. So we are basically reading something from the database. Okay, so we are doing select star. Star means pick everything which meets this condition. So select everything from orders. Orders is the table name or the entity name. We said in the beginning, SQL database, everything is based out of tables, columns and rows inside the table, correct? So orders is the name of the table. Where means it's you are applying the condition that this condition should be met, only return those rows to me. Okay, amount can be one of the, you can say, column that is part of this orders table. So we are saying wherever the amount, the value of amount, so amount is the column, the value would be present in the row, right? The value of the amount is greater than 100. Okay, so say it returned you 5 rows because 5 rows had data where amount was greater than 100. Make sense? Okay, and then there is a transaction 2 which performs the insert operation, which is this create. Okay, create, read, update, delete. Okay, so it is inserting, so create command, so it is inserting a new row and it is putting the amount which is the value of amount as 200. So new row has been added and it has also committed it. We are talking about commit here because we are not talking about the dirty read case here. In dirty read we used to read the uncommitted data from another transaction, but we are no longer doing that. We are in the phantom read, so we have committed the transaction 2. Okay, now in transaction 1, because it was not complete, some of the operations were still running and it runs the select query again. Basically it tries to find the data again from this orders table. Now what will happen is, because we have committed it, now instead of 5 rows it will see the 6 rows because this new row has been inserted by transaction 2, correct? But in non-repeatable read it was about the value, whereas in phantom reads it's about the row. Okay, new row appeared or disappeared. Here a new row, complete new entry, you can say, has appeared. So clearly you could say instead of 5 rows now it's saying 6 rows. Why is it bad? Because your data set has changed, correct? So this was about the phantom read. Next, let's check the last one, the lost update, which says two updates overwrite each other. Here you go, let's see an example. So say the balance was 100. Okay, and T1 reads it 100, T2 reads it 100. Very good till now, right? So say transaction 1 updates it to 80, whereas transaction 2 updates it to 70. So now basically this has overwritten what was done in transaction 1, because transaction 1 updated it to 80 and transaction 2 updated it to 70. So the final balance is coming as 70, but the updates which were done by transaction 1, those got lost, correct? So both of these transactions first applied the read operation and then the update operation, correct? They read the same value because at that time the value was same for both, correct? And then both of these updated the values. Okay, and the later one, the transaction 2, because it did it later, so it overwrites whatever was done in transaction 1 as well, correct? So this is the problem which is faced. So these are the 4 isolation problems which happens because multiple users are using your system or database at the same time. Dirty read, non-repeatable read, phantom read, and the lost update. Again, you might not be able to understand completely for the first time. Why worry? This video is free, the content is free. I put a lot of energy on it for you. You can come back and revisit it and learn again. Okay, but show some love. Make sure you subscribe to the channel and like this video. Share it with your friends and family. Yeah. Okay, so after the isolation problems, let's visit one more very important interview question, which is what are the isolation levels? Alright, so basically SQL provides you 4 isolation levels. We'll talk about 4 of these. These are basically from weak to strong level. Okay, the first one is the read uncommitted, which says almost no isolation. Okay, read uncommitted we also discussed as the problem in the dirty read, correct, where we meant you could read the uncommitted data, right? And after this you have read committed, which means there are no dirty reads. The third one is repeatable read, which means same row stays same. We discussed about this problem earlier, right? Don't worry, we'll correlate both of these things, the isolation levels and the isolation problems in a chart or table, but stay with me, we'll discuss about that. And the last is the serializable, which says full isolation. Okay, as I said, it is from weak to strong isolation level. So weak to strong. Okay, and another thing is the higher the isolation, lower is the concurrency. Why is that true? I mean, just imagine the example that I gave it to you for the synchronized keyword in Java programming language. There was one method earlier, multiple threads were allowed to use this method, but when you use the synchronized keyword, right, only one thread can go inside it at a time, correct? So overall concurrency will be reduced, correct? You are solving the problem which was happening due to multi-threading in a particular case, but the concurrency has been reduced here. In the similar way, isolation is solving the problem like multiple users are using your DB or the system at the same time. So you want to solve that problem like double booking of a ticket. So the higher isolation you put, like serializable here we talked about is full isolation. If we put that kind of a structure, of course the concurrency will reduce. You will put restrictions on, like not all of the users can operate something at the same time, correct? One at a time you will do all such kind of things like logs or whatever you want to do. So that would reduce the concurrency overall. So the higher isolation, lower concurrency. Okay, so let's discuss about each of these in few words so that you get more idea. Okay, let's talk the first one, which is the read uncommitted, which is of lowest isolation level, that is the weakest one. It allows the dirty reads. We discuss about the dirty read, which means like you can read the uncommitted data, correct? So this level basically allows the dirty reads, non-repeatable reads, phantom reads, and lost updates. All 4 problems that we had in isolation, it allows all 4 of these. So that's why it's of lowest isolation level, correct? So example can be the transaction 2 can read transaction 1's uncommitted data, which is the dirty read, correct? So not just limited to this, all the problems that we discuss, this allows. So read uncommitted means you are allowed to do all of the isolation problems. And of course this is almost never used because we have to handle the cases where there are multiple users trying to book the tickets at the same time, the same ticket, right? So we have to handle that kind of case, so we can never do something like read uncommitted. Okay, so after the read uncommitted, second one is read committed. Okay, this is the most common one. We said like the read uncommitted is very rarely used, almost never used, and the read committed is most commonly used. What does it guarantee? It guarantees there are no dirty reads. Okay, so dirty reads are prevented, which means a transaction cannot read uncommitted data of another transaction, right? Only committed data is visible, but it still allows other problems of isolation like non-repeatable reads and the phantom reads. So an example here is the transaction 1 reads 100, transaction 2 commits 150, transaction 1 reads again, it sees 150. So you can see transaction 1 can see the different value in the same transaction. So that was non-repeatable reads. That problem is still existing here, correct? So this read committed is used by PostgreSQL, Oracle, SQL Server, the default one. Okay, so till now read uncommitted, it allows all the isolation problems. Read committed, it does not allows the dirty read, but it allows other isolation problems. Okay, and this is most commonly used. You might say that we are not talking about the fourth case, which is the lost update, but it's kind of the subset of the things that we discussed above, so we can ignore that part for now. These three are basically the most important ones: the dirty read, the non-repeatable read, and the phantom read. Okay, so these three basically form the most famous kind of the isolation problems, and the isolation levels also depend on these problems. Okay, so this is kind of the subset of what we talked about here, right? All right, going back, third we have the repeatable read. Okay, it guarantees there are no dirty reads and there are no non-repeatable reads. Okay, so clearly I think it's become easier now. It allowed everything. It did not allow the dirty read. It does not allow the dirty reads as well as the non-repeatable reads, correct? It still allows you the phantom reads, which was the third problem, which is the SQL standard as well. So it means like if the new row is added or removed, basically that kind of problem can occur. So basically if you try to read the number of rows in the same transaction, you can get the different values because of the phantom reads case, right? Now this repeatable read is used by MySQL. Okay, after this we have serializable. Serializable is the highest level of isolation, and it guarantees like transaction behave as if they run one by one. So not like multiple transaction happening at the same time, it would look like one by one. So it's kind like serial order maintained, you can say. Okay, so it prevents everything. It prevents dirty reads, it prevents non-repeatable reads, it prevents phantom reads, and the lost update. So everything that we talked about, all the isolation problems, it prevents all of those. Okay, but because you are preventing that, there is a cost factor involved. Everything has a pro and con, correct? So if you're doing it kind of in a sequential order, so you're putting a lot of restrictions on that, you have to pay the cost for that. The cost is lower concurrency, of course, and more locking and coordination, right? Where do you use it? In the financial systems, seat bookings, and the inventory. Seat booking example we just saw, like there is one ticket only and multiple people are trying to book, so you can put this kind of isolation out there so that only one person can get the seat, right? All right, I know, I mean, a lot of information related to isolation. We started with acid properties and too much information on isolation. We discussed about the isolation problems and the isolation levels, but I told you that I'll also tell you a kind of a summary or a chart where I could relate the isolation problems with the isolation levels. So let's do it then. Why wait? Okay, so here you go. You can clearly see here we have the isolation level and the isolation problems out here. Okay, so first isolation level, read uncommitted. It allows everything. Okay, so it allows the dirty read, the non-repeatable read, the phantom reads. Next, the read committed, which is most commonly used. It does not allow the dirty read but allows other things. Okay, and after that we have the repeatable read, which does not allow the dirty read and the non-repeatable read. Talking about the phantom, it depends on the DB implementation. Some allow, some don't allow. So you can say it depends. Okay. But when we talk about serializable, it is the highest level of isolation. It doesn't allow dirty read, non-repeatable read, or phantom, right? So here you can say it would act as like one by one, not all of things happening together on one go, one by one. Okay, so I mean, not that difficult. If you see, you just have to create one chart. You have to write all the levels here from weak to strong, and then all three the problems right here. And after that, it's such a simple pattern. All tick here, just first one is a cross, all tick, and then just keep on increasing the crosses. So simple, right? One cross, two cross, three cross. There you go. Easy way to remember, but I feel still maybe hard to digest in one go. Don't worry, complete the video, think about it for some time, learn some of the things, do some of the things in DB, revisit the video, you'll get more understanding of it. So one thing here you could clearly see is like for the scenarios like the financial transactions or the seat bookings, the serializable looks the wonderful thing because it will make sure that we are not doing the double booking. correct? So all that scenarios it will cover. So in that way it's really great, the serializable one. But of course we cannot use it all the time as there are the cost factors involved in it as well, correct? Okay, so let's go through the last question related to isolation, and after that we'll switch to the next topic. Okay, the question is how databases implement the isolation. We talked about like all these level of isolations, but how the database implement this isolation. So basically there are two main techniques. First is the locking, where you can basically lock the rows, lock the table, or apply the range locks. Okay, and other technique is MBCC, which is multi-version concurrency control, where you have multiple versions of rows, where readers don't block the writers or writers don't block the readers. Okay, I won't go too much detail into it because databases we need to cover a lot of things. We also need to go into every type of NoSQL database and then time series database and much more, all the things that I need to cover. But I'll give you brief of both of these as well. Okay, so we'll just go in brief in these and then we'll switch to the next topic. Okay, all right, so when we talk about the first approach, which is locking, which is the lock based isolation, this is the old kind of technique, but of course this is an important one. So basically a lock is a permission to access data. Like you have some data, right, you want to access that. So if you have the lock, only then you can access the data. So based on that you can apply the isolation, correct? So say when a transaction touches a row, DB locks it. Okay, and other transactions must wait or fail. So you can simply imagine something like this. This is the row in the DB. So DB we said like there will be table, and inside table you have the rows and the columns. So this is the row, say. So transaction 1 comes here. So the DB applies the row level lock here. Okay. So in this row now we have applied the lock. So if a transaction tries to visit this row to read or update or any operation, I mean we can set all that things, but say we have applied lock here and it's trying, transaction 2 is trying to access this row, because it was already locked it won't be allowed. So transaction 2 won't be allowed, so either it needs to wait. If it can't wait it would fail. Okay, so if we talk about the types of lock, there are two types of lock. First is the shared lock, which is the read lock. As I said, like transaction 2 coming for read or write, so depends what kind of operation you allow it. So here it comes read locks and the write locks. The shared locks means the read lock, like multiple readers are allowed. Okay, so if here it was a read lock or the shared lock that was applied by the database, then if transaction 1 came for read it was allowed, transaction 2 came for read as well, that was also allowed because this is a read lock, reading is allowed. If transaction 3 came for the write operation, that won't be allowed. Got it? So writes are blocked in this, but multiple reads are allowed because read is not changing the data, read is just giving you value. So giving value is okay, right? Writing is making the problem when someone is reading it. So this lock is like read based locks or the shared lock. So you are allowed to read, multiple transactions can simply read, but if any of the transaction is reading, you're not allowed to write from anywhere. Got it? Okay, the second one is exclusive lock or the write lock. It means only one writer, and when one writer is there, any other transaction coming even for read or write, those will be blocked. Okay, so even reading is not allowed by another transaction when one transaction is doing the write operation. Got it? Yeah, I mean makes sense, right? So we won't go in too much detail of it, but you'll get the brief summary. What does this mean? Okay, so here is an example. Okay, so say the balance was 100. Okay, in the transaction 1 we are doing select, which means the read operation, balance from account. Okay, so it applies the read lock, this one, correct? The shared lock or the read lock. I mean read lock is easier to remember, even the shared lock makes sense, right? It's shared for reading, whereas exclusive log is like only one write allowed and others can't even read. Okay, so when transaction 2 tries to update the account, update means you are writing. Okay, create and update both means you are writing, so that will not be allowed. You can clearly say it is in the waiting stage, either it will wait or it will fail. Okay, then the transaction 1 commits. When it commits, the transaction will end, correct? So the transaction will end and it will release the read lock, and after that transaction 2 can update because the lock has been released. So this is an example of like read lock. You can clearly see when read lock was present, the write operation was not allowed. Now some of the issues with this can be like of course it can be blocking, right? You can clearly see transaction 2 was not allowed, so it blocked it. There can be deadlock. I'll show you one example of deadlock actually. And there can be poor concurrency. Concurrency, I mean, simply means like multiple transactions trying to access things at the same time. So here you blocked it or kept it in the waiting stage. So it reduced the concurrency, correct? Now let's see an example of the deadlock which we talked here. All right, here you go. Say the transaction 1 locks row A, okay, and it wants row B, correct? Which makes sense. It has locked like row A and it wants row B as well. But transaction 2 has locked row B. So A was locked by T1, correct? Now B was locked by T2, correct? And now T2, the transaction 2 wants row A. Now you can clearly see this is locked by transaction 1 and it wants this. This is locked by transaction 2 and it wants this. So clearly you can see there is a deadlock because both won't release anything and both will be kept on waiting or blocked or depending on each other. So what DB needs to do is like detect and kill one of the transaction. I mean, there are other ways as well, but yeah, you can see this is an example of deadlock happening here. Okay, so basically this was about the locking that we discussed. After this, next let's discuss about MBCC, which is multi-version concurrency control. Okay, as we said, like locking is the old way of doing things. MBCC is a new way. The modern databases, they prefer MBCC. Basically the core idea is that readers don't block the writers and writers don't block the readers. In locking we saw like two types of lock. One was read lock, another was write lock. In read lock the write operations were blocked, correct? And in the write lock even the read operations from other transactions were blocked, correct? So in MVCC that is not done. Instead of overwriting the data, database keeps multiple versions of a row. All right, let's try to understand MVCC with an example. Okay, so here you can clearly see as an initial state we said like in the row the balance was 100. So this was version v1 because we are going to maintain multiple versions as we are not applying any logs here. So the transaction 1 starts. So transaction 1 reads the balance, it will show the 100 from version 1, correct? And then the transaction 2 basically updates. So the write operation, it writes the balance as 150. So what we are doing is maintaining a new version, so it's a v2 now. So now database has two versions. V1 has value 100 and V2 has value 150. Now as we have two versions, who sees what? Transaction 1 will see the value as 100, transaction 2 will see the value as 150, and any new transaction coming will see the value 150 because there has been update in the value. So there is no blocking and there is consistent view. So basically it uses something as like the snapshot isolation where each transaction sees a snapshot of the database at the start time, right? This snapshot doesn't change during the transaction, correct? Like because here transaction 1 was still in progress, so that's why we don't want it to see the value which got updated during that transaction where T1 was going through. Like transaction 1 read the value 100. Now transaction 1 is not complete yet, and during that time transaction 2 has updated the value to 150. Now transaction 1 if tries to read the value again, if it sees the value is 150, then we go to the isolation problem that we discussed earlier, right? You are able to see different values in the same transaction. So here this versioning approach is helping us, and the snapshot isolation is coming into picture where the snapshot of the database at the start time doesn't change during the transaction. Okay, so T1 is not going to see the different value in the same transaction, but next time or any new transaction comes, it will see the updated value. Okay, and it also prevents non-repeatable reads that we just discussed. Okay, so it fixes that problem, right? So this was about MBCC. So using these two main techniques like locking and MBCC, the database can implement the isolation. Okay, so we discussed a lot about isolation, and which was part of the ACID properties, right? Atomicity, consistency, isolation, and durability. So the important part to remember again, ACID properties is one of the main core feature of SQL database. Okay, now let's move to the next topic related to a property or a feature in the database in general or specific to SQL database first.
Now let's discuss what is a transaction. So as we discussed in the ACID properties, a transaction is a set of SQL operations which are executed as one unit. Let's see an example here. Okay, here we started the transaction with begin keyword. Then this is an operation you can see where we are trying to update the seats. Then we are performing the insert operation, and finally we are ending the transaction with the commit. So all these operations are part of one transaction, and as we saw in Atomicity, if any operation fails, Atomicity means it will roll back all the operations to the initial state. Alright, before moving to the next topic, as we said earlier, SQL follows the ACID properties and the strict schema. So let's discuss about schema. What is a schema in brief? Okay, so schema means structure of a table. As we said, like in SQL, we have the table which consists of columns, right? So these will be your columns, and the rows, right? So these are the rows and these are the columns. Okay, now each of the column will also has the data types. So columns, data types, and the constraints that we discussed like in the consistency part of the ACID properties, constraints like not null, unique, foreign key, etc. So SQL is strict as it follows the schema. Okay, for example, if you see here, users is the table. Inside that you have this column ID which is of data type int, and it is the primary key. Then we have another column email, the data type is varchar, and few constraints that we have mentioned here, it must be unique and not null, right? So what are the pros of schema? You get the data quality and you get the predictable queries because your schema is fixed, so your queries are predictable. Now if we talk about the cons, schema changes is costly at the scale. So whenever you want to change the schema, like add a column or update some column, that would be costly at the scale. All right, after this, now let's move to another topic, which is indexing. So first question that comes in mind, what is indexing? So let's try to understand indexing in a very simple way. Okay, so say this is your book. Okay, now you know in the book, it at every page you have the page numbers, say 1, 2, and then 3, 4, and it goes on. Okay, say you have to go to page number 80, right? So you generally don't go one by one to each of the page. You don't go 1, 2, 3, 4, and like 79 pages swapping and then going to the 80th page. No, because we have the page number. We can clearly see the page number and directly we can shuffle to where we want to go. Say for example, you'll make a big swap. It will go to say page number 47, and then again you'll make a swap. Maybe it goes to 82, and then you can go 2 pages back and you reach to page number 80, correct? So basically this page number is helping you reach your required page quite fastly. Similar way, index is a data structure that helps the database find the rows faster. Okay, here we were trying to identify our required page. Similarly in DB queries, because you tend to return the rows or the data present in the row, so index is a data structure that will help in your read queries. Okay, so without index we will have to make a full table scan. Like for example, in this book, if there were no page number, we have to go one by one swapping each page, right? But with the page number, we have the freedom to do it faster. In similar ways, with index, we are able to return the read queries in much faster ways in log of n lookup time. Okay, so the next question, why indexing is needed? So like we discussed, if we don't use indexing, then we have to check each and every row inside the table, correct? So for example, say the query was select star from users where email equal to this. Now as it starts with select, you can clearly see this is a read query. Star means we are trying to fetch everything from the table name, which is users, and then we have the condition using the where keyword, where email is equal to this one. Okay, so now because we are talking about the case without index, so what DB will do is like it will check each and every row. Row 1 no match, row 2 no match, row 3 yes we found a match, and similarly it will go to each and every row. So we are basically checking all the rows in the table. Hence if there are n rows in the table, so the time taken for this query will be O of n. Now just assume the database which has millions of entries, so that will be so slow, correct? Now if we talk about the same query with the use of index on email, so we have done the indexing on the column email here, and you clearly know that in this query we have put condition on email only. Okay, so it will be quite fast using indexing. How? So we will directly check the index which is email, and that will point us to the row, just like the page number thing that we discussed. Because we can already see the page number, we can directly move or shift very quickly to that particular required page number. Similar to that, here we did the indexing on this particular column email, and we did the query here on the email only, so it becomes very fast. So using the indexing, we reduce the query time from linear, which was O of n, to logarithmic, which is O of log n. So few important things that you observe here is we do the indexing on the column. So here we did the indexing on email column. Another important part to remember is that this query became quite fast because the query was on email and we did the indexing on email as well. Okay, so there was a kind of match, you can say. But if you do the query on the column which is not indexed, query won't be fast. Okay, we will discuss about it in this video more, but before that, let's check how index works internally. So in the beginning we mentioned that index is a data structure, right? Let me show you. We said index is a data structure that helps DB find rows faster, correct? So saying that again, index is a separate data structure, okay, which is stored separately from the table data. Say for example, this is your table which has columns and rows. So in rows you have the data, correct? So when you index based on some column, say for example we index based on this column, so this part of indexing is stored separately from this table data, and it contains index column value, and corresponding to that it will contain the row pointers. So like we indexed basis on email, correct, in this case. So what we will store is something like this. This is the value of the mail a@gmail.com, and corresponding to that we have maintained the row id. What is the id where this value is present? So that's why when we did this query, correct, like select star from users where email equal to this, now because we have indexed based on email, we already have this information. Okay, so that is why it's so quick, because we directly see, okay, we want this, and this will be present at row id this, so we can directly go to row id 1523 instead of scanning the complete table, correct? So you can clearly see, instead of going to each and every row without indexing, we would have done row number 1 2 3 4, goes on goes on goes on, row number 1520 21 22 23, we found a match, and further it will go on and scan all the rows. Whereas using the index, we have already corresponding to this value, we have these rows. Okay, so we go to the row number 1523 and we'll get the value, and we will return all the rows which has this value, right? So this is how index makes things so easy and quick, because we are storing that data, which is a separate data structure, separately from the table data. Now as we said, index is a separate data structure, but which data structure? So mostly for indexing we use B tree data structure. But why B tree? Because it is balanced, it keeps data sorted, and it is efficient for the operators like equal to, smaller than, greater than, between, order by. So SQL or relational databases mostly use B tree indexes. Alright, as we mentioned earlier, we'll do indexing on particular column of the table, right? But apart from that, we can also have like composite index, where we do indexing on multiple columns. For example, if you see here, we have done the indexing on two columns, user id and the created at. So more than one column, hence this is a type of composite index which is allowed. But when you have this multi-column index, you need to keep in mind about an important rule, which is leftmost prefix rule. Now this means like if you do the query, okay, so index works on user id, that's totally fine, and it also works when you apply both in the query, user id and the created time. But it will not work when you query specifically on the created at time. okay, because that is on the right side. So the rule that we follow in the composite index is that leftmost prefix rule, because user id was on left, so even if you query based on user id, that would work and that would be quite fast. If you query on both user id and created at, that would also work, but if you do only specific to the created at column, then it won't be fast. Indexing won't work in that case. Okay, so keep in mind this leftmost prefix rule when you have multi-column index or the composite index. Okay, so earlier we discussed that the use case of indexing is that you get very fast query results for the read queries, correct? But what is the trade-off or what is the con of indexing? So the problem is that indexing can slow down the writes. But why is it? Why indexes slow down writes? This is because with every write you must need to insert into table, of course, because you are writing the data, but at the same time there would be an additional step because you have maintained the indexes, so you will have to update all indexes as well, correct? So that's why now with the write operation you are performing one more extra thing, so that is why it will slow down the write operation. So when we talk about the insert operation, which is the write operation, it will become slow with indexing because you have to perform this additional step. Similarly for update, it will be slower as compared to without indexing because again you have to do the step, and same is for delete. So the main point to remember is indexes improve the read performance but at the cost of write performance. Okay, so for indexing you have the pro part that you will get the faster read queries, but it can slow down your write operations. Okay, so that is the con part. All right, now comes the next question, which is when not to use the indexing or when indexes are not used. Okay, so in these cases indexes are not used. First one, when column has low cardinality. Now what does that mean? Say for example the column is gender, okay, and it has values like male and female. Now if we use indexes on that, it won't be useful, right? Because as I gave you an example related to index, like here if you see corresponding to the value we have the row id, okay, but if we have the low cardinality, which means male or female, then we have only two values, m and f, and you can assume like this would contain like somewhat around 50% of rows and this would contain around 50% of rows. Of course, I mean the numbers can vary, but the probability factor 50-50%. So indexing is not that helpful here because you have so many rows respective to each of the value, right? Okay, the second one is query using the function. For example, here you can see we have used the condition on email, but we have used the function like lower here. So here the indexes are not used. Another case is where we use the wildcard. So for example, here you see we have made the condition like, but before abc we have put like percentage. Now percentage abc means something like mabc is also allowed, right? And tabc is also allowed. So anything is allowed before abc, so this is a wild card, and on this situation indexes are not used. And the last one is where the table is small. So if the table is quite small, I mean indexing won't make much of the difference because you could also scan the table in quick time. So in these cases we don't use indexes. First one was cardinality, which, and cardinality means number of unique values, you can say. So the number of unique values for the column gender will be quite few, so that's why in that case indexes are not useful for this column. Now after this, the next question comes into mind is like, what should be the indexing strategy, or on what basis should we decide the index? Basically when you are designing the indexes, you need to ask which queries are frequent, which columns appear in where, because as we saw, if a particular column is appearing in where clause and if we have put an index on that column, it can become quite fast, right? And frequency is also really important because our main purpose of using the index is that we can fasten the read queries, and it makes sense only if those queries are quite frequently used. Then the next one is which columns appear in join. We'll talk about joins later in this video, so don't worry about that point for now. And the last, which columns appear in order by. So order by is used for sorting, but if index matches the order, no sorting is required. So based on such factors, you decide your column on which you'll apply the index. Like if we take an example of Bookmyshow, we'll think about the index based on the queries, okay? So say for the users table, we mostly find out the user by email. So we will put the index on the email column. Okay, and then in the bookings table we get the bookings by the user, so we put the index on the user ID. And then in some other table we get the shows by city and date, then we put the composite index, which is the index based on multiple columns, and that will be on city and date, right? So similar to this, you will decide your indexing column for the table. Okay, so after this, the next topic that comes is like index maintenance and monitoring. Now, first of all, why is this required? Because too many indexes will result in slow writes. We saw that the indexes improves the read queries but slows down the write operations, right? And at the same time, if you have unused indexes, then it's kind of a waste of money. But the question comes is like, how will you get to know if an index is getting used or not? So for that, we can use this explain analyze, and through this we will get to know if an index is getting used or not. Now basically, when I understood about indexing for the first time, I had few questions in my mind, so I'll go through those questions so that you get more clarity about indexing, because you also might have the similar kind of questions in your mind, right? So the first question in my mind was like, we mentioned that index is stored separately from the table data, right? But where is it stored? So the indexes are stored on disk inside the database storage engines only, but not with the table data. Okay, so if we talk about the physical storage view, both the table data and the index data live on the disk, which can be SSD or HDD, and both can be cached in the RAM. Okay, so if you see, this is the disk. Inside this you have this table data and then the index pages. Both are on the disk, but both are kind of separate. Index pages are not stored in the table data, those are kind of separate, but in the disk only. Okay, so the main point to tell this is like, index is not stored in the row of the table. Index is stored as a separate data structure on the disk. And as we discussed earlier, the data structure used for indexing is generally the B trees. Alright, after this, the next question that was in my mind was how database uses index during the query execution. We said that indexing will make the read operations quite fast, but how does that happen? Okay, so the same example that we used earlier, select star from users where the email is equal to this email, right? So this is the read query. And now say we have done the indexing on the email column. So how will that help? So first of all, DB will check if the index exists. Here, as we said, we have done the indexing on the email column. So it will traverse through the B tree, because as we know that the index is stored in the B tree data structure. Okay, and through that it will find the pointer, and once it finds the pointer, through that it gets the row ID, right? So it will fetch the row from the table, right? So another thing would be, if the index is cached in RAM, then of course it will be very fast, because you will directly get the index, and from that you'll get the row ID, and you can directly fetch the data from table respective to those row IDs. In case it's not present in the cache, then as we did, like, it will fetch it from the disk IO. Okay, now after this, the next question on indexing is, will too much indexing cause issues? The answer is yes. Now let's see why. The first thing, as we said, like, the indexing can degrade the write operation performance. So too much indexing can degrade the write performance. Now, because whenever we do the insert, update or delete, apart from modifying the table data, we would also need to update all the indexes. So say for example, for a table there were 10 indexes. Okay, so then you have to do 10 updates after every insert, update or delete operation if that impacts the index. Hence the write operations will become quite slow. Second point, as we said, like, index uses the separate data structure and it is stored separately from the table data, so indexing will increase the storage usage. So for large tables we may result in huge index data. Third point is, if you have so many indexes, there is high probability you will always get a cache miss, because every time you check in the cache, something other would be present, as you have so much index data, correct? So high probability is you have to always check from the disk read, and that won't be that fast. And we used indexing for like fast results, but if every time we have to check through the disk read, it won't be that fast. Similar to that, one more thing could be like, as we said, from index we can directly go to the row. Now if you have so much data out there, so much indexing done, then it might be possible that you have too much data, and it means that it is not actually making the final read query that fast. So we used indexing for making things fast, but if you have so much data, then of course it might not help in making it fast. And lastly, because you have so much indexing done now, you have to also take care of the maintenance overhead related to the indexing. So long short in answer, yes, too much indexing will cause issues, and we should be mindful while creating the indexes. Also, we can keep something like this in mind. If your system is write heavy, then of course you should have very few indexes, because the role of indexing comes in fastening the read queries. And as we know, indexing will slow down the write queries. If your system is write heavy, then indexing is not helping you. Whereas if your system is read heavy, then of course you can have more indexes, because the role of indexing comes in making the read queries quite fast. But at the same time, we need to make sure that we are not keeping too much indexes, right? So if our index is not getting used that frequently, or there is low cardinality, or your table is write heavy, then you can remove those indexes. All right, so this was about indexing. Now let's move to the next topic. Now next, let's discuss about normalization. So the few questions that come into our mind related to normalization are: what is normalization? Why do we need normalization? So let me explain it to you in a very simple way. So this is an example without normalization how we would save the data. So we are talking about the orders table. Okay, it has fields like order ID, username, user email, product name. So clearly you can see this table has all the information related to order as well as the information related to user as well, because it also contains user email. So if you see here, the first row, it says order ID 1, username is Rahul, and user email is r@gmail.com, and product name is iPhone. Okay, and the second row, it's like order ID 2, but it's for the same user. So the username is again Rahul, and user email is r@gmail.com, which is, you can see, same as the first row, but the product name is AirPods here. So clearly, as one user can have multiple products, right? So here Rahul has two products, one is iPhone and the AirPods. Now what are the problems here? So say if Rahul changes email, okay, then basically what we need to do is like we need to update multiple rows, because multiple rows contains this information of email address of Rahul. Clearly the email address is same, but it is present in multiple rows. So whenever we are updating it, we need to make sure that we update all of those rows, otherwise there will be data inconsistency. So if we do one miss, it will be inconsistent data. Just imagine in one row we are writing rahul@gmail.com, and in another row it's like r@gmail.com. So clearly that would be inconsistent data. But the basic logic, if you see here, is like without normalization, the simple thing is like we are keeping all the information in one table, right? You could see here we had the order related information, which contained product name as well as at the same time we also had like user related information, like user email is also part of this table. So we have kept all the information in one table, and this is without normalization. So we can clearly see the problems associated with it. Now let's see how we will solve it with normalization. Alright, so with normalization, what we are going to do is like create separate tables. Like one is for users and one is for orders. So we have separate tables. In users, we will have the user ID, name and email. Whereas in orders, we will have order ID, user ID and product ID. So you can clearly see now orders table does not contain the user email, because that is part of the users table. Now by separating the tables, we would remove this case, correct? Because now r@gmail.com won't be present in orders. It will be only present in the users table, and there will be only one row for that: user ID, name Rahul and email r@gmail.com, and here we will simply use the user ID. So clearly you can see without normalization there was redundant data, correct? Because here you can see we repeated these stuff like Rahul r@gmail.com in multiple rows in the orders table, whereas if we keep that information in users table, that will come only once. We will simply use the user ID, that's it. So with normalization we have single source of truth, safe updates, because we will simply update in the users table now if we have to update the email of the user, and there will be only one row, so we won't have this issue of updating multiple rows, correct? And hence there will be data integrity. So using normalization, we have reduced the redundancy, and it has also removed updating multiple rows related issues. So basically, if I say what is normalization, so normalization is organizing data by, you can say, separating out the tables to avoid the duplication and inconsistency. So you can clearly see without normalization you had so much of duplicate data, and by doing the normalization you have separated out the tables and the duplicate data will be reduced, correct? And at the same time it would also avoid inconsistency, which was happening without normalization because you had multiple rows. So if you had to update the information, you had to update in multiple rows, and just in case if you miss one of those rows, there will be data inconsistency. But now because with normalization you have separate entity in which this record would exist only once, so this issue won't come. You would simply update that particular row related to user, and hence the normalization will reduce data duplication and data inconsistency, right? So coming back here, so normalization is like one fact should live in one place only, correct? So here without normalization you could see this data was getting repeated multiple times, it was present multiple times, whereas when we do normalization this record would be present in the user's entity only, okay? So using the normalization we are providing kind of single source of truth. Without normalization, same data will be stored in multiple places, and due to that updates become risky, bugs appear, and data become inconsistent. And when we use normalization, we separate out tables. Using that, we remove all of these issues. Now if you know about normalization, you might also know that there are multiple normal forms like 1NF, 2NF, 3NF, which kindly acts as like the gradual improvement that we can make in our structure or schema of the database, right? So the question comes like, what are the various normal forms when we talk about normalization? Alright, so there are multiple normal forms. We'll start with the beginning one, which is the first normal form, or 1NF. Okay, it's a gradual process only. You don't shift directly to the last one. You have to go step by step, okay, because we have to update or change the schema of our database. So we start with the first step here. So every normal form will have its own set of rules. For 1NF, the rule that is most important is that each cell has a single value. You need to focus on that. We'll see an example through which you will get more idea, okay? So this is an example which is not currently in 1NF form, okay? Here you can see we have user entity which has columns like ID, name and phones. So the data in row is ID is 1, name is Rahul. Phones, you can see there are multiple phones which are separated by comma, okay? And the rule that we defined in 1NF was each cell has a single value, but here you could see in this we have multiple values separated by comma. So this is not in 1NF. So how can we make it in 1NF? We can basically keep only one value in the cell. So it will be something like this, user ID phone, and you can see we have separated the phone numbers. User ID is same but phone number are different. So here you can see we have created a new table, new entity, user phones. Why? Because if we keep the same data here, then there will be data duplicacy. It would become something like 1 Rahul and 9876. Now about the second row, if this is just the ID as a primary key, then we would put 1 2, but if this is the user ID just like this, then of course we would make it same 1 1, and then the name would also be Rahul and the phone number is 9123, correct? So here you can see the user name is getting repeated, correct? So duplicate data. So it creates the same issue. In order to avoid that, we have created a new entity, user's phone, which only contains the user ID and phone number, right? So it does not contain any other information related to user like the username, email, all such things are not present here because this is specific to the phone number. And here you can clearly see we have separated out the phone numbers. So this is not in 1NF and this is in 1NF, okay? So what problem have we solved? If we do like this, there would be duplicate data, and now using this format we have removed the repeating values, okay? And another thing is like we have non-atomic columns, that is each of the cell has only single value, Okay, so in 1NF you want atomic values, no repeating groups, and each cell has a single value. Right, so here in 1NF we saw that we created a separate table out here, but it's not the major requirement. The major requirement is to have that each cell has the single value. So instead of this, even if I do something like this where the basic thing is each cell has single value, this is also in 1NF. Okay, so the major thing in 1NF is each cell should have the single value. Alright, so after 1F let's move to 2NF. Okay, so 2NF is the second normal form, right? 2NF, right? So what are the rules which are required for 2NF? Like we saw for 1NF, there were rules like atomic values and each cell has a single value. And similar to it, in 2NF, the first rule is your table must be in 1NF. So as I told you earlier, the normal forms are kind of gradual improvements that you have to make. It's not like you will directly move to the last step, so you have to do it step by step. So in order to be in 2NF, first you must be in 1NF, so you need to follow these rules first, right? And then you can think about 2NF. So first is this, and the other part is there should be no partial dependency on the composite key. Now what is a composite key? We discussed about the primary key in the table. The primary key makes each of the row unique, correct? Now if the primary key is not just one column, it is multiple columns, then it becomes like a composite key. That means like we have multiple columns which make a row unique. Okay, so the rule of 2NF is that there should be no partial dependency on the composite key. Now what does this mean? It means when a column depends on a part of the composite key. Say you have two columns as a composite key, okay, the column 1 and column 2. If one of the column in this table has the dependency on one of these composite keys, not on combined of these but only one of these, so that is partial dependency. So in order to be in 2NF, there should not be any partial dependency on the composite key. Let us see with an example through which you'll get more clarity. Okay, so for example, we have this table orders items. It contains order ID, product name, and quantity. Okay, so in this, the product name, this column basically depends on the product ID because both of these are related. So the product name will be dependent on product ID. But here we have the composite key. The combination of this order ID and the product ID is the composite key for this table order items. Okay, so you can clearly see, so product name has dependency on product ID but not on combined this composite key, correct? So this was our composite key, but product name has partial dependency because it doesn't depend on combination of order ID and product ID. It just depends on the product ID. So clearly you can see we have partial dependency here. One of the column is having the partial dependency on the composite key. If this product name was dependent on combination of this, that is a composite key, then there was no issue for 2NF. But this is depending on one of the columns of the composite key. Right, so how can you solve that? You can basically create separate tables. We have products table as a separate one apart from the orders items. In the products table, we'll keep the product ID and product name. Now product name depends on product ID, and here now we have only the primary key. There is no composite key, so this is totally fine. And in orders items, we will keep the order ID, product ID, and quantity. So there is no product name out here now. So this issue is completely resolved, right? So basically creating a separate table, you have removed this partial dependency, correct? So we have removed the partial dependency here. We have also solved the data duplication here. So using this, you have made your table in 2NF. So the rules for 2NF, again as a revision, it must be in 1NF and there should be no partial dependency on the composite key. Alright, so after 2NF, let's move to the next form, which is 3NF or the third normal form. Okay, so what are the rules that are required to be in 3NF? First rule is you must be in 2NF. So to be in 3NF, first you must be in 2NF and there should be no transitive dependency. Now what is a transitive dependency? It means that a non-key column depends on another non-key column. Okay, let's try to understand this with an example. Okay, so this table is currently not in 3NF. So here we have the users entity. It has the user ID, city, and the pin code. Now clearly we can see city depends on the pin code, but both of these are non-key column. here the user ID is the primary key, correct? Both of these are non-key columns, but city, a non-key column, is depending on another non-key column, which is the pin code. So due to this is currently not in 3NF. And how can we convert it into 3NF? By creating separate tables. Here now you can see, apart from users table, we also have the cities table, which contains city and pin code. Now again, we know city depends on the pin code, but here we have only two columns and one of these will be the key column, correct? And the other entity, users, now only contains user ID and the city. It does not contain the pin code. So this is how we have basically made it in 3NF, because now there is no transitive dependency, which means there is no non-key column which depends on another non-key column. So with this, we have solved the hidden dependencies. I know there might be confusion in your mind, but don't worry. After this, basically I'll show you an example through which I'll show you how to make it in 1NF, 2NF, 3NF, all the forms one by one. Now after 3NF, do we have 4NF? Not actually. After 3NF, we have like a stricter version of 3NF, which is said as BCNF or Boyer's code normal form, but this is kind of bit advanced and it is used when there are multiple candidate keys and there is complex dependencies. So generally we don't go to this level, so we can ignore this for now. Otherwise it can become really complicated. So let's ignore BCNF for now, but just in case if you want to know more about it, put that in comment section. I'll cover it somewhere in another video. Okay, but for now what I want to do is like I want to show you an example where we want to convert a table which is not normalized to the normalized form. So we want to make the gradual transition to 1NF, 2NF, 3NF, so that you get more clarity how can you basically do the normalization. Okay, all right, so this is our table which is not normalized, or we can say 0NF. Clearly you can see we have the orders entity here and it contains the columns like order ID, customer name, customer phone, and the products. So clearly you can see this is not in 1NF because a cell is containing multiple values like laptop, comma, mouse, keyboard, comma, mouse. So there are multiple values which are present in a cell. Okay, of course if it is not in 1NF, it cannot be in 2NF and 3NF, correct? So let's first convert it into the 1NF. all right, so we have converted it into the 1NF. What we are going to do is like simply make sure that each of the cell contains only one value. So same thing that we are doing here, just we are splitting this. So instead of laptop, comma, mouse, we would make it two rows now. Same data, all of this, just it has laptop, and again same data, it has mouse. Then the phone one was already correct because it had only one value, but this had two values, so we would split it into two rows. Now this part would be common in both of these rows, but the product value would be keyboard in first and the mouse in second. So using this way, we have made this table or entity into 1NF because each of the cell contains only one value now. Right now this is in 1NF, but is it in 2NF also? Here if you see, what is the primary key? We have the composite primary key here, the user ID and the product. The combination of these two make as the composite key, because through that we are making each of the row unique. So for example, 101 laptop, 101 mouse, then 102 phone, then 103 keyboard, and 103 mouse. So combination of these makes the record unique, hence we have the composite key here. But if you observe here, customer name, customer phone, they only depend on the order ID, they are not dependent on the product, correct? So clearly you have the partial dependency on the composite key. The composite key was order ID and the product, but the customer name or customer phone only depends on the order ID and not on the product. So there is a partial dependency on the composite key, and hence it is currently not in 2NF form, correct? So what we need to do is like convert it into the 2NF form. All right, let's see how to make it in 2NF. We can do it by splitting it into multiple tables. Okay, so instead of all this information in one table, what we are going to do is like split it. So this was our table, orders table, and you can see we have split it now in 3 tables. It had information related to customer, so we had made a separate table customer, and then orders table is there, and then order items is another table. Now let's see what we have done. Okay, so first of all, here you can see we have the customer table, which contains the fields as the customer ID, the name, and the phone number. Okay, then we have also 2 other tables, orders table and order items table. The orders table contains the order ID and the customer ID, whereas the order items table contains the order ID and the product. So clearly you can see now there is no partial dependency here, right? So that is why this is now in 2NF form, right? So you can clearly see from this, where we had the order ID, customer name, customer phone, product, we converted it into the 3 table. This is quite understandable because the customer information should be in a separate table. And apart from that also, this orders ID, which contained like order ID, product information and customer information, instead of that we have separated the product information and the order information in 2 different tables, right? So this table contains the order ID and product, and this contains the order ID and the customer ID. So this makes sense, right? Now we have to see if these are in 3NF as well. So in 3NF we had like there should be no transitive dependency, which means there is an issue if a non-key depends on another non-key. Here if we see, this is already in 3NF, this is also already in 3NF. If we talk about the customers table, the name depends on the customer ID, but customer ID is your primary key, so it is not the non-key. And similarly, the phone depends on the customer ID, and again customer ID is your primary key. So this is also in 3NF. So we don't need to make any changes further. This is also in 3NF, and this is done. Okay, so this was one of the example. You can clearly see we started from here. We had all the information in one table: order ID, customer name, phone number, product. So one table had information related to the order, the product and the customer, and due to that we were facing the issues. And from this we have converted to this. You can clearly see we have a separate table for customers, we have a separate table for order items which contain the information of order ID and the product, and we have a separate information on the orders table where we have the order ID and the customer ID. Okay, so this was the first example. Let me show you one more example through which you will get more clarity how you can convert a 0NF to like normalized form. Okay, all right, so this is our second example. This is in 0NF. You can see this is a table, and the name of table is student course. It contains the student ID, the student name, courses, instructor and instructor phone. Okay, so all the information is present in one table. You can see it contains the student information, the course information, and even the instructor information, everything in one table. Now let's see if it is in 1NF or not. Clearly it is not in 1NF because one cell contains multiple details like math, physics, physics, chemistry, and hence it is not in 1NF form. So first let's convert this table into 1NF form. Simply what you need to do is like each of the cells should contain only one information. Okay, so we will separate out this information in another row. So other data will be, you can say, duplicated, but the courses will contain only one value. Alright, so we have converted this table into the 1NF form. Clearly you can see we have kept all the columns as same to same, just that course, you can see instead of having multiple values, it has only one value per cell. So one Rahul, math, Sharma, 9999, and now instead of math, physics, we have a new row. This data is duplicated, but this has a new value physics. Okay, similarly to this one, we have separated out physics and chemistry in the separate rows, and through this we have made it in 1NF, which is first normal form. Okay, now let's see if this is in 2NF or not. First of all, let's see if there is a composite key here. So of course we have a composite key here, which is a combination of student ID and the course. So student ID and course make things unique: 1 math, 1 physics, 2 math, 3 physics, 3 chemistry. So student ID and the course make the composite key, correct? Now for 2NF we have to see there is no partial dependency. Okay, so we need to make sure none of the column is having a partial dependency on this composite key. But here you can clearly see the student name field is dependent only on the student ID. Student name is not dependent on the course. Similarly, the instructor and instructor phone are dependent only on the course and not on the student ID. So clearly you can see there are multiple partial dependencies here. So this is currently not in 2NF. Why not in 2NF? Because student name depends on student ID, but the composite key was student ID and course. So the student name is partially depending on the composite key. Similarly, the instructor and instructor phone are partially dependent only on the course and not on the student ID. So we need to convert it in the 2NF. Alright, so this was 1NF. Now these are in 2NF. You can clearly see we have split the table into multiple tables. Here we had data related to student, course, instructor all in one table. Now we have split into 3 tables. First is the students table, which contains information like the student ID and the student name. Then we have the courses table, which contains the information as a course and the instructor and instructor phones. And then we have the enrollments table, which contains the information as the student ID and the course. Right now this is in 2NF because there is no partial dependency on the composite key in any of the table. Okay, so that is why this is in 2NF form. Here we had the partial dependency on the composite key. Here there is no partial dependency on any of the composite key. In first table, this is the primary key. In second table, course is the primary key, and both of these form as the composite key, but there is no partial dependency. Okay. Now let's see if these 3 tables are in 3NF or not. So the rule of 3NF is that there should be no transitive dependency. That a non-key is depending on another non-key, then it's an issue, correct? And that can happen in this courses table. How? You can clearly see the instructor phone number depends on the instructor, and both of these are non-key. In this table, the primary key is the course, but the instructor phone depends on the instructor, and both of these are non-key. So what we need to do is like create another entity which would be the instructor entity, and that would contain information related to the instructor, right? So what we will do is like create another entity out here which would be something like the instructor. Okay, instructor would be the entity, and inside that we will have both of these fields, instructor and instructor phone. You can also keep instructor ID to keep things simple, but just in case if we are ignoring that for now, what we can keep it in that is like the instructor. Okay, and this would be the primary key, and the other column would be the instructor phone, right? Instructor phone. Okay, so this would be the primary key, and basically this depends on this, so it will have information like Sharma first, and it will have the number as 9999, and the second information would be the Verma, and the information would be 8888. And what we will do is like we will remove this instructor phone from this entity. Now we will have like 4 entities. First is your students, second is courses. Courses only contains 2 things, course and the instructor. Then we have the enrollments, which has student ID and course, and then we have the 4th entity, which is the instructor, which can contain instructor and instructor phone. Now using all 4 of these entities, this is now in 3NF. Okay, because now there is no transitive dependency, and clearly you can see we started with here this table had information of the student, course, instructor, and it was not normalized, and we converted into the 3NF form by the 4 entities: students, courses, enrollments, and instructor. Okay, so this is how you will basically normalize your table. Now basically we talked about 1NF, 2NF, 3NF, and the advanced format BCNF, which we ignored for now. But the question that comes into mind is like, do we always normalize fully? Like we discussed about 1NF, 2NF, 3NF, and BCNF. So do we always need to normalize till the last level? The answer is no. Let's try to understand why. So we clearly saw that with normalization, what we are doing is like we are creating separate entities. We are splitting the table into multiple tables, correct? So what will be the problems of over normalization? We will have to make too many joins. Now of course we need to still discuss about joins later in this video. Maybe just after this topic we'll pick the joins, but for now, to make things simple, it is something like, say for example, you have two tables, okay, this one and this one, and if you need the data from both of these table, of course then you will have to join the data from first table to second table. So you will have like different queries through which you will try to join the data, because now data is split into multiple tables. So you will join the data across multiple tables, and then of course it will result in slower read performance, right? And again you will have complex queries. Very simple example, say you had this one table which had all the data, so denormalized you can say. So it is not currently normalized, but it has all the data. So one row can contain all the information, so simply you will make the read query and it will give you all the data. But now just imagine this is normalized, so you have say 3 tables, and now if you want to get all the data, now of course you need to make complicated queries where you need to join all the data from different places, right? So this is a result of over normalization. You get this problem that you have complex queries and slower read performance. So that is why in real life you don't always normalize till the last level, okay? So what do we do in real life? We basically normalize for correctness, because we also saw what are the problems that happen if you keep all the data in one table, right? There can be issues like data duplication, and when you try to update, there can be a problem that you have to update multiple rows, otherwise there can be data inconsistency. So you normalize for correctness, but then you selectively denormalize for performance. Now what does this mean? Same as this thing. Now say for example you have kept like 5 tables, right? And you have to get the data, so you would have to write complex queries and join the data of like 5 different tables, so that would be quite slow. Now that would degrade your performance. This means that you would pick the things, like you will selectively denormalize some of the thing, and some of the data you will keep together so that you have like quick answer responses, because at the end user you have to show the response or the data correctly, and at the same time it should be very quick. So for end user it doesn't matter if you're keeping 1 table or 5 table or 100 tables. For them it matters is like it should be quick, and for quick you need to also do selective denormalizing, which means like you are also keeping some of the data together, correct? So the simple answer, we don't normalize till the last level always, right? We will normalize for correctness, but then also selectively denormalize, which means keeping data together for the performance. Okay, so now on the basis what we discussed, in your mind there might be a question which would be like, when to normalize versus denormalize. So normalize when your systems are like write heavy, because as we discussed, the problem comes in like reading. You are reading through multiple tables, you are joining the data, complex queries, but if your system is write heavy, then normalizing it makes more sense. And when the data consistency is critical, we were doing the normalization so that there is data consistency and there is least data redundancy. Okay, so normalization was removing the problem of data inconsistency. So when the data consistency is critical, you should normalize. And for the financial systems, because in there the consistency is very important. Now when to denormalize? When your system is read heavy. Of course, if your system is read heavy and if you have like 7 tables and you have to get data from all of these, then it will be quite slow, right? So in that case you need to denormalize. Means most of the data in one table only, right? Another would be the analytics and feeds and the caching layers, all of these places where you want the data very quick. So in that you need to denormalize. Okay, all right, so we discussed about normalization, and in SQL we do normalization so that data remains consistent. Okay, so we use normalization in SQL, but as we discussed, when we do normalization we will have multiple tables, and when we want to get some record, fetch some record, we would have to join the data, right? And for that we use join. So now let's discuss about join. Okay, so the first question that appears in the mind is, what is a join? So as we discussed in normalization, we would have multiple tables, correct? And if we want the data, so we would have to combine rows from 2 or more tables using some relationship, and that is join, right? Because now data is present in this table as well as in this. We want the joined data. So for example, say one table has ID, another table has details. So we will join and bring the data together. Like this, we have users table and orders table. Users table will have the information related to user like user ID, phone number, name, whereas orders will have the information related to the orders made by that user, correct? So we will pick the user ID from users table, and then we will find out the data from the orders table related to that particular user ID. Don't worry about it, we will discuss with examples about join in this video. Now the next question that comes in mind is why joins exist. So without joins or without normalization, you can say there will be data duplication. As we saw in case without normalization, there was duplicate data, correct? So without joins and the normalization, there would be data duplication, there would be inconsistency in data because the same data is present in multiple rows. If by any chance you miss any particular row while updating the records, there will be data inconsistency. And also because we would be keeping all the data in one table, so the table size would be huge, so everything would be present in one single table. So that is why we do normalization. We would have multiple tables, and to get the complete data we would require joins, and with joins we will add the normalized data. So basically, because the existence of the concept like joins, we can do data normalization. So we have multiple datas as we have the logic to join the data as well, right? So through this we will have single source of truth and flexible queries. So join is a kind of logic through which we can fetch and join data from multiple tables. Now join can be of multiple types. So now let's check what are the core join types, and let's try to understand those with examples. So we have these type of core join types: inner join, left join, right join, full outer join, cross join, and self join. Now one by one, let's try to understand each of these with example. And in order to understand very easily, we'll take this example, these two tables for all of these, okay? And I'll show you what will be the output using inner join, left join, right join, full outer join, cross join, self join. So these are the two tables. You can see table 1 has like user related information and table 2 has like order related information. Now of course we need to do join because using the user ID we can fetch some data related to orders, correct? So we need to fetch the data combining both of these tables, so we will use the join queries, but we will use the same example throughout so that you have clarity, and we will see the different output coming based on what kind of join we apply on these. So I'll show you the queries and the output accordingly, okay? So we have two tables, users table and the orders table. So first let's start with inner join, okay? Basically inner join will give you only those rows that match in both the tables. So as you remember, these two tables we know, like users table and orders table, and we will apply the join on these two tables, okay? Now first of all, let's see what is the query for the inner join. Basically we want to fetch the data combining both of these tables, and we have to apply the inner join. So let's see the query. All right, so this is the query for inner join. First we write select because we want to read the data or fetch the data, correct? And then we do u.user id. Here u is representing this users table actually, because you can clearly see it says from users u, okay? So you are representing that users table with u because you are going to use it multiple times. Instead of writing users.user id, users.name, so you are giving it a short form u. And similarly for orders, you are giving short form o, okay? So you are writing select u.user id, so you want this column user id and username, both of these columns you want, and then you want o.order id, so this column, and o.amount. So all these four columns you want in your response, okay? From users u, and you have written here inner join, correct? This is the first type of join that we are discussing, inner join. So we have mentioned inner join here. So from table users and inner join on orders table, okay? And what is the condition that we have given? On u.user id equal to o.user id, right? So now because in inner join we said like it will return only rows that match in both the tables. So basically it's kind of intersection. We have to see where both of the things match, okay? We have applied on the user id. You can clearly see 1, 2, 3 present in users, whereas the user id present in orders is 1, 1, 4. So you can clearly see there is a match on 1. 1 is present in user table as well and the orders table. So basically we found a match on 1. There is no 4 present in the users table. So that will not come in inner join. So what will be the output now? So you can see we wanted these 4 columns. So these are present here: ID, name, order ID and amount. Okay. And only the part which is common in both, which match in both, which is this user ID 1. So only that will be in the output, user ID 1, user ID 1, because we had 2 rows in the orders table. So both will come, both will have name as Rahul, right? Order ID as 101 and 102 and amount as 500 and 300. Okay. So based on this, you can clearly see inner join basically means kind of intersection, or you can say the rows that match in both of the tables. And this was a query through which we got this output. Okay, so we use this inner join keyword here. But the main part to remember, in the output we had only those rows which had a match in both of the tables, correct? So you can clearly see we did not print 2, 3, 4 because they were not present in both of the tables. Only 1 was present in both of the tables, and hence in the output user ID related 1 is displayed and nothing else is coming in the output. Okay, so this was about the inner join. Next, let's discuss about the left join or left outer join. We are keeping the same example here, users table and the orders table, and we will now apply left join on it. Now what does left join mean? It means all rows from the left table and matching rows from the right table. Okay, so you will get all the data from the left table and the matching rows from the right table. So let's first see the query of the left join, and after which we'll see the output. Right, so this is the query of the left join. Similar to the inner join, first we write like select and then we write the name of the columns which we require in the output. So user ID, name, order ID, amount, same as what we did in the inner join. Then from users u, so this is your left table, correct? So we mentioned in the rule everything from the left table and only matching rows from the right table. So this is your left table, and then you write the keyword left join and then the table name orders, which is your right table. Okay, so left and right table you have here, and then the condition on the user ID matches in both. Okay, so what we want to return is like all the data, all the rows from left table and the matching rows from the right table. So basically you will get the data for user ID 1, 2, 3, and then from the right table wherever there is a match. So match comes at this user ID 1, 1. So 4 is not a match, correct? So data related to 4 will not come. So here is the output. Okay, because we wanted these 4 columns, so these 4 columns have appeared in the output. Okay, and what data to be displayed? All the 1 to 3, these will be displayed because these are part of the left table and everything from the left will appear. Okay, you can see 1 is coming twice because we had that entry in the right table, correct? So because it was appearing twice, so we have this twice. 1, 1, name would be same, order ID will be picked from here 101 and 102, and amount will also be picked like 500 and 300. Okay, then of course for 2 we will display 2, the name we have Amit, but there is nothing present in the orders table. So if nothing matches, we simply print null there. So we'll write order ID null, amount also as null because it's not present in the orders table. And then 3 we print. Okay, corresponding to 3 we have the name Neha, so we print Neha. In the orders table we don't have any entry respective to 3, so we'll print null and null. Now this won't be printed because this is not part of the left table, correct? So you can clearly see all rows from left table and matching rows from right table. Okay, so easy to remember because the name says left join, so everything from the left table and matching from the right. Now you may ask, like, why would you use the left join? One of the example could be you want to get the data of users even if they have not made any orders, correct? So here you can clearly see we have the data related to 2 and 3, although they have not made any order here. Similar example could be you want to get the information of the products even if they are not sold, right? So you'll get that data using the left join. Alright, so now that we have discussed about the left join, similar to this, now let's also discuss about the right join. So we will use the same input here, the users in the orders table. Now what will be the rules for right join? You can just imagine the reverse of left join. In the left join, we took the entries from the left side and the match from the right side. So here what we will do is like we will pick everything from the right side and we'll pick the matches from the left side. Okay, and it's easy to remember because the name says right, so you would give the preference to the right table. You will pick everything from the right and just the match from the left side. Okay, so let's now see the query for right join and then we'll see the output for the same. All right, so this is the query for right join. First you write the select keyword because we want to perform the read operation. Then you basically tell the name of columns which you want in the output. We are making it same or consistent across all the join queries so that you don't have any confusion. So this is your left table, which is the user table, and you do the right join. So you write the keyword here, right join, correct? And then the table name. So this is your right table, correct? Orders is your right table and users is your left table. And what is the condition on u.userid equal to o.userid, correct? So what we want here, everything from the right table and match from the left table. So basically we would show for user id 1 4, okay, but we will not show for user id 2 and user id 3 because it is not matched. So let's see the output now. All right, so here is the output. These were the columns that we put in here, correct? Now as we said, we will pick the data from the right table. So user id 1 because we found the match as well, so we'll write user id 1. The name corresponding to that is Rahul, so we write Rahul here. Then order id is 101 and amount is 500, so we write 500 here. Okay, the next, because we have one more entry with user id 1, so we pick 1 because we found also the match here, so we write 1 here. Name Rahul, we picked it from here. The user id is 102, so here it comes, and 300. Now we want to show this one as well, but there is no match in the left side table of users, correct? So we want to show this, but because there is nothing in users table, so we print null here, and corresponding to name also we put null here, and then user id we know is 103 and the amount is 700. Okay, so it is a kind of case we can say the users are shown only if they exist, because in the users entity this user does not exist with user id 4, so we are not displaying that with the id. We are saying that as a null. And important part here, because we applied the right join and on right side we had the orders and on left side with the users, so we have excluded those users who have not made any order here, correct? So the users who are not present in the orders table, say for example user 2, user 3, they have not made any order, so we have excluded from the output. So if in summary you have to remember, you can say you'll show the data from the right table and from the left side whatever is matched, only that is displayed. All right, so after the right join, let's go to the next one, which is the full outer join. We are going to check this again on the same example of the users and the orders table. Now what does full outer join mean? As the name suggests, full, it means all rows from both of the tables. So let's first see the query and then we'll see the output for this. Okay, so this is the query. Select these columns, right, from this left table, which is the users table, and we write the keyword full outer join, and then the other table orders, which is your right table, and after that we apply the condition on u.userid equal to o.userid. Now let's see the output for this. So here is the output. As we said, it will include everything, so all of these will be included. First of all, user id 1, corresponding to that data we have Rahul, and order id is 101 and amount is 500, correct? Next is 1 with Rahul, order id 102 and amount 300, correct? After that comes our user id 2, so we put 2 here. The name is Amit. The order id would be null because it is not present in the orders table, right? So we put null and null here. Okay, so next would be 3, name would be Neha, again because it's not present in the orders table, null and null as an order id and amount for that. Last we would have the user id 4, but because that is not present in the left table, so we would put here null, name also null, the order id we know as 103 and amount as 700. So you can clearly see it has included everything, like all the rows from both of the tables. Just that we have not put 4 out here, we have put null instead of 4 because that does not exist in the left table users entity, correct? But overall we have picked all rows from both of the tables. So clearly you can see irrespective of whether there is a match or a mismatch, we have included everything from both of the table. That is why it's called the full outer join. So wherever there is no match, generally you will see nulls there. You can see null here. Also in these places you see the null, but we have included all the rows. Okay, so after this, the fifth type is the cross join. Okay, the same example we will use here. Now basically this is a Cartesian product, which means if there are m rows in table 1 and n rows in table 2, it will give you m into n. So this is very rarely used and it can be dangerous if it is misused, because you can see there is huge amount of data that can come as an out. So here if you see, there are 3 rows in the users table and 3 rows in the orders table. So the output would be 3 into 3, that is the 9 rows. First let's see the query and then we'll see the output. Alright, so this is the query that we have made. Select, these are the 2 columns that we want to show in the output, the name and the order ID, right? And this is your left table, which is your users, and we use this cross join keyword here, and then orders table is your right table. Correct. So what we are going to do is, like, we are going to have m into n rows, right? So let's see the output now. So here is the output. You can see m into n, 9 rows. We have printed only 2 columns here, name and order ID. Okay, so it will give you kind of combination for each of these. So first is Rahul. So Rahul will be combined with all of these. So Rahul 101, Rahul 102, Rahul 103. Then we have Amit. So Amit will be combined with all of these. Amit 101, Amit 102, Amit 103. Then we have Neha. So Neha will be combined with all of these. Neha 101, Neha 102, Neha 103. So you can clearly see it is giving you the Cartesian product. So it will be rarely used because it can give you huge amount of output which might not be even required for you. It is generating all the combinations, as you can see here. So in cross join, as you can clearly see, there is no condition as well. In other joins you generally provide where the user ID on the first table is equal to user ID of other table or any other condition, but here you can see there is no condition. It just like provides all the combinations which would be possible. So we discussed about these 5. First was the inner join, which was used to provide you the intersection, right? Only those rows which match in both. Then you had the left join, basically which provided all the rows from the left table and matching rows from the right table. Then we had the right join, which provides all the rows from the right table and the matching rows from the left table. Then you had the full outer join, which provided you all the rows from both of the tables. And lastly, we discussed about the cross join, which would give you the Cartesian product. So these 5 are basic, you can say, the core types of the joins that we have. There is one more type, the 6th one, you can say it is the self join, which means a table joined with itself. That's why it's called a self join. So for example, this is the table which has like 3 columns: employee ID, name and manager ID. Okay, so you can see these 3 rows are present in this table. Correct. Now the name of this table is employees table. So let's write the query for self join. So here is the query for self join. Select e.name. Let's write the short word for it, e. So for from employees, e, and we have selected e.name. So this field as employee and m.name as manager. So you're giving 2 different names here. So because this is a self join, so both tables will be the same. So this is the left table employees, and then we are doing here the left join here, and on the right table also we have the same table because it's a self join. So right side also we have this employee table, but we are giving some other name here, m. And then because we have to apply the condition on left join, so we are doing the e.manager id equal to m.employee ID. So here is the output. You can see because we have applied the left join here, although the left table and right table both are same, we are just applying the left join on the same table. So that's why we have called it as the self join. Now in the left join, we know, like, we pick the data from the left side and we take the intersection on the right side. So everything on the left side, like Rahul, Amit, Neha, these will be displayed. So we have displayed here Rahul, Amit, Neha, and then we have to display the manager name. So for Rahul, the manager ID is null, so we display null here. For Amit, the manager ID is 1, which represents Rahul, so we write Rahul here. And for Neha also, the manager ID is 1, which represents Rahul because Rahul's employee ID is 1, so we mention Rahul here. So clearly you can see we have applied the join on the same table. So on the left side and right side we have the same table, correct? So that's why it's called the cell join. Now cell join in itself is no keyword, so that's why we have not mentioned cell join here. In the cell join you have to use either of the types that we discussed, right? It can be inner join, left join, right join, full join, or cross join. Here we have used the example of left join. So we discussed about all types of joins with the example. Now let's try to memorize those with the brief summary. The first one was inner join, where in the output we had only the matching rows from both the tables. Then we had the left join, which had all the rows from the left table and the matching rows or the intersection from the right, correct? So all left side plus matches. For right it would be the complete reverse of left, so it is like all right plus matches. Full will contain all the rows from both the tables. Cross will be like Cartesian product, and self would be table joined by itself. Okay, so these are the types of joins. All right, so after this, now let's move to a very important question, which is what is the difference between join versus where, and how to use each of these. Alright, so the purpose of join is to combine the tables, because after normalization we will have multiple tables, so we have to join the data. So for that we use the join, whereas where is used to filter the rows. The role of join is to define the relationship between the tables. The role of where is to apply the conditions. Talking about the execution step, which is a very important part, the join happens of course during the join, whereas the where happens after the join. Okay, I'll show you the table now through which you'll get the clarity of the execution order, that where happens after the join. Okay, let's go there. So this is the basic question which says what is the SQL execution order for the keywords like join, where, on, from, all such things. So this is the execution order. So here you can see we have join, and then we have on, and then we have the where. So basically the on keyword, this happens during the joining, whereas this where, this happens after the joining. So on you can say during, where after the join. Okay, so this is the thing that you need to remember, and this is what we were talking about here. The execution step of join would be during the join and on as well, but whereas for where it happens after the join. Okay, now as we were discussing join versus where, if you talk about the inner join, both will give the same result. Let me show you the query. Now here you can see in way 1 we have used join plus on, whereas in way number 2 we have used the where clause. Okay, this is the old style, this is a new style. See the query number 1, select star from users. This is the left table, correct? And we have used join keyword here, and this is the right table, correct? And then we have used on with the join. So u.user_id equal to o.user_id. So way 1, this is for inner join basically, and this is using the where clause. Select star from users and order table where u.user_id equal to o.user_id. So both of these will give the same output as we are talking about the inner join. So this was like inner join. So both gave the same output here, but the way 2 is like the old approach and this is the new approach. This is more cleaner and safer approach, so this is a better one, the new approach, using the join plus on. Okay, now we will talk about some of the cases like where clause can cause issues, and you have to keep in mind how to use it, because in inner join it was totally fine, both were giving you the same kind of output. But let's say we are using here the left join instead of the inner join, we are using the left join. Okay, and if we use something like this can cause big issues. This is not the correct way. What we are doing here, select star from users u, so this is your left table, correct? And then you have used the left join here, orders right, so orders is your right table, and then you have used the on keyword u.user_id equal to o.user_id. Till now it's totally fine, but after that you have used the where clause where o.amount is greater than 500. Now this can cause issues because as we talked, the execution of where happens after the join. So here we have used the left join, which means we will show all the data, all the rows from left table, and we will show the match from the right table, correct? So some of the stuff can be null as well. So what happens here is, like as we told, like where filters after the join, so the null rows will be removed because amount we have applied the check is greater than 500. So for example, if we simply applied the left join, forget about this where clause for now, we had something like this as an output for the users and orders table, correct? But after this, you can clearly see there were some of the amounts which were null because we used the left join. Left join means everything from the left table and the intersection from the right table. So if something was not present in the right table, so for example for user id 2 and 3 nothing was present, so we put that as null here. So this was a result that you got from the join. Now if we apply this where clause after this join, now clearly you can see it says 500, so nothing is greater than 500, ignore that. Let's say this was like greater than 100. Okay, now when we apply this kind of condition here, then what will happen is like both of these rows, correct, last two, these will be removed because these are not greater than 100, correct? Only these would be present. So if the end output is only this will act as like the inner join instead of the left join, correct? So this won't be that great. We wanted things to happen like the left join, but if we apply the where like this, it acts like the inner join, which is not our correct requirement. Okay, and if we say this was not 100, this was 500 only, so o dot amount is greater than 500, then after this query, because this was a join result, this where clause happens after the join. As you can see, nothing is greater than 500, so the output will be nothing, so no row will be returned from this. Okay, so this was a response from the join, but after we apply where o dot amount is greater than 500, we get nothing in the response. Okay, now let's see, instead of where clause, how can we write in a better way so that it can do filtering accordingly. So the query would be something like this. We use select start from users u, this is the left table. Okay, then we use the keyword left join orders, which is the right table, correct? And then we use on u dot user id equal to o dot user id. Till now everything is same, you can clearly see, just instead of where we will use and o dot amount is greater than 500. Now why this is correct? Because here the where clause happened after the join. Okay, so that is why the filtering was not happening correctly. Now let's see what will be the output. So this is the result after join. You have the user id, name, order id. This happens because we have used this condition. This happens during the join and not after the join. When we use the where clause, this happened after the join, so it removed all the rows after the join output which we got. But here what we are getting is the filtering we applied during the join, so you can clearly see the amount comes as null for all because none of these had amount greater than 500. So the final output would be something like this. You can clearly see the amount is coming as null, but it has not removed those rows, whereas when you use the where keyword, it had give you 0 rows, so everything was removed from the join whatever we got, because this happens after the join. If you do something like this filtering happens during the join. Okay, why this happens during the join? Because it is actually on condition, so this is happening at on the user match and basically represent another condition. So these two conditions which are part of on. Okay, so match of user id and another condition is amount is greater than 500. So these were the conditions which were present in on keyword, whereas here inside the on we had only this condition, and after that we had the where clause. So this condition of amount greater than 500 was present in where, which happens after the join, whereas this was present in the on, which happens during the join. So that's why it makes a huge difference. So you have to be very cautious when using where in the joins. Okay, so basically you can say something like this. We did like first where o dot amount greater than 500, in second case we did on o dot amount is greater than 500. In first case we got no rows because after the join it did filtering, so whatever result we got after the join, it did filtering on top of it, so nothing was given. Whereas in second case the filtering was done during the join, so all the users with null orders were returned. Okay, so filtering in where happens after the join and can eliminate the null rows, whereas filtering in on happens during the join and preserves the left join behavior. Okay, again you need to be very cautious when using the where with the join. It's better to use on with the join. So basically when we are talking about the joins, on condition is acting as like the matching case. If you have one condition you put it, and if you have more than one condition and you want to say make both of those mandatory, then you can use basically and keyword and then put the second condition, right? So you were using the on keyword for matching the conditions using the join. Like for example, we talked about the inner join. So in inner join, we said that in the output, we give the rows where match is found in both of the tables. So what is the matching condition? We have put like user ID, u.user ID equal to o.user ID. But how are we matching it? Using the on keyword, right? So with the on keyword, you are providing the criteria of match. Okay. So if we had more than one condition, we could use the and keyword. And the good part is it is quite similar to the English, right, language that we use in day-to-day life. So it makes things easier in that way. Okay, so after this, let's move to the next question, which is how database executes a join. So we saw different types of joins. Now let's see how is it executed by the database. Now join can be executed in many ways. Let's see all the various ways. First can be the nested loop join, where you can clearly see for each row in table A, scan matching rows in table B. It is kind of you have applied like two for loops, quite similar to like we have the 2D matrix, right? And how do we traverse it in the brute force? Similarly, this is like if there are n rows in table A and m rows in table 2, so the cost would be O of n into m, because you are getting all the combinations, right? Now because it has high complexity, it is good only when one table is small, of course, because if n and m both are big in numbers, then the total cost would increase, right? So it is good only when one table is small. Okay, the second type is index nested loop join, which is the most common one. Basically in this we will use the index to reduce the overall complexity. So for each row in table A, we use the index on table B. So we will use the index on the join keys, or you can say the foreign keys on which we will apply the join. Now as compared to the first one, it is quite fast and it is very commonly used in OLTP systems. Now what is OLTP system? Don't worry about it, we will discuss about that later in this video. But the main thing is this is the most commonly used. So indexes make joins efficient. How it works is like on the smaller table, you will build the hash table and you will prop using the larger table. Now of course, because you are building the hash table, it requires extra memory, and this kind of approach is fast for large data sets. And the fourth way to execute a join is merge join. This will be used when both of the tables are sorted, and then basically you will merge like you do the merge sort, correct? So this is fast, but it requires sorted input, correct? So these are the four ways how DB executes a join. We did not go in much detail because that is not required. We discussed this just to give you the brief, like how things will work internally, okay? But this one is the most common, where we use the index on the join keys, or you can say the foreign key, and that will make the join quite efficient. Now further, let's see what are the best practices for using join. Alright, so some of the things that we discussed. First, we can index the foreign keys, or we can index on the keys on which we are going to apply the join, because that will make things quite fast. This is the one that we discussed, right? Index nested loop join, okay? So if you index on the foreign keys on which you are going to apply the join, that is going to be very efficient. Next, join the smaller tables first. And third, avoid unnecessary columns. So instead of doing select star, you should provide the column name which is required for the output. So instead of star, we can provide the columns. Okay, so after this, let's discuss about joins versus denormalization. So denormalization means all the data present in one table. Normalization meant we would split the tables into multiple parts, and then because we would require the combined data, so we would use the join then, correct? So our understanding till now is like many joins will make the slow reads because you have to combine the data from multiple tables, correct? Hence that read query will be quite slow. And denormalization makes faster reads because you would have all the data in one table, so making a query here, you will get the data directly, whereas if data is present across multiple tables, then you have to join the data. So in the real systems, we will normalize the core data, because in denormalization, if everything is present in one table, we saw there can be multiple issues. There will be a lot of duplicate data. Then there can be a case of data inconsistency, because if you update some of the rows but some of the rows are not updated accordingly, so there will be data inconsistency. So we normalize the core data for data consistency. but at the same time we denormalize the hot paths, the areas in which like you have a lot of read operations which is read frequently. So in that part you will denormalize so that the read query is quite fast on that, because we have learned excessive of normalization and excessive use of joins can hurt the performance at scale. Okay, so we have to use the combination of normalization and denormalization. So for example, say we have the normalized tables like users, movies, theaters, shows, seats. So we have a product like Bookmyshow, so we have all these normalized tables. And if a hot query comes as like movies plus theaters plus show timings, which is of course quite common in Bookmyshow, then instead of doing heavy joins like you're combining multiple tables, the solution can be you can denormalize some of the part which you know is quite heavily read, and apart from that you can have pre-joined views and cached responses. Now after this, let's see what are the common join pitfalls. Okay, so if you miss the join condition, like for example we use on and then provide the condition. If you miss that part, then it would act as Cartesian explosion, which means in the output you will get all the combinations of both of the table, correct? So we need to keep in mind that we provide the correct condition using the on keyword. Second pitfall is joining on non-indexed columns. As we saw earlier, indexing on the join keys or on the foreign keys on which you are going to apply join can improve the performance by huge margin. So we should always keep in mind to use the join on the index columns. So if you are joining on non-indexed columns, that can create a lot of issues. Third pitfall is too many joins in hot paths. Now if you know some query keeps on happening, it's a hot query, but again you are just applying join on top of it, then it can degrade the performance, correct? So you need to keep in mind like you can denormalize that kind of hot path, or you can cache the response, you can apply the pre-joins so that the overall user experience is good. And lastly, another pitfall is joining large tables on repeat. So all of these are the common pitfalls through which your performance can be degraded. Alright, so this was about the join. And when we talk about RDBMS, so SQL Database or RDBMS, it follows strong ACID transactions. We discussed about ACID properties, right? Apart from it, SQL also has strong consistency as it follows like ACID properties, and it supports joins. So we do normalization in SQL and we use the joins to join the data. So SQL is good in joins. Okay, we will see in NoSQL we don't use much of normalization and it's not good for joins. We will see that later. But in SQL we follow ACID properties. It has strong consistency. It is used for financial transactions like the banking apps, they use the SQL database, and it supports joins. So normalization and joins are common in SQL database. Now because SQL has structured table and it is good in connecting multiple tables using the key, which is the foreign key, so that is why SQL is strong in joins. Okay, as we follow the strong relationships in SQL database. Now next, let's discuss about scaling relational databases. So how do you scale SQL database? Okay, when we talk about scaling SQL, there are three things. First is a vertical scaling, which means you can increase the CPU or RAM. Like for example, you have a machine which has like RAM of 6 GB and storage of say 512 GB. Okay, so you can increase that to like RAM of 12 GB and say storage you make it 2 TB. So you are simply increasing the hardware of the current machine. Okay, so that is easy, but again it has limits. You can increase the hardware limit of something till some point. Okay, after that it won't be possible, right? So you can't do vertical scaling unlimited level, right? There would be a maximum level till you can do vertical scaling for a machine, because every machine has its own limit, right? So after vertical scaling you have options like, first you can have the read replicas. We have heard about read replicas earlier as well when we were talking about the durability part in the ACID properties, right? Durability means once you have committed the transaction, even after that your machine basically crashes, the data should survive. How does that happen? That happens like one of the ways is read replicas. You have multiple copies of your data, correct? So there is no single point of failure. So in this we can use like the master slave architecture, or you can say there are multiple replicas for reads. Like in the master we do the writes and in the replicas we do the read operations. So we have separated the read versus write operations. Write is happening on the master machine, whereas reads are happening from the replicas. This basically improves the read throughput. So using this, first you avoid single point of failure, then of course you have divided the operations like write versus read. But the problem which comes in it is like eventual consistency, because say for example you have this master and you have kept like 3 replicas. Okay, so we said that read the operation will happen from here, write happen here. Now say we have updated the data in the master. Okay, and then if you read from the replica, of course you won't get the updated data, so there will be eventual consistency, right? So that happens when you have like read replicas. Now before moving to sharding, I would want to discuss in bit more detail about the read replicas so that you get more understanding out of it. Okay, so as we said, like the read replica is a copy of the primary database that is used only for the read queries. Okay, so basically it is also called the master slave architecture. Like you have made one master on which we will do the write operations, and then you have multiple slaves on which you will perform the read operations. Okay, so read will happen from the replicas and write will only happen on the master. So this master acts as the primary database on which write operations will happen, and on the replicas we will do the read operations. Now the question comes, why do we need read replicas? Now basically in system design we keep on talking about single point of failure, right? So just imagine if we have only one single database, then we would have too many read requests on a single machine, right? Like for example, this is the machine, so every request will come here, so it has to perform all the operations, and there can be a situation that whatever is the capacity of this machine, you have more requests coming than that capacity, and in that case your machine can go down and your overall system will go down, because this is the only machine which is present in your system, right? So that causes single point of failure. Okay, after that of course you will have the CPU bottlenecks, and there will be slow queries affecting the writes, because now there are so many read operations but that needs to be performed by this single database, so it would also impact the write operations. And there are other factors related to SPOF as well. Like for example, there is a single machine and it goes down, then of course your complete system goes down. Say the machine crashed or something happened, so in that case your data won't be durable, correct? If you had the data only on one machine and that is crashed, so how will your data survive? So we want the durability fact that we talked in the acid properties, right? And overall also we want like data to be persistent in our database. So if we have only one DB, say it is present in one geographical, say that location is impacted by some natural disaster, then how will your data survive? So for that you require the replicas, correct? Now what problem replicas solve? They scale reads horizontally, because now you have multiple read replicas, and when a read operation comes, now you have option to which machine you want to send that read operation, so you can scale reads horizontally. It also reduces the load on the primary, because now we have separated the operations. On primary DB we are only doing the write operations, and on the replicas we are handling the read operations, so it reduces the load on the primary one, and it improves the availability. Which how? Like even if one replica goes down, we can distribute the request among different replicas, so it improves the availability. And we have separated the read and write traffic that we already discussed, scaling the read heavy workloads without impacting the write operation performance. Okay, now that we have multiple read replicas, whenever a read operation comes, we need to decide where does it go. So how will we decide like where the read goes? So we have multiple options to decide that. First is using the application code. So through the application code you can decide to which machine this read operation should go to. We will discuss about this part later in this video, because I have to show one use case of this one. But before that, let's go to the other options. Second is the database proxy, and third is the load balancer. So here you can clearly see we have used the load balancer to decide to which replica this read operation should go to. Okay, so if you want to know about load balancer in detail, you can refer to this video of mine where we have discussed about the load balancer in system design, what's the role and why is it required, and how does it decide to which particular machine the request should go to. Okay, so you can refer to this video for more details. Now after this, let's check another question that comes into mind, which is how replication works internally. So for this, let's understand a concept as WAL, or write ahead logging. So as we said, like we have the master and slaves, right? And the write operation happens on the master machine, correct? So whenever the write happens on the primary or the master machine, the change is written in the bin log, okay? And then the replica reads the bin log, okay? And after that, the replica replays the changes, okay? So whenever you make a write operation in the master, the change is written in the bin log, and the replicas start reading from the bin log, and then replica replays the changes. Okay, so this is a process: primary, bin log, and then the replica. So primary here means the master machine on which we have applied the write operation. Okay, now but when we talk about the replication, there can be different replication modes. Let's discuss about the replication modes. All right, so these are the three replication modes. The first one is asynchronous, which is the most common one. Okay, so just imagine you have this primary database where you will perform the write operation, okay? And then you have your read replicas, which would be used for read operations, correct? So the first one, in asynchronous, the primary doesn't wait for replica. So whenever a write operation comes, it happens here and we give the success. Okay, so which means the write operation is done and we have not updated the read replicas. So in that way, the write operation will be very fast, because we don't wait for the read replicas to be updated as a master. Okay, so the good part is we get the fast writes, but what is the bad part? The con is that there can be possible lag. Say for example, you updated the name, like from Mr. Mohit, this was a old name which was present in DB, and now you updated it to say just Mohit. Okay, so you made an update in that, so this was updated and it was quite quick. But if you make a query on the read now, you will get the old data, or you can see the updated data after some lag. So there can be a possible lag in that, right? But this is the most common one, because in this the write operation is quite quick. So the next one is the semi-synchronous. So the name gives you some vibe what it is going to do here, right? So basically it will wait for at least one replica acknowledgement. So whenever you make a write operation, okay, so it will wait for at least one of the replica to say okay, it has been updated in the replica as well. Okay, we are not doing for all the replicas, we just wait for one of the replicas to say okay, acknowledgement done, that we have also this change in the replica as well, right? Now you can imagine what is the con here. You will have the slower writes, because you have to write in the primary machine, and at the same time you will have to wait for one of the replica to acknowledge that that change has been also been updated in one of the replicas. So we will have slower writes, but the good part is there will be better safety, because in at least one of the replica we have this updated data, correct? And the third one is synchronous, which is very rare. In this, what we will do is, like whenever we make the write operation in the primary, it will wait for all of the replicas to replicate that data, so that that change will be now present in all of the replicas as well. So of course the good part is there will be strong consistency. So if you try to read from any of the machine, you will get the updated data every time. But the problem part, you will have very high latency when we talk about the write operation, because when you write, you have to write in the primary, at the same time you have to update all of the replicas. You are waiting for that part. Okay, so it is used in the special system. So depending on what kind of system you are using, what kind of requirements you have, you can use one of the three replication modes. Now of course we said asynchronous is the most common, but it introduces the possible lag, which is also called as the replication lag. Now what is the replication lag? It means the replica is behind the primary by some time. Okay, so it will take some time for the replica to update as to the primary one. So if we talk about the replication lag, it can appear something like this. Okay, this is the replication lag. How? Say for example, the write operation happened in the primary at the time 10. Okay, and then when we talk about the replica, the changes apply at like 10:00:02. So the lag is of 2 seconds, correct? So the replica machine is behind the primary by 2 seconds. So it takes 2 seconds for the replica to update same as the primary one, correct? But why this lag happens? It can happen due to a lot of reasons, like you have the heavy writes, so many writes happening, and we don't want to slow down the write operation, so we are not updating the replicas at the same time. Okay, and then there can be network delay because these machines are not same, these can be separate machines, so you have to interact with them via the network, so there can be the network delay, correct? Then you may also have like slow replica hardware, and there can be a large number of transactions, so you have to update a large number of transactions and it takes time, so there can be replication lag. Now what is the problem with this? Again, the same thing, say this is the primary database and these are the replicas, right? Say you updated some data here and then you try to read that data, you will get the stale data from the replica because there is a replication lag. The changes that you have made in the primary are not currently reflected on the replicas. So this is what we call as like eventual consistency, which means that if you try to read the data at the same time, you won't get the updated or the exact data, but after some time, after the replication lag, you will get that data. So this term is called as eventual consistency. Okay, that after the replication lag you will get that updated data, but there will be some delay, and that is called as like eventual consistency. So I hope you got this problem what we are talking about. If you update the data and if you try to read that data, you won't get that exact data at the same time as there is replication lag, correct? So you will get the stale data. So how can we fix this kind of problem? Now basically one of the solution to this problem is that you can route the critical reads to the primary. So earlier we said like in the primary we will only do the write operations and the read we will do from the replicas, right? But now as we see, there is the replication lag which can happen, which is a very common kind of issue as well. So what we can do is like if you have a critical kind of read that you detect, what you can do is like you can route that to the primary database instead of waiting for the replicas to be updated after the lag, right? So we can't wait for the lag, so then in case of the critical reads you can route it to the primary. And then there is one more solution, you can use the cache with the write through, but let's discuss about this first one, routing the critical reads to the primary. How can we do that? Okay, so when we discussed about like how we will decide the machine through which you will do the read operation, correct? Here we said that we have three options. Okay, we said like load balancer is quite common, right? And there can be database proxy, but there is one more option which is the application code. So basically using something like this in the application code, you can redirect to the primary machine instead of the replica. So if the read is critical, you are making it to the primary machine. Although we said that the primary machine, the role is to only handle the write operations, but if the read is critical, you can also redirect it to the primary, and because we have performed the write operation on the primary machine, it will always contain the updated information, and when you read from it, of course you will get the updated data. So if the read is critical, you will get a updated data and not the stale data. But in else case, if it is not critical read, you can send it to the replica, and then further you can decide it in any of the ways, like which particular read replica you want this to pick. Okay, but this is something that we wanted to talk, like if your read is critical, then you can basically redirect it to the primary one through the application code, right? All right, so after this, next let's talk about the failure scenarios using the read replicas. Okay, the one good thing about read replicas is that it provides you multiple read replicas. So just in case one of the machine fails, correct, so what you can do is like redirect its request to other machines, correct? So that is why it is really important in avoiding single point of failure, so that even if one machine fails, you can redirect the request to other machines, right? So it handles it in a wonderful way. So this was when one of the read replicas fails. But what about if the primary machine or your master machine fails? Then how to handle that? Okay, so in case your primary fails, okay, what you need to do is like you have to select one of the replicas. Say for example, we pick this one, okay, and we make this the primary one. So this will become the new primary. This was the old primary and this is the new primary which we took from the read replica. So now this is not acting as like the read replica machine, it is acting as the primary one. Okay, so all the routing which was happening for like the write operations, now instead of going to this, it will go to this because it is acting as the primary now. Okay, and then it will resume the write operations. These two will keep on acting as like the read replicas. So all the read operations which were earlier coming to 3 machines, now the routing will be updated. These will only go to these 2 machines, but the write operations will be redirected to this machine now, as it is acting as the master now. So in order to perform this, we can use the tools like MySQL, Orchestrator, and much more. Okay, we covered about the read replicas. Now let's discuss about sharding. So basically sharding is kind of horizontal scaling, where we would split the data horizontally across multiple databases. So you can imagine it like, instead of having one huge database which has everything, we will split it into multiple smaller database, which will be called as shards, right? So instead of like one huge database containing records like 1 to 1 billion users, we will have multiple smaller databases or shards, like shard 1 having the user data from 1 to 250 million, then shard 2 having 250 million to 500 million, then shard 3 having users data from 500 million to 750 million, and shard 4 having user data from 750 million to 1 billion. Correct? So we have distributed it into smaller multiple databases or shards. So now we have multiple shards here, but each shard will have same schema, and each shard will store subsets of rows, right? For example, it is having user data from 1 to 250 million, and similarly 250 to 500 million, but every shard has the same schema and contains subset of the complete data. Now when we discuss about sharding, a basic question that may come into your mind is, why do we need sharding? Now as I said earlier, sharding is like horizontal scaling. So if you know the basics of system design, which we have discussed in this video, you might be already aware why we need sharding. Like it's like the horizontal scaling of the database. Like we do horizontal scaling for our like servers, in similar way we need the horizontal scaling for our databases, right? So refer to this video where we have discussed about in detail of the fundamentals of system design. But okay, coming back to the topic, what are the problems that we face without sharding? It's like there is only single database which contains all the data, so all the load goes into it and it acts as like single point of failure. So for example, you have only one huge DB, so it can act as like single point of failure as well. But at the same time, like we discussed, we want to do vertical scaling, but then on vertical scaling you have a hardware limit. You cannot increase it after a specific point, like because this is a kind of a machine and machine has restrictions related to hardware, correct? You want to scale it vertically, but after a point you cannot scale it. So if you talk about like scaling, then you need like horizontal scaling, correct? And after a while, if you put too much load on a particular machine, then that machine will go down, okay? And because you have only this one huge data set, so if it goes down, your complete system goes down. So you need like horizontal scaling to handle this kind of load. Now what all sharding solves? It solves horizontal write scaling, storage scaling, and better isolation. We basically checked for scaling on the database, right? We saw like vertical scaling is one option, then read replicas is one option for the read operations. And when we talk about sharding is primarily used to scale write throughput and the storage. So in summary, if I have to tell you, sharding is like, instead of having a big one database, you split it into multiple databases or shards. Read replicas was specific for scaling of the read operations, and sharding acts as like horizontal scaling for the database. So one question that may come into your mind is like, what is the difference between sharding and replication? Because we have checked about like replication earlier and now we are talking about sharding. So what is the difference between both of these? So both of these things, sharding and replication, are used for scaling of the database. Like when things happen at a huge scale for database, how do you handle that? So both of these help in it, but let's see the key differences. The goal for replication is to scale the reads. If you have so many read operations, how do you handle that? Using replication. And the goal of sharding is to scale the writes, okay? So replication is for scaling the reads, sharding is for scaling the writes. And when we talk about the data aspect, replication we are doing by copying the stuff, right? You basically create the replicas, so you are basically creating a copy of that. Whereas when we talk about sharding, it is happening by splitting the data. So you had this big database, you split it into small multiple databases or the multiple shards, you can say. Next, when we talk about the consistency in replication, we have eventual consistency. Why? Because if you write in the master DB and then you have the replicas, so there will be replication lag that we discussed about, right? So these will be updated after some time or after some lag. So we will have eventual consistency. But when we talk about consistency in sharding, it will be strong per shard, because you will make a write operation to a particular shard only, right? So we have split the data into multiple shards. So your write operation will have happen to a particular shard, and in that particular shard the consistency will be strong. Next, when we talk about the complexity, for replication it is medium complexity, but sharding is of like bit high complexity. How? I mean, you'll see more about sharding in this video and you'll get to know like why sharding is bit hard, specifically when we talk about like SQL database. Okay, so sharding comes as like one of the, you can say, the weak point or difficult point to handle in SQL, because you have to handle it by your own. Whereas when we talk about NoSQL, they are automatically quite good. They are made in such way that they are good in handling like the horizontal scaling, but in SQL you have to handle it yourself by doing the sharding. So basically the logic of sharding, the shard which to pick and how things happen, it happens on the application layer for SQL, and that is why it makes things more complex. I mean, we will talk about more later in this video, but very simple things. Say for example you have like 4 shards for now, and your logic is that it should go to some particular shard. There can be some method that you have written based on which it can go to a particular shard, but say after a while one of the shards is down, right? So then you have to keep that logic so that it can be handled by the application logic, so there can be changes in that kind of things, right? So yeah, there is complexity in sharding. We'll discuss more about sharding, the logic, all the things. We'll also discuss the aspects like SQL versus NoSQL. Why is it so typical for SQL, whereas for NoSQL it is kind of automatic thing, the horizontal scaling. Now, as we said, like there are multiple shards now, and we saw that it can be something like shard 1 contains data for 1 to 250 million, and shard 3 contains for 500 to 750 million. Like, but how do we know where the data exists? And that basically happens using the shard key. So the shard key basically decides where the data exists. Okay, so if we have the bad shard key, then it can result in hot shards, imbalance, and lot of issues. Okay, and good shard key would be where you have like evenly kind of distribution among the shards. Now I understand the basic questions in mind would be related to the shard key and what are the strategies used for sharding. So let's discuss both of these in detail. So the first type is range based sharding. So it would be something like we saw in earlier example also. So user ID from 1 to 100k we would put in shard 1, and user ID from 100k to 200k we would put in shard 2. So we have decided the range, this range, so this shard. Okay, like that we can basically distribute. It appears to be simple, so that is a pro. But the con part would be like a particular user or set of users in a shard can be hot shards, so many write operations happening in particular shard, whereas in shard 2 there might be like a very light load kind of a place, right? So there can be hot shards that can be formed due to the con of this range based sharding. So this kind of approach can be used for like time based data or logs, you can say, because that would come into particular range. All right, the second type is hash based sharding, which is the most common. Okay, so instead of just deciding the range, what we are going to do is like make a hash related function. Like for example, if there are n shards, so we would do whatever user ID comes modulus n. Okay, this is just a method that we made. You can have of course a better hashing related method. Okay, and based on that we will decide the shard. So the pro of that is like we have like even distribution and no hot shards happening here. So in first case, hot shard can appear, say for example, you made like shard 1 for 1 to 100k user IDs, and there were user IDs mostly lying in that range only, so you would have a hot shard as shard 1, because in shard 2 nothing is coming. Whereas when we talk about like the hash base, it will evenly distribute among all the shards. Okay, so there would be no hot shards in this. But of course, like range queries were easy in the first one because it was range based. Here it would be a bit difficult for the range queries. And if you do simple like this kind of function where you are just doing the modulus on the number of shards, if you add a new shard, then it will become difficult because this all calculation will become difficult now. So there will be a lot of changes happening on based on that. But the best part of hash based sharding is that it is evenly distributed. Alright, the third type is directory based sharding. In this you have maintained a lookup table, and corresponding to the user ID you will have the shard ID maintained. So you are maintaining an additional memory here. Extra lookup is a con that would be part here. Okay, but the most common of course is the hash based sharding, where you use the hashing approach to identify the shard. Okay, so let me explain it to you with a very simple example. So say we have this users table. In the users table you have like columns like user ID, name, email. Now which column should we pick as the shard key? We discussed like shard key is very important because based on that we will decide our shard, correct? And it's important for you that you pick up like right shard key, otherwise it can create a lot of issues for you like hot shard and many other imbalances, correct? So here if you see these, which one would you pick as your shard key? User ID, right? So if we pick the shard key as user ID here, then basically we will decide the shard based on this user ID. So we will use this hash based sharding approach because this is the most common. So we will use this only. Okay, so what we are going to do is like put it in the hash function where we will pick the user ID and we will do the modulus of 4. Okay, so say 4 is the total number of shards, so we will do modulus of 4, and based on that we'll get the shard. Say for example the user ID was 101, so it will do 101 modulus 4 and it will return you 1. So shard 1 is the answer for this user ID 101. Similarly, if the user ID is 202, so we will do 202 modulus 4, which will give you 2. So it will send you to shard 2, right? So using this you will be able to identify your shard. Now as we know, like we have multiple shards, right? So we have split the big database into multiple parts, correct? So how will the querying happen in this sharding system, right? So that's the main question, how the querying happens in the sharded system. Let's try to understand that. So we identified above that everything is dependent on the shard key, correct? Based on the shard key you will be able to identify your shard. So here also when we talk about querying, there are two cases. First, if you are querying using the shard key. So if you are doing this, then it will be fast because you are using the shard key. Now why it will be fast? Because you will make a query something like this. Select star from users where user ID equal to 101 and user ID was our shard key, correct? You remember this? Our shard key was user ID. So basically we are querying with the shard key, and based on the shard key you will get to know your shard, correct? For example, here we identified using the hash function and we will get the shard. So for example in the query you had like 101, so you will get the shard from this like 101 modulus 4, so it will return you 1. So shard 1 is your place, so you will hit only one shard, correct? And you will be directly routed to your particular shard. So that is why this is very fast, because everything is dependent on the shard key, and here you are querying with the shard key only. Now the second case is query without the shard key, and that would be really expensive. Let's see an example for the same. So here is the example. We are doing select star from users where email equal to this, okay? And email is not our shard key. Our shard key was user ID, correct? So that is why it will become quite expensive, because it will be difficult for you first of all to identify which shard to query on, correct? You have multiple shards now. You have split the data into multiple shards, and if you would query based on the shard key, you would clearly know which shard to go on, and that's why your routing will be quite easy. You will just hit only one shard. But when you talk about like you have not included the shard key here, then first of all it's difficult for you to identify which shard to go on, okay? So it may result in that you have to query all the shards. Depends on what strategy you are using, but the worst case would be like you have to go to each of the shard and try to identify whether you find out your thing here or not. So there can be high latency in this case. So basic thing to remember when we talk about sharded systems, queries without the shard key are quite expensive. Now a question may appear like, how will we handle this kind of scenario where we have made a query without the shard key? I mean, it depends. The worst case is like, of course, you can go to each of the shard and try to find out. That would be the worst case scenario. But you could also do some optimizations on top of it. For example, you have maintained the mapping. So there is additional kind of mapping that you have maintained or additional index service that you have maintained, through which what you want to get is like, through that you get the mapping from email to the user ID. So once you get the user ID from that mapping, from the email, then you simply can find out the shard because your user ID is a shard key. So instead of searching the user directly via email, what you are trying to do is like, you can basically try to find out the user ID from the email from some other mapping that you have maintained. Okay, and then from the user ID you'll get the shard, and you say get to know this is the shard, you directly go there and you find out. Okay, so this kind of optimizations you can make, but of course the worst case, you have to go through all of the shards if you're not doing any such optimizations on top, right? But of course this is expensive. Even if you have made some optimizations, you have to do that additional step, right? So if you're not doing the query on the shard key for the sharded systems, it will be expensive. So like we had the pain for querying without the shard key, another pain point could be if you have to do cross shard join, right? We discussed about joins where you have to find out the data from different tables, correct? And in sharding you are basically splitting out the data into multiple tables, right? So there might be a situation that you have to find out the data from shard 1 and then shard 2 as well, and then join that data. So that can be also quite painful because you have to make multiple DB calls. There will be high latency and there can be complex failure scenarios in it. How this can happen, like for example, you have one user shard, right? And you might also have like orders shard. Both of these can be different, and in a query you might need data for both. So it's kind of like cross shard join. Yeah, so we are doing cross shard and then join on top of it because data is present in different shards. So for that, what you can do is like, you can co-locate the related data. If some data is related, you can co-locate that. Another thing that you can think of is the denormalization, because joins you are using because of normalization, because you have split out data, and here you have different shards. So maybe denormalization can help. Of course, you can clearly see that cross shard transactions will be quite slow. Okay, all right, let's move to another topic related to sharding, and that is re-sharding. Now what is re-sharding? Now we said like, we split a big table into small shards, right? So say these are your shards, but now some case can appear that this shard, okay, becomes too big or it has too much traffic to handle. Then what to do? Then we have to do re-sharding, right? Because now this particular shard is too big and we need to shard it further. So what will be the problems in re-sharding? There will be data movement, there will be the risk of downtime, and there will be cache invalidation because you are re-sharding it. So basically you are splitting it further into small shards. So you will have to face all these problems. Now what are the solutions? Consistent hashing is one thing that can really help. If you want to know about consistent hashing, put that in comment section. I'll create a separate video on that part. Then we can have the virtual shards and online migration. Okay, I think we don't need to go in much of detail of this. It was just to share this topic, re-sharding. So let's move to the next point from here. All right, now that we are talking about sharding, let's also discuss about one of the famous problem that we face in sharding, which is hot shard problem. Let's try to understand it with a very basic example. Say you have done the sharding basis on country. Okay, so in the India based shard, you may get massive traffic, right? Whereas the shard Nepal might have like small traffic, right? So the basic problem is like, one of the shards gets too much traffic, right? So that's why it's called like hot shard. All of the requests are coming to this particular shard, whereas other shard, it's like very less kind of traffic happening. So this kind of a problem can happen in sharding. Now let's see what can we do for that. All right, the fix is, first hash based sharding. We discussed about what is hash based sharding. We discussed like range based sharding, hash based sharding, and directory based sharding. And we said like hash based sharding is most common because it gives you distributed kind of load, correct? So it will fix the hot shard problem. And then we need to pick the shard key in the correct way. It's important that you pick the right shard key, and we can also have like composite kind of shard key, so that will help to resolve this hot shard problem. Okay, one more thing about sharding, like we discussed like about the concepts like sharding and the replication. We also saw what is the difference between sharding and replication. Now in real world, what happens? So basically in real world we use both. We use replication as well as sharding. So it's a combination of both of things, because replication is used for scaling your reads, whereas sharding is used for scaling your writes. So you will have multiple shards, and each shard has replicas. Okay, so each of the shard will have like primary and the replicas. So we are doing the combination of sharding and replication, multiple shards as well, and each of the shard has the replicas as well. So due to this, we have the high availability and high scaling. Of course, we are doing sharding for write scaling, and then for each shard we are doing the replicas, so read scaling is also there. So we discussed about sharding, but now let's discuss in terms of SQL. Okay, so we discussed like sharding, what is sharding, how do we do it, what does it mean. But now let's talk in terms of SQL or RDBMS database. Okay, so we discussed in SQL we follow the ACID properties. So it is good for consistency because it follows the ACID properties, right? So for financial transactions, for banking apps, you use the SQL because of its consistency and all the ACID properties it provides, correct? And in SQL we follow like normalization, correct? So we normalize, that means we create different tables based on the role, you can say, and that helps in maintaining the consistency, correct? And then we use joins in SQL. So SQL is good for joins because it follows like normalization, and of course you need to get the data across multiple tables, right? So you would need joins for it. Okay, now the point comes for huge scale, correct? When we talk about scale, we discussed about like we can do vertical scaling, but you cannot do vertical scaling after a point, correct? Then we talked about replications. You can create multiple replicas, and of course that is good for your read scaling, read related scaling. You can do the replication. But then comes like the write operation related scaling, and for that you need to do the sharding. Sharding acts like the horizontal scaling. So the point is, in SQL the horizontal scaling or the sharding is bit complicated or difficult to do. You have to manage it, it's complex. But why? Let's understand why is it difficult in SQL to do like horizontal scaling or sharding. Why is it so complex? All right, let's understand that. Yes, of course you can do the horizontal scaling in SQL, but it is complicated. Why? Because first, sharding breaks the joins. We said like we'll follow the normalization in SQL, and SQL is also good for joins. But when we split into multiple shards, right, so the joins becomes quite difficult. Why? Because now you have to do joins across the shards. Okay, you have to do joins across shards, and that are really expensive, and those are really difficult. Okay, so it becomes hard. So the transactions also become hard because you need to maintain the ACID properties. That is the core of SQL. You need to maintain the ACID properties. But when you have to maintain ACID properties across the shards, it's very complex. Okay. Third point is related to operational complexity. Now the important thing to understand here is like the sharding or the horizontal scaling for SQL, it is not automatic. It is kind of managed by you. This is like app based logic. Okay. So your app logic is there which makes this sharding happen. But the problem with it is like re-sharding requires data movement, that we saw. Like re-sharding is the thing, like you have to do the sharding again because your particular shard is becoming like huge. Again you have to do re-sharding on top of it. So that has its own set of complexities. But one another problem is like because you are doing the sharding using your app based logic, so app logic has to handle a lot of things, and due to it, it becomes like complex. App logic must know the sharding mapping as well. When we talk about NoSQL, you'll get to know that in NoSQL, the horizontal scaling is kind of automatic. NoSQL database is built like that it doesn't need to do the horizontal scaling based on the app logic. It happens at like the DB level, you can say. I'll explain it to you when we talk about the NoSQL, but for now you need to understand in SQL it is not kind of automatic thing. Your app logic defines the sharding, so it becomes quite complicated. Like for example, a new shard added or a shard removed, then all that kind of things are handled by the app logic, correct? Whereas when we talk about NoSQL, which we will talk later, it handles that automatically at the DB level. So because in SQL it is handled at the app logic, it is complicated. Okay, and then it has other things as well, like for example there is limited flexibility. If you have to change the shard key, it is quite painful. So the sharding or the horizontal scaling in SQL is quite painful because it is handled by the application logic. The sharding at SQL is handled at the application layer. So for now you need to remember this. SQL, the sharding logic would be at the app level. Okay, I'm writing app here. Whereas when we talk about NoSQL DB, so in NoSQL DB, it will be handled at the DB layer. Okay, so that is automatic and it is quite easier as compared to in SQL. So in SQL, the horizontal scaling becomes like a difficult thing or a complex thing to handle. Okay, that is why when we talk about huge scale, then sometimes we give preference to NoSQL. When we don't rely properly on asset properties, when we don't need like asset properties too much, then if we are talking about huge scale, then we prefer NoSQL. Okay, don't worry, we'll discuss more about it. I mean, this part also, app based logic and DB based logic, we'll discuss it again when we talk about the NoSQL part, so that you get more clarity. But for now, just remember SQL is good for asset properties, consistency. It would be used for like financial related transactions, for banking apps. It is good in normalization. It is good in joins because SQL is basically relational database. So maintaining relation between multiple tables using the keys, it's about SQL. Joins is good in SQL, but problem comes when we talk about horizontal scaling or scaling the writes or using the sharding, because across shard, when you have to do joins and maintain the asset properties, it becomes really complex. And overall the sharding is not automatic in SQL. This is happening at the application layer logic, and that is complex to handle. Okay, all right, so this was about SQL. All right, before moving to NoSQL database, one more important doubt that I want to discuss, because maybe you have a similar doubt in mind. Okay, the doubt is, in normalization joins are fine, right? In normalization also we split the table, and in that joins are totally fine when we talk about SQL database. Then why join is the issue in sharding? In sharding also we are kind of splitting the tables. Then why join is difficult in sharding, whereas it was fine in normalization? Joins are really difficult. But why? How is it different from normalization? Let's try to understand that. Okay, so here is the fundamental difference. In normalization, we split the data, but that is only logically. But when we talk about sharding, we split the data physically. Now let's try to understand this with an example. Okay, so here you see the example of normalization first. We have normalized the table, so now we have two tables, users tables and the orders table. Okay, these have like separate columns. Basically, instead of having all the data in one table, we have normalized the tables into two different tables, users tables and the orders tables. Correct? So the important things to remember in normalization is that both the tables are in the same database. These are also on the same machine, and these are under one query engine. Okay, so that means it's not like physical separation. These are just logically separated. Okay, but both of these tables are on the same machine in the same database, so they are part of same query engine. So that's why join is easy here. We can simply do something like this: select star from, this is the left table, users, and we do the, say, any type of join here on the right table, and we provide the condition using the on keyword, right? So say for example we are doing the inner join of both of these tables based on this condition. The important part to remember, both of these tables are on the same machine in the same database and under same query engine. So database can read both tables, use indexes, and join row by row efficiently. So that's why normalization is just logical separation, nothing else. So that's why join is easy in normalization. Now let's take an example of sharding through which you will get more clarity. So sharding says this data is too big for one machine. Let's split it across multiple machines. So clearly you can see we are talking about the physical separation. That's why it's also called like horizontal scaling, where we talk about different machines, right? So like in normalization, we took the example, correct? Like this users table and the orders table. Now let's see similar for sharding. You can see this is the shard 1, which you can take as machine A, and this is shard 2, which is machine B. So two different machines, right? And in machine A we have data of users Rahul and Neha, whereas on machine B we have data of users Amit and Priya. So clearly you can see the users table is now split physically in different machines, because the data might be too big for one machine to handle, correct? For example sake, we took like 2 entries here, but you can imagine there can be a lot of entries. That's why we did the sharding. We need multiple machines to handle that kind of data, correct? So this was about the users table like we saw here. Similarly for orders table, we may need to do the sharding. So machine A will have orders like this, and machine B will have some other orders like this. Okay, so this order is for user 1 and this order is for user 3, correct? But clearly you can see these are on different machines now. Now let's see why joins are so hard in sharding. Say for example we apply this query, select star from, this is the left table, then we apply say inner join on the right table, and we provide the match condition using the on keyword, right? So this is your join query. But now as we saw, the data is present in different machines, right? So now database has to do a lot of things. It has to query machine A, it has to query machine B, and it has to move data across network. Why network? Because these are now two different machines. Data is not present in a single machine. These are two different machines. So in order to connect, you would require the network, which is slow, correct? And then you have to merge the results. Then you have to handle the failures. You have to handle the timeouts. So this is not anymore a normal join, correct? We saw in case of normalization, we were able to do the simple join because both of the tables were present in the same database in the same machine. So it was quite easy to do that. But now we are talking about different machines in sharding, and that's why it's not a normal join. It becomes a distributed join. Why distributed? Because there are different machines, correct? Now the distributed joins are very slow, very complex, and very failure prone. And that's why databases avoid joins across the shards. So in SQL, we earlier said that normalization is totally fine because we are splitting the data just logically, and SQL is good in joins, correct? Because it is like relation between different tables using the keys, and SQL is good in it. But when we talk about sharding, first of all, sharding is complex in SQL because that logic needs to be handled by the application layer, right? And on top of it, the joins become very difficult because it is no more the normal join, it is a distributed join now, because now the tables are split physically. So there are different machines which have this data. So you have to connect the data from different machines. That requires network, and there are a lot of complexities involved, and that's why it becomes so hard to manage or to handle the joins in sharding because it's a distributed join now. And as we are talking about SQL first, in SQL the main property it follows is consistency, and it follows the ACID properties, correct? And it becomes really difficult to maintain the ACID properties across the different machines. So when we are doing sharding and we are doing the distributed joins, it becomes really difficult to maintain the consistency of the data, and it becomes really difficult to maintain the ACID properties across the shards. That's why sharding is a quite complex thing in SQL. So in summary, as we were talking about normalization and sharding, normalization is logical split, whereas sharding is physical split of data. What does that mean? In normalization, you have the tables on the same machine, whereas when we talk about sharding, we have data on different machines. Like we saw the case here, right? the users table, some of the data is present in machine A and some of the data is present in machine B. Similar can be for the orders table as well, right? So in sharding you have different machines. In normalization, the data is under same database engine, whereas in sharding you would have multiple database instances. So when we talk about join in normalization, join is local, whereas in sharding join needs network, because we have different machines, and when you have to interact between different machines, of course you would have to require the network. When it's in the same machine, you can do that locally, so there is no need of network calls in a single machine, correct? So that's why normalization is fast and safe, whereas sharding is slow, risky and quite complex. So basically in normalization, generally you say you have a different table, but when we talk about sharding, it is not that simple. Different machines are involved. Also, there will be multiple database instances involved in sharding, and because there are multiple machines, so you would have to interact between the machines using the network. And there would be other complex things, like there would be no global lock, because it's easy to make a global lock on a single machine, but when you talk about different machines, you can't have a same global lock across them. So a shard is like a complete database which is present on a different machine. So in real life, simple examples if I have to tell, when you say you have a flat like a 3 BHK, correct, in a society, so that would be an example of normalization, because you have 3 rooms out here, correct? So 3 bedrooms you can say with washroom. So different you can say rooms, but all of these rooms are part of same flat, correct? So one flat, but you have 3 different rooms. Similar to that, in normalization you have different tables, but those are present on the same machine under the same database. But when we talk about sharding, it can be like one room is present in one city, like it is present in Mumbai, and another room is present in say Delhi, and one more room is present say in Bangalore. Okay, so different cities. So in normalization, because these are part of the same flat, so you can directly move from one room to another room. But here, if you have to go from one room to another room, then you would have to take flights, correct? You can't just like move from one room to another directly, because these are in the different cities, so you'll take the flights or any mode of transportation to reach there, so that this would be complicated. Similarly, when we talk about sharding in actual terms, so it would be kind of different machines are involved. Okay, so you can't interact with them directly, so you would require the network or API calls to interact between each other. And when we say like why SQL avoids DB level sharding, because SQL database are built around the properties like single node asset properties, because it follows the asset properties. Strong consistency is another thing that SQL database follow, and it is good in local joins like in normalization. But if we do the automatic sharding, then it would break the asset properties, but SQL is major for following the asset properties. If we do the automatic sharding like normally we do in NoSQL, then it would break the asset properties across the shards. It would also break the joins. It would break the transactions, because we were following or using the SQL database for these two important things, following the asset properties and strong consistency. But automatic sharding would break all of these. So that's why in SQL, if you shard, it is managed by the application. So the application layer is managing the sharding logic, and that is a bit complicated or complex to handle. So in SQL, you have app level sharding and not DB level sharding. Okay. Now you may say, why I'm using this term like DB level sharding? This is because in NoSQL, there is DB level sharding, which is automatic, and that is not handled at the app level. Don't worry about it. You'll get more idea as we discuss about NoSQL database. But just to give you the brief summary, NoSQL handles this thing in a better way, because in NoSQL, we assume that joins are bad. The SQL database is good in joins, so we do perform the join operations in SQL. But NoSQL, it assumes joins are bad, and it encourage denormalization. In SQL, we encourage the normalization, right? We split the tables logically, whereas in NoSQL it encourages denormalization, which means all of the data would be present in one place. So that's why it stores everything, whatever is needed together. So this is an example of NoSQL. You can see it contains like the user ID, name, and also the orders related information. So the data related to user and the orders, both of these are present in one place because it encourages denormalization. And because we have all the data in one place, so as there is no need of join, there would be no need to do the cross shard fetching as well. And you can get all the data in one read from one machine only. And that is why on NoSQL, the horizontal scaling is very good. Okay, and that is done automatically at the DB level, not at the app level, at the DB level. But don't worry about all of this. I just gave you the brief summary. Now basically what we will do is like try to understand about the NoSQL database, what are different types and what are the properties which are present in NoSQL database, through which you'll get the more clarity about it. Okay, so let's move to NoSQL databases. All right, the first question that comes in mind is, what is NoSQL? So in very simple terms, NoSQL is not only SQL or not only SQL. We discussed about SQL database or the RDBMS database, where it used to follow the properties like strong consistency, follow the ACID properties. It was good in normalization and doing the join operations. Now we are talking about NoSQL. So NoSQL databases are designed for massive scale. So SQL is not that great when we talk about massive scale. Why? Because we saw sharding or horizontal scaling is quite complex and difficult in SQL database. But when we talk about NoSQL database, it is designed for massive scale because horizontal scaling is not an issue in NoSQL. It is done automatically at the DB level. So apart from that, NoSQL is designed for distributed systems, right? High availability and flexible schema. Okay, flexible schema is another important point to notice here. In SQL, we had like fixed schema, correct? So SQL is good when you have like fixed schema. But there can be also the cases when you have like flexible schema, and for that we have the NoSQL. So unlike SQL or RDBMS, NoSQL systems assume that there can be node failures, there can be partial data availability, and there can be network failures. Now a basic question that comes in mind is, why NoSQL exists? Basically, NoSQL solves some of the difficulties or issues that were faced in SQL database, like horizontal scaling, which is quite difficult in RDBMS because we saw that sharding is quite complex in SQL database. We cannot do automatic sharding, and that's why it needs to be handled at the app level logic, which becomes complex, right? So it is hard in RDBMS, but in NoSQL it is built in. How? Because the horizontal scaling or the sharding, you can say, in NoSQL is done at the DB level. It is done automatically because all of the data that is required will be generally stored together, so we don't face the problem that we face in SQL, like some of the data in one machine, some of the data in another machine, and you have to use the distributed joins to get the complete data. So that is complex thing in SQL, but in NoSQL, horizontal scaling is kind of the built-in or automatic feature which is handled at the DB level. Next, when we talk about the schema changes, RDBMS, it is quite painful because in RDBMS or SQL, we have generally the fixed schema. Whereas when we talk about NoSQL, it has like flexible schema. So it is very easy to make any schema related changes. Next, when we talk about a point, say there are a lot of write operations happening. So in RDBMS, we have kind of limited scope for that, but in NoSQL, we have high throughput. So in case we have massive writes, NoSQL is generally better in handling that case, because again, as we discussed earlier, you knew that when we had to scale the read operations, we use the replicas in SQL. But when we talked about scaling the writes, we required sharding, and hence it becomes difficult, right? Whereas in NoSQL, it is known to handle massive writes. Okay. And when we talk about the global distribution, of course, in RDBMS or SQL, it is complex, whereas in NoSQL, it is kind of a native thing. So NoSQL handles all these things related to huge scale, a lot of write operations, schema changes, and global distribution in much better way. But you may say, how is this possible? It's very simple thing, like SQL follows some of the principles like strong consistency and following ACID properties. So it is really good in that. Whereas NoSQL, it would basically perform all these things as a trade-off. So the NoSQL is not good in strong consistency, okay? And it is not that good when we talk about following the ACID properties across the machines. So it would trade off such things for providing all these features. Alright, so now that we have mentioned consistency point here, so let's discuss a very important concept which is very frequently asked in interviews, and that is CAP theorem. So the first question comes is, what is CAP theorem? So basically in CAP, C stands for consistency, A stands for availability, and P stands for partition tolerance. Now the important part to understand here is, in the distributed systems, you can only guarantee 2 out of these 3 things, which means you can either have CA or you can have AP, okay, or you can have CP, but you cannot have all 3 of these. CAP is not possible when you talk about the distributed systems. You can only guarantee 2 of these, so only these combination can exist, CA, AP or CP. But now, because we are talking about the distributed systems, so this P part is required, which is the partial tolerance. Okay, so this one CA, this is not possible because we are talking about distributed system and P is mandatory in it. So you have choice between AP or CP, that is you can either provide availability and partition tolerance or consistency with partition tolerance. I know you would have questions in your mind, so let me tell you what each of these mean actually, and through that you'll get more clarity and we'll discuss some of the queries through which you'll get some more understanding. Okay, so first let's try to understand the meaning of each of these. First, when we talk about consistency, it would mean that every read returns the latest write. It means that whenever you perform the read operation, it should return you the latest kind of data which is present in the database. Or if it cannot return you the latest or most updated data, it will throw you an error. It cannot provide you the old data. Okay, so this consistency might confuse you with the ACID properties which we discussed in SQL, but this is different from that. Okay, you need to keep that in mind. In ACID properties, C was like more about like the constraints for the consistency check that you can apply, something like the money in bank should be greater than 0 before you can make a transfer, right? Or you apply the constraints like the not null or unique or any key related constraint, all such kind of things that you need to apply. But here consistency means, say in database, okay, you had value of something like say I, earlier it was say 10, okay, and someone made a write operation here and updated it to say 12. Okay, so the point of consistency here is, if someone makes a read operation here, you need to return this updated value. You cannot return this old or stale data. You have to return the most updated thing, or just in case you cannot, you have to return an error. So that is what consistency stands here for. That if like all the people are getting like same kind of consistent data, whatever changes you made, you're getting the latest data. Similarly, someone else is checking or reading the database, they should get the same data. Of course, it looks quite simple when you talk about single machine, but because we are talking about distributed systems, so you understand we have multiple machines in which data is present. We talked about like different architectures like master slave in SQL, correct, where you would make the changes or write operations in the master or the primary, but you would read from the slaves or the replicas, correct? So of course, we also talked like if you update the replicas, then your write operation becomes slow because you have to wait for all the replicas to be updated, correct? But if you just write in the database and you don't update the replica at that time, then the consistency can suffer, correct? Because you are reading from the replicas, not from the primary database. So in that kind of scenario, you might return the stale data or the old data, like 10 might be returned, but we don't want that. When we talk about strong consistency, it means either you return the most updated or the latest value, or you simply return an error. Okay, so this is the meaning of strong consistency here. Next term is availability, which means your system should be available. Like for example, this is your system, or you can say database. So any request which comes to your system, it can be any time, because your system is distributed and it might be serving the request from all over the world, correct? So we have different time zones, so you may get the request anytime, so you need to be available 24/7. So every request that comes, it should get a proper response. There should not be any error in that part, correct? So your systems cannot go down, and your systems cannot be like it is crashed, it is not giving response, or it is giving just errors. It has to give the proper response, correct? And the third one is the partition tolerance. So partition tolerance means system continues to operate despite network failures. So in easy terms, you can make it or understand it like there is no single point of failure, so that even if one of the machine goes down, your system as a whole unit should perform. How do you do that? You have like multiple machines out there, you do the horizontal scaling, or you have like partitions, like through which even if there are some failures, your system as a whole unit should be able to operate. It's not like if one machine is down, your complete system goes down. No, that is single point of failure. You have to avoid that, because we are talking about the distributed systems. So you will have different set of machines which can handle the failures. So if one machine is down, you have to distribute the load across other different machines so that the users can still get the data, correct? So now why we said like CA is not possible, because we are talking about the distributed systems. So P, or the partition tolerance, is a required or a must thing, correct? Otherwise we won't have the distributed systems set up, because we are talking about distributed systems. So in CAP, we either can provide consistency with partition tolerance or availability with partition tolerance, because P is mandatory as we are talking about distributed systems. But now the question comes, why we are saying we can guarantee only two of these? Why can't we have all three of these, like consistency, availability, and partition tolerance? So let's try to understand that with an example. Okay, say we have like two nodes, right? We have node A and node B. So this is like, you can say, the partition that we have, like different nodes out there. Now we will see the two scenarios here. Okay, the option one, first we are focusing on consistency. We said like there are three things: consistency, availability, and partition, correct? So partition is always there because we are talking about the distributed system. You can also see here we have multiple nodes here, correct? First we'll focus on the consistency, and we'll try to have the availability as well, and we will see why we cannot have all three of these together. Okay, so we'll first focus on consistency. So consistency and partition, correct? So what happened here is like we made the change on node A, like we saw the earlier example. I was say 10. Okay, the value of 10 was present on both of the nodes, node A and node B, and now someone changed the value of I to 12. So node A has value 12, whereas node B has value 10 right now, because the write operation we performed only on node A, and it did not wait for updating all of the other nodes, because it would become very slow, correct? So in this case, in case a request comes to node B, right? Now what strong consistency means? Strong consistency means either it will give you the most updated data, which is 12, but it cannot give you that because it has the old data right now, it has the stale data. So there were only two things: either it will give you the most updated data, or it will return error. Now because node B cannot return you the most latest data, because it has not synced with node A yet. So what strong consistency means? If it cannot give the latest data, it will give an error, correct? So the node B will reject the read request, or it will give the error. But if this is done, then the availability is sacrificed. Why? Because availability meant that every request receives a non-error response, but we are throwing an error here because we are following consistency. So that is why here you can see we cannot follow all three of the properties, right? We are following just C and P, consistency and partition tolerance. Now what is the second option? The second option is following availability with the partition tolerance. So in the same example, if the read request comes on node B, then because we are following availability here, so node B will serve the old data, that is it will return, say for example, the value as 10 instead of 12, which is the old or stale data. Now because it has returned to the response, we are good with the availability because we have not thrown an error here, but we have sacrificed the consistency because we have not provided the latest data, we have provided the old data, so we are not following consistency here. So that is why here the availability factor was done, but we have broken the consistency, so we are following only availability with partition tolerance and we are not including consistency here. So clearly you can see in both of these cases we are able to follow only two of the things, either we are doing consistency with partition tolerance or availability with partition tolerance. We cannot do all three of these together. So basically when we talk about the distributed systems, you cannot do all three of these together. Like consistency, you require the latest data, right? But at the same time, availability means you give the non-error or proper response to all of the requests. So both of these cannot work together when we talk about the distributed systems, correct? So we saw both of these options. So either you have to choose between consistency with partition or availability with partition, because you cannot serve the latest data to all the requests which are coming. You would either follow consistency where you will provide the latest data or throw an error, but when you throw an error, it impacts the availability. Whereas if you give the data to all of the requests, then you might also give some of the old data to some of the requests. In that case, consistency is impacted. And this is the scenario when we are talking about distributed systems, correct? Because we are including the partition tolerance in it, right? So when we talk about distributed system, the CAP theorem says you can only guarantee two of these, okay? And when we talk about two of these, CA is not possible because partition is a required factor in distributed systems. So either AP or CP. Now a basic question that may come into your mind for CAP theorem is CAP theorem applicable to SQL database? The answer is yes, if the SQL database is distributed. In CAP theorem, we talk about the distributed system, correct? So we mentioned distributed systems here. So in SQL, if you have like distributed system, you have replicas out there, different nodes are present out there, then CAP theorem would be applicable to it as well. Which means if you talk about distributed system in SQL, you can provide like either CP or AP. Same is the case for NoSQL. So even in distributed SQL, it's a choice between CP or AP. But generally when we talk about like SQL systems, strong consistency is preferred. So generally it would give more preference to CP instead of AP. Now another common question that appears in the mind is, can we decide for CP versus AP per request that we make? So basically the answer of that is a modern concept, which is like the tunable consistency, which means like some systems let you choose this, like what do you want to choose, how much preference you want to give per request as well. For example, the Cassandra database, which is like NoSQL database, which we will discuss later, like because we are going to discuss more about the NoSQL database. In that basically you can decide how much consistency you want or how much availability you accept, okay? So it's kind of like per request you can choose some of these dynamics. So it's kind of like on runtime you are deciding what preference you want to give. Okay. Alright, so before we talk about the types of NoSQL databases, let's discuss few of the things that we mentioned earlier. Like we said, horizontal scaling is built in NoSQL and massive writes is easier to handle in NoSQL. Why is that? So let's discuss about that in detail first. Okay, the first question, how is horizontal scaling built in NoSQL? We earlier discussed like it is difficult to do horizontal scaling or sharding in the SQL database, but how is it built in NoSQL? So basically the NoSQL database is designed for distributed systems from day one. The basic design of NoSQL is according to that fact only. So when we talk about scaling in RDBMS, the basic thing comes up is the scale up or the vertical scaling, which means you would look for bigger machines. Why do we say that? Because sharding is painful and manual process in SQL. When we talk about sharding in SQL, it has to be done at application layer. We discussed about that earlier, right? But when we talk about NoSQL, it is designed for distributed systems. So you can scale out, or you can do the horizontal scaling very easily. It's just you have to add the nodes in it. And why is that possible? Because sharding is automatic in NoSQL database. Because that is handled at the database level, sharding is done in NoSQL database, not at the application layer. So in NoSQL database, partitioning is the core feature. So basically in NoSQL you have like nodes, okay? So we have multiple nodes in NoSQL, as partition is the basic or the core feature of NoSQL database. Like for example, we have calculated the partition here using the partition key. Like the user ID can act as a partition key. It depends like what kind of partition key are you deciding. But the main point is every record will know which node it belongs to, say this one, and which replicas store it. Now we will have the replicas just like SQL, because the replicas were there for scaling the read operations, and we would require that in NoSQL as well. Another important part of the NoSQL is that each of the node will have its own CPU, on disk and on memory. So in this case there are no central bottlenecks and there is no master for writes. Now another important part to remember here is that we use consistent hashing here to identify the partition. Okay, all of the nodes are basically part of this circle, you can say, and through consistent hashing all the nodes are part of this ring, you can say, and we will use the consistent hashing approach to identify the node. Now if you want to know in detail about consistent hashing technique, put that in the comment section. I'll create a separate video on that part. But if I have to tell you in summary, so consistent hashing is really helpful when you have to add or remove a node, because if you use the simple hashing technique, it would be something like your partition key and you will do the modulus with the number of nodes. Okay, say earlier the number of nodes were 4. Okay, so your hashing method will be something like this. This is your key and you do modulus with the number of nodes. Now say you increase the number of node by 1. Okay, so your method will update. So instead of 4, now you will take the modulus with 5, and due to this most of the values will get changed. Okay, so there will be a lot of change that would be happening because you have added or removed any of the node. Like removing of the node is also very common thing, because one of the system or your node can go down due to any particular reason, correct? And due to that your hashing method would change, and all the outputs that you generated for the node, that would also change, correct? So in hashing you will see a lot of changes happening when you add or remove the node. So in order to handle that, you have the technique like consistent hashing, where if a particular node goes down or you add a new node, there will be very minimal changes that would be happening, because all the nodes are present in a ring format. Okay, so this technique of consistent hashing is really helpful in evenly distributing the load, and at the same time it has very minimal impact if you add or remove a node. So going back to the main question, so basically as you store all of the related data in one place only in NoSQL, and then you have your horizontal scaling happening at the DB level and not at the application level. You have partitioning as a basic feature. We saw like there are multiple nodes, each of the node has its own like CPU and memory, so we are not sharing all the resources out here. And the techniques like consistent hashing, overall that is why horizontal scaling is built in the NoSQL database. Now because we have mentioned node and partition, the very basic questions that may come to your mind is what is a node and what is a partition in NoSQL. So basically when we talk about SQL database, we think about the tables, rows, primary keys, foreign keys, then we have joins, and then we think it as one big database, because sharding or horizontal scaling is difficult to manage, or it is complex in the SQL database, correct? So SQL was like structured data in tables, and tables can connect with each other or have relations using the key, correct? And then we have joins in it, right? But when we talk about NoSQL database, we would think about keys, partition, node, cluster, and no joins, because NoSQL doesn't believe in joins. We want to keep all the related data together, so there is no requirement of join here. So basically a node in NoSQL would represent one machine or one database instance which is running NoSQL. So a node can be represented as your laptop, a server, or a virtual machine. So one machine, or a database instance which is running NoSQL. So we can represent it as like node 1 machine A, node 2 machine B, node 3 machine C. So each of the node is representing a different machine, and together they form a cluster. And as we discussed earlier, each of the node will have its own CPU, own disk and own memory. Now that we have mentioned that node is basically representing a machine, why do we need multiple nodes? It's very simple. One machine cannot handle the complete load. As the number of users increase, you would need to scale. And one of the format is horizontal scaling, correct? So you would require multiple machines, so you would require multiple nodes. And also when we talk about the distributed systems in system design, we have to avoid single point of failure. If there is only one machine, then of course there is a single point of failure, and we need to avoid that. So we would require multiple nodes. Now when we talk about partition, partition is a piece of data. It's not a table, it's not a machine. It's just a logical slice of data, you can say. So if I have to give you a real life example for partition, it would be, think of a big book, okay? Now instead of one huge book, we want chapters in it. It makes things easier for you. So partition is like chapters. You are doing partitioning of the book and it makes things easier for you. One chunk of data or logical slice of data, you can take it as one chapter, okay? So instead of one complete huge book, you see it as like chapter 1, chapter 2, chapter 3 and much more. So each of the chapter in real life example is representing partition. So this was a realistic kind of example, but when we talk about database, so instead of taking as like complete all huge data, you divide it in multiple partitions like partition A, partition B, partition C, and each of the partition will contain a subset of rows based on some rule. Now these rules can be like the partition can be decided by some key range or hash, or like we discussed earlier, consistent hashing. So basically node is a machine, whereas partition is a chunk of data. Now one thing comes in mind is like, where does partition reside? So partition lives on machines only. So partition lives on nodes, okay? So like this, you can see node A has partition P1, node B has partition P2, node C has partition P3. But the important thing is that this mapping is managed by the database and not your application. So this logic of partitioning, the horizontal scaling on NoSQL, it is handled at the DB layer. It is not handled at the application layer. So if you remember, we discussed in SQL, this logic of horizontal scaling was handled at the app level and not at the DB level. But in NoSQL, this complete logic of horizontal scaling, the nodes and the partitioning, this is handled at the DB level. Now one question may come into your mind, are partitions always on different machines? Because we said that partition lives on machines, so is it that the partitions always are on the different machines? Multiple partitions per node, which is quite common. The answer is not always, okay? There can be multiple different possible setups. First can be one partition per node. Like here we saw A, for node A we have partition P1, node B partition P2, node C partition P3. But there can be another scenario where we have multiple partitions per node, and this is quite common. So for example, if you see here on node A we have partition P1, P2, P3. So multiple partitions can be on the same node as well. So a node can have multiple partitions, and the next setup can be same partition replicated on multiple nodes. And this is a case of replicas. So here you can see an example where multiple nodes are present in a partition, but this can happen only in the case of replicas. For example, you see partition 1, the primary copy is present in node A and the replica copy is present in node B. So only in case of replicas, same partition can be replicated on multiple nodes. So all of these scenarios are possible. So we won't always say like partition will be always on a different machine or node. Now I know, because we have mentioned the node is a different machine. So one question that may come into your mind is like, why NoSQL partitioning is different from the SQL sharding? Because in sharding also we have different shards or machines on which this data is present. So how this NoSQL partitioning is different from the SQL sharding? So say if we talk about the SQL case and we have like 1 million users, correct? So this can be the distributions, user from 1 to 250k, those would be present in shard 1, and then 250k to 500 shard 2, 500k to 750k on shard 3, and 750k to 1 million on shard 4. Now each of the shard is representing a different machine, correct? So this data would be present on different machines. But the main point is this logic, like how you decide which user is going to which shard. This is done manually on the application layer. So it would be something like this. If user ID is smaller than 250k, then we will write the logic like shard 1. So we have selected shard 1. Similarly, we would do the other cases like else if it is between 250 to 500k, shard 2, and like that. And similarly, we would put all the cases and select the shard according to that, and that is handled on the application layer, the code, that code we write. So the basic point is the database is not aware of this logic that we have mentioned. It's the app which decides like where the user data should go to. So each of the shard represents a complete database on a different machine, and that logic which shard is selected is handled at the application layer. Now what are the problems associated with this SQL sharding? As we discussed, application knows the sharding logic and this is not handled by the database. So it is very hard to rebalance, and even if you add a database, it would be painful because this logic is present on the application layer, and it might be something like a hard-coded thing, or you are handling it with some external side, but you need to keep an eye on this logic, correct, whenever you basically add or delete the shard. And another thing that we discussed earlier, join across shards is very difficult, complex, because it becomes the distributed joins and it has its own set of issues. But when we talk about NoSQL, things are different. So you can think of something like shard is a separate database on the separate machine, whereas node is representing the machine running that database. Okay, now this was about the SQL sharding, but when we discuss about NoSQL partitioning, it is the database which will decide all the things. Like for example, whatever key comes, we will apply consistent hashing on it, and based on that you will get the partition, and from the partition you'll get the node as well. So this logic is handled at the DB layer. Okay, so the database does all of this, and it is not handled at your app layer, because everything was handled at the application layer for sharding in SQL, but this part is handled in the database layer for NoSQL. So it's a DB which figures out which is the partition, which is the node, and it routes the request automatically to it. So basically you can say it like it's your database which is splitting the data, which is deciding which partition and node it is. So basically here is the thing, the chart which will make things easier for you. So when we talk about table in SQL, that is a logical structure and that is managed by database, right? When we talk about shard in SQL, it is like full database on a machine, on a different machine. When we talk about different shards, those are like full complete database on different machines, correct? And that is handled by the app layer on SQL. This is an important thing to remember, because this is handled at the application layer. That is why sharding is complex in SQL. When we talk about partition in NoSQL database, it is like a chunk of key space, and this is managed by the database. Similarly, when we talk about node in NoSQL, you can say it as a different machine, and this is also managed by the database. So shard is like machine level split, whereas partition is like data level split. So when I was learning this topic, one thing that confused me a bit was like partition versus the table. So these are completely different things. So as you know, table has the columns, schemas, and you can write queries on it, correct? But when we talk about partition, it is invisible to you. There is no schema meaning when we talk about partition, and it is only used for distribution. You will never query a partition. You used to write queries for the table, right? But you would never query a partition. Another thing is like database will move the partitions around quite freely, because it is just like chunk of data. So as we mentioned here, the partition is invisible. Basically, node is the database instance running on the machine, whereas partition is just logical. Node is physical, partition is just logical. Alright, because we have talked about nodes and partition, the next question that comes to mind is, why do partitions exist at all in NoSQL? So why do we have concept like partition in NoSQL? So we mentioned the concept of nodes. So why not just split the data directly by node? The reason is because the nodes change, and if we split the data by nodes, then there would be instability. We want data distribution to be stable. So basically nodes are unstable. Nodes can be added, nodes can be removed, and nodes are slow. But data needs stability, right? We can't keep the data in nodes because those are unstable and they keep on changing. So that's why we require the partitions, because partition is like logical split of data, and we use consistent hashing approach through which things are quite stable and rebalancing is quite minimal. So basically from the key we get to know the partition, and from partition we get the node. Now let's see some of the problems that partitions solve. Number one, say we put everything on nodes instead of partition. So without partition, you would have something like this. Node A has 50% of data and node B also has 50% of data. Now if we add another node, node C, because we will keep on doing the horizontal scaling, right? So in order to distribute the data evenly, now each of the node will have kind of 33% of data, correct? So earlier you could see there was 50% data present in node A and node B. Now you can clearly see instead of 50% it should have now 33%. So there would be a huge amount of movement of data from node A and node B to node C. So clearly you can see we will have to move 33% of the data from node A plus node B, because that we will shift to node C. That is why we said it's a huge movement. Now with partition, what we will do is like 100 partitions in total, and those will be distributed among the nodes. Like node A has 34 partitions, node B has 33 partitions, and node C has 33 partitions. So when we talk about movement, only few partitions will move, not all data. Next thing, if we talk about the load balancing problem, there can be a point where some data is hot, like user 1 has millions of requests, because user 1 can be, say, a famous personality, right? Like for example, you have the database for all the users, and then in between you also have the users like who are famous, like Ronaldo or Messi, correct? So there can be a problem like some data is hot. So partitioning lets database split hot ranges and move partitions independently. If we talk about without partitions, the whole node will be overloaded. After this, the problem 3 which partition solve is the failure handling. Say for example, node B dies. You had like multiple nodes like node A, node B, node C, and many more. Say now node B dies, which can happen, correct? Because due to any specific reason, a particular machine or the instance of the database can die, right? So if that happens, whatever partitions were present in node B, those will be lost. Like P4 and P5 say were the partitions which were present at node B, those will be lost. Okay, what database can do is like promote the replica partitions, because as we discussed earlier, there will be replicas of the partitions, correct? So whatever partitions are lost, the replicas will be promoted by the database, and it will reassign the ownerships, right? So in this way, the partition is handling the case of failure, correct? But if we talk about without partitions, what would have happened is like the whole machine would be lost. So that would be a really big issue. So this way, like having the partition solves multiple problems, and that's why we have the concept of partition in NoSQL database. So basically, if we say why NoSQL introduced partitions, because partitions allow automatic rebalancing. As we discussed the consistent hashing approach, through that the load will be distributed in evenly manner, and in case the node is added or removed, that is also handled very well using the partition. Similarly, it is really good when we talk about scaling, and it provides the option of DB controlled routing. So using the partitions, everything can be handled by the database and no application level changes are required. I know maybe still it's a bit confusing for you, so let me explain it to you with a very simple real life example. So without partition, we can think of it as like node is a suitcase, right? So you have this suitcase, trolley bag, correct? And your data is the clothes which are present in it. So multiple clothes are present in it, correct? So you put all the clothes in the suitcase here like this. Now your flight allowed you to take one more suitcase, so you added one more suitcase, correct? So this is the second suitcase. So what you need to do is like move out the clothes manually from here and then put it in this. So 50% clothes you will keep it here, and rest 50% of the clothes you will put it here. So let me remove some of the clothes from this suitcase, right? So you are doing this manually, put some of the clothes from here to this one, right? So this is the case when we talk about without partition in technical terms. Now when we talk about the case with partitions, it will be like clothes are packed in small bags. Okay, so instead of directly keeping the clothes in the suitcase, what you want to do is like you would want to keep those first in the small bags, and then the bags will be distributed in the suitcase. So instead of keeping all the clothes like this, now I have multiple bags out there. Okay, and inside the bag I have these clothes. Similarly, one more bag here, and inside this I have kept the clothes. One more bag here and kept the clothes here. So you can see I have like 4 bags in this suitcase 1. And now if I add the suitcase, so instead of manually putting the clothes there, what I'll do is like I'll just simply move the bags. So these 2 bags I'll simply pick and put in this other suitcase. So I'll simply keep these 2 bags inside this suitcase and these 2 in this suitcase. So it makes things quite easier for you, correct? So the partition here is acting as your small bag. Node was like suitcase as like earlier example. So the DB instance running on different machine is acting as the node, just like the suitcase here. But the partition is the small bag inside which you are keeping the clothes, or in technical terms, partition will have the data. So instead of manually moving the data from one machine to another machine, you will just take the partition and move some of the partitions. Okay, so it makes things quite easier for you, and that is why we have the concept of partition in NoSQL database. So basically partitions exist so data can be moved, balanced and replicated independently of the nodes. As you can see in this example as well, instead of manually moving the clothes or the data, what we are doing is like we have the partitions. So we simply move this partition and it makes things easier for you. Data can be moved, balanced and replicated independently of the nodes. Alright, so we have mentioned it multiple times that in SQL database, the sharding logic or the horizontal partitioning or the horizontal scaling, that was happening at the database level, whereas in NoSQL, this logic of like horizontal scaling or partitioning, this is basically handled by the database layer. So the basic question that would come into your mind is like, if NoSQL can do DB level logic to do the horizontal scaling, why can't SQL database just do the same? So a simple answer to this question is SQL database cannot do that without breaking their core promises. Now, what were the core promises that were given by SQL? Those were strong ACID transactions. We discussed about the ACID properties earlier in this video, and we mentioned that it's a main kind of feature that SQL provides, correct? The second promise is joins across table. So SQL or RDBMS is like relational database, which means multiple tables are related to each other via the keys, correct? And if there are multiple tables, then you would require to join the data, and SQL is good in joins, correct? And the third thing is the constraints, like the foreign key, unique constraint and much more, correct? So these were the promises that were provided by SQL database. Now basically these promises assume that data is local, locks are local and order is known. Now when we talk about NoSQL DB level consistent hashing, that assumes data can live anywhere, okay, and nodes can disappear, network can fail. So this directly conflicts with the SQL promises. So let's try to understand this with an example, okay? So let's say these two are the tables, users table and the orders table. First we'll take an example of SQL, okay? So what we'll do is like, we'll do a transaction in SQL. So what are the operations in that? We'll do the begin, we'll do the insert operation in the orders table and put some values in it. Then we will do the update operations on the users table, and we will update the balance, okay, and then we will finally commit. So this is one transaction, so all of the operations will be part of one transaction only. Now because SQL guarantees the ACID properties, so SQL will guarantee all the operations in this transaction, correct, like these two operations, insert and update, either both succeed or both fail. It won't happen that one will succeed and one will fail. In case that happens, it will roll back the other operation as well to the initial state, correct, the atomicity feature in ACID, correct. Another thing the SQL guarantees is the balance will never be wrong or there is no partial state. So basically, as you remember, we follow the ACID properties in SQL database. So this was a case of normal SQL. Now let's imagine SQL is following the DB level consistent hashing that we follow in NoSQL database, correct? So something like this can happen. The user ID 101 can be on node A and the order ID 1 can be on node B. So when we talk about this situation for these operations, so what will happen is like the first operation is on the orders table, correct, and on the ID 1. So order ID was on node B. So what node B will do is like insert the order, correct. So the next thing was update users table with ID 101. So 101 user ID was on node A. So node A will update the user balance. But let's say before this step, okay, the step 2 where we had to do it on node A, the network fails between A and B. Then in that case, the order has been created, but the balance was not updated. So clearly you can see one of the operation is successful, one can be failed, correct? So in that way, the ACID will be broken because the A in ACID stands for atomicity, like all the operations which are present in the transaction, either everything should be successful or everything fails, roll back to the initial state, correct? But that is not happening here because we have different DB instances on different machines, correct? Each of the node represents a DB instance on a machine. So we have different machines, and in case we are having like multiple operations on different nodes in a transaction, but due to some issue there was a failure between the two machines, they cannot communicate to each other, so one of the operation passed and one of the operation failed. So if we were following this in SQL, and if SQL tries to fix this issue, it would need a distributed transaction because we have like distributed system now, right? Like node A and node B, different DB instances of different machines basically. So you would require the distributed transaction, you would require the global logs because we have different nodes here, and what this will cause is like high latency, low availability, and huge complexity. Now why SQL refused to do this automatically? Because now we are talking about like the distributed nodes, like you have node A and node B, some data can be present on this one, some data can be present on this one. So just imagine like if this is happening automatically, a very simple query like this, select star from users, join orders, we are applying the join here, but the problem here is like we have different machines here, so you would have to fetch data from multiple nodes and you have to move data over network because these are different machines. Now it's not like data is present in single machine, you have different nodes, which mean DB instance on different machines. So the joining of data would be like the interaction happening over the network, right? And it would also require to lock the rows across the machines. It is kind of the similar problem that we were discussing in sharding as well, right? Because in sharding we said like it would be on the different machine, it became like the distributed joins. So the similar problem appeared here as well when we talk about following the DB level consistent hashing, because here also we have like the nodes present, correct? So overall the SQL performance would collapse. Like sharding is a complex thing in SQL, similarly this would become a complex thing. So that is why in SQL the philosophy is that it will stay single node per transaction to keep things simple. If you want distribution, you decide it on the application layer or you apply the logic on app level. That is why we don't do it on the database level, because if we start doing it automatically on DB level, all such kind of issues will appear. And overall, because the ACID properties are guaranteed in SQL, things will become very complex and the performance of SQL will collapse. So that is why we do handling on the app level in SQL, which is like controlled distribution. So what we will do at app level is like, so basically this logic of like sharding will be done at the application layers. So application knows the user ID is the shard key and users plus orders are co-located because we do the control distribution. So app ensures user 101 that we were talking about and his orders like the order ID 1, those will be on the same database. And now the transaction is safe again because you have to apply the ACID on the same kind of DB, and even the joins will happen on the same database, same machine. So you don't have to do it like on the separate machines because you are handling that at the app level. So everything is controlled here. So basically the app based sharding, it limits where SQL is distributed. Whereas when we talk about DB based consistent hashing, it distributes everything blindly. Okay. So that is why we use the app level based sharding in SQL database. But now you will say how the consistent based hashing is working for NoSQL. So now let's see the same example in NoSQL database, what happens and how it handles it. The main funda is NoSQL changes the rules. The rules for SQL were different. It has to follow the ACID properties and all the priorities it has, whereas NoSQL has its own set of rules. It has its own set of priorities. So this is one of the example of how you will keep the data in NoSQL. So we have taken the example of Cassandra database in NoSQL. Later in this video when we discuss like the types of NoSQL databases, but here you can see we have like orders by user, which contains the order ID and the order list. So everything for user 101 would be in the same partition and same node group. So basically NoSQL does not promise multi-table transactions, joins or foreign keys. The joins and the foreign keys are for RDBMS because it means like relational database. The multiple tables can relate to each other using the keys, and SQL is famous for joins, but NoSQL does not promise anything like that. So basically what it can safely do is like based on the user ID hash, it will find out the partition, and from the partition it will get the node. So no global coordination is required here. So long story short, if I have to tell you in a very simple way, why do we have different handling in SQL and NoSQL? Why SQL handles this logic of sharding at app level whereas NoSQL handles it on DB level? The reason is both of these database promise different kind of features. Like SQL promises you ACID transactions. Like SQL provides you feature of ACID properties, correct? Strong consistency, relation between different tables using the keys, and it is good in joins, correct? Whereas NoSQL has its own sets of features and priorities. NoSQL doesn't guarantee you following the ACID properties across the nodes. Okay, so if I show you in that table form, if SQL adds DB level hashing instead of handling that at app level, then if it has to keep the ACID, it will become very slow and unavailable. The example that we just saw before this, correct? And if it drops ACID, it becomes NoSQL because NoSQL doesn't guarantee ACID across nodes, whereas SQL guarantees the ACID properties. So if you keep ACID using this approach of NoSQL, then it becomes very slow and unavailable. If it drops it, then it is no longer SQL, correct? Then it is a NoSQL. If it keeps the join, it breaks the scalability because you have to now apply the join across multiple nodes. Again, it becomes like a distributed join, right? Which is very difficult. Whereas if it drops the joins, it breaks the SQL promise, correct? So you can't keep everything. So both of these SQL and NoSQL have their different set of properties and promises they provide, and based on that they handle it in their own way. Now another thing is, in the modern scenario there have been a few databases which are combination of both of the properties of SQL and NoSQL. So they are providing both of these, which we will discuss later in this video at the end. But they come with their own set of challenges, like they are really expensive in some of the things. Okay, so basic point is SQL, NoSQL provide different kind of promises. Okay, and based on that they handle it in a separate way. So SQL handles the horizontal scaling or the sharding using the app level logic, DB level consistent hashing approach, you can say. So next, let's discuss about what are the types of NoSQL databases. Alright, so these are the four major types of NoSQL database. First one is key value database. Some of the examples are Redis, which is very famous. Another example is DynamoDB. Okay, how key value database stores data in terms of key value pair. Just like you know the hash map or dictionary, right? You have the key and corresponding to that you keep the value, right? In similar way, key value databases also keep the value in key value pairs. Okay. The next type is the document database. Some of the examples are MongoDB, which is very famous, CouchDB, Firestore. And how data is stored in this one? Data is stored in JSON-like documents. Don't worry, we'll discuss about each of these in detail, but for now, let's take a brief summary, okay? The third type is wide column databases. Some of the examples are Cassandra, again very famous. Another example is HBase, okay? How data is stored in wide column database? In this, you have like dynamic columns. So rows will have the dynamic columns, and these are optimized for write heavy workloads. So you would have dynamic number of a lot of columns present in wide column databases. Okay. The fourth category is graph databases. Some of the examples are Neo4j and Genus Graph. Now, how data is stored in graph-based databases? Using the nodes and edges, because as the name suggests, graph is a format. So we store it in the graph format using the nodes and edges. Okay. So these are the four types or categories of NoSQL databases. So what we will do now is like walk through each of these in detail so that you get more clarity when which one should be used. Okay, so let's start with the key value database. And of course, the first question that comes to your mind would be, what is a key value database? The basic funda is the key value database will store the data in terms of key and value. So this is the key, and corresponding to this is the value. Okay, so you can think of it as a dictionary or a map or hash map, but the major part is data lives on disk. When you talk about like hash map or dictionary, then we know it is not persistent storage, right? But here when we talk about key value database, the data lives on disk and it is distributed across machines. So it is not like if your machine goes down, all the data is gone, correct? Because when we talk about hash map or dictionary, it is like when your process is killed, that data is also gone, correct? But when we talk about key value database, it is like distributed across machines. It is also like fault tolerant and very fast. So this is an example how data is stored in key value database. Okay, so this is the key. You can see user 101, this is a key, and corresponding to this we have this value where we have stored the name of the user and age of the user. Okay, as we discussed earlier, one of the example of key value database is Redis, which is very famous. So some of the properties of key value database is that it is extremely fast. It has very simple structure, as you can see here. How it is fast? Like basically you can directly get the data based on the key. So you will basically search via key and you will simply get the value out of it. Okay, and it is easy to scale as well. So these are the good things about it. What are the challenges? It is not good for joins and it is not good for complex queries. So basically you cannot ask it like give me all users older than 25 because everything is based on key here. So it is not good for all such queries. And you cannot ask like join users with orders because it's not good for joins. Okay, you can ask it like give me the value for this key, as we are storing the data based on the key. So when you ask for a specific key, it will return you the data or value very quickly. Okay, so if we talk about the use cases of key value database, it is used for caching. Yeah, Redis, as we know, it is very good for caching, very quick. It is also used for like session storage, rate limiting, and OTPs. You might have already used Redis for all such things like storing OTPs or for caching purposes, right? So these are the use cases of key value database. Now, as we are talking about key value database, one question that may come into your mind is like, why key value databases exist? Basically, key value database optimize in one thing extremely well, which is fast access by key at massive scale. So as it stores the data like in key value format, so even when we talk about scale, if you give the key, it will give you the data corresponding to that key very quickly. Okay, so that is what it is amazing in. So these are the problem which key value database solve. First one being millions of reads or writes per second. Then low latency, simple data model, and easy horizontal scaling. Now because it is a NoSQL database, of course horizontal scaling is one of the features of that, but when we talk about like quick access based on key, I mean key value database are best in that part. Okay, and also you could clearly see it has like very simple data model, like you put the key and corresponding to it you can put the data, right? Now some of the core operations that we have in key value database are basically you will provide the key here and based on that you'll get the value. Okay, so it will be used to fetch the value. It is very similar to what you might have used in like hash map or dictionary, correct? So any language that you have used like Python or Java, in Java you have the hash map, correct? So you have this get method out there through which you get the value of the key. Similar to that, most of the key value database provide this operation of get, where you provide the key and corresponding to that you'll get the value. Next operation is put, again very similar to the hash map thing in Java, you might have already worked on it. So basically you provide the key and the value, it is kind of the insert operation you can say. So it will store the value corresponding to this key, it will store this value. Okay, next operation is delete operation, so you will provide the key and it will remove that entry. Okay, another operation is exists. Basically through this operation you will simply check so whether this record exists or not. Now some of the key value database support TTL, which is time to live, so it is kind of expiry that you can set. Some also support atomic counters, like Redis provides like the INCR atomic operation, correct? And some supports conditional writes as well, which we have used in this system design video as well. Go check that out, you'll get the clarity how we are using these things. This is a good concept that you can use while designing your system design problems, correct? And some key value database also support conditional writes. All right, so now we know like how key value database stores the data. Next question that comes in the mind is how data is stored internally in key value NoSQL database. So basically the step one would be the key hashing. Okay, so based on the key that you provide, it will find out the partition using the hashing. Step 2 would be from the partition you'll get the node, and step 3 would be the value is stored in the node, which can be in memory, on disk, or on both. So it is something like this. First you have the key and then you do the hashing on it, from which you'll get the partition. From partition you'll get the node, and when you get the node you store the value in the node. Quite similar to what we discussed earlier in this video about NoSQL, right? We had like data, we had like node, we have the partition. So that example also that I told you earlier, the suitcase having the boxes and inside the boxes you have the clothes, correct? All right, next let's discuss about the horizontal scaling, or how key vault database scales so well. So the first reason is no joins and no complex queries. So as we discussed earlier, it stores the value based on the key. So you will simply give it the key and it will return you the value. So here we are not doing any filtering, no scanning, no joins. So the database will only look into the keys that you have provided and it will not look on other keys. So basically each of the requests will touch only one partition and only one node. So we are not doing any range based queries or checking other keys. You simply provide the key and it will check that particular value. So it will hit a particular partition and node only. Now the second reason is it is perfect for consistent hashing. As we discussed earlier, in NoSQL we use a consistent hashing, and here in key value database it fits perfectly well. So based on the key you get the partition, and hence you get the node as well. So as we are doing the consistent hashing, so when you add the nodes or remove the nodes, you would require minimal data movement and there is no schema impact. Very similar to the example of suitcase, the boxes and the clothes that we discussed earlier. Okay, that's a very simple example through which you'll get the complete clarity of the whole picture. I know we have not discussed in detail about consistent hashing, so if you want me to discuss about consistent hashing, the complete approach, how things are stored, put that in comment section. I'll create a separate video for that. Alright, so this was about the horizontal scaling. Next, also discuss about the replication and fault tolerance in key value database. So most of the key value database replicate data. So for example, if we put the replication factor as 3, it means it is kind of maintaining 3 copies of the data. So for any key, say K, we have 3 replicas in node A, node B and node C. So just in case one node dies, read and write operations will still succeed. They can be rerouted to a different node because we have the replicas. Alright, next let's discuss about data modeling in key value database, or what are the rules that you should follow in key value database. Alright, so this is the rule 1, which is you should design the keys carefully. As you know, in key value database, everything is stored in terms of key and corresponding to that the value. So it is very important that you design the keys very carefully. Like we'll take the example. So this is a good key design. You have like user 101, session ABC123 and cart 101. So basically you are getting the category and corresponding to it the ID as well. So this is acting as a good key. The bad key design would be just user. Now because user can have many user IDs like user ID 101, 102, 201, whatever. So this is not a good key design because there is no uniqueness, whereas this is a good key design. You're getting the category and also the ID corresponding to it as well. So the combination of this is acting as a key. Okay, and then corresponding to this you will store the value. So it means for user with ID 101 you have this value stored, right? So it is a good key design in that way. So apart from this, you can also keep composite keys in key value database like this. You have the category, you have the ID, and you are also storing something else with it. Like here we are storing the timestamp. So it is a composite key. So you can clearly see in the key itself you can keep multiple things through which you can uniquely identify. So here you can keep data for particular order with particular ID and at a specific timestamp, because it can also happen like for a particular user you might have multiple records and you want to keep it with particular data like the timestamp, right? Which can also help something like in rate limiting, like you have specified like in 1 minute you cannot make like more than 100 requests, something like that, correct? So you can keep your key according to it so that you can easily calculate, right? Now next let's compare key vault database with the SQL database, because till now we have studied about SQL database and we know a lot of things about SQL database. So let's compare both of these so that you get more clarity about it. Okay, so first feature is the queries. In key value database you basically query only based on keys, okay, whereas SQL is rich in queries. You saw earlier in this video we wrote multiple queries. Even for joins we wrote different queries, right? So SQL is rich in queries, whereas when we talk about key value database you can query only based on keys. Next, talking about the schema. In SQL we know we have the fixed schema, correct? So SQL is famous for fixed schema and then relation between different tables using the keys, joins, asset properties, whereas in key value database there is no schema. Corresponding to a key you can keep any value. So in value you can keep anything. So there is no fixed schema. Okay, talking about the scaling for key value database, as we discussed, the scaling part is excellent also because it's a category of NoSQL database. By default it is good in horizontal scaling, correct? So this is happening automatic. This logic is also handled at the DB layer, right? Whereas when we talk about SQL we know like the horizontal scaling or the sharding is quite hard, that we already discussed earlier in this video. Talking about the transactions, of course SQL provides like strong asset properties. So the asset properties in transaction for SQL it is quite strong, whereas for key value database it is limited. And when we talk about the use case, Of course, SQL is used for providing the ACID properties support. It has strong consistency, so it is used for financial transactions, the banking apps, whereas the key value database, it is used for hot path. Okay, so the key value database is excellent when we talk about like the massive reads happening at the scale, because you will simply query based on the key. Okay, so this was about the key value database. If I have to define the key value database in summary, it would be the key value database store data as key value pairs. Okay, and they optimize for fast access by key. You will query only based on key here. Okay, they scale horizontally using the consistent hashing, and they have limited query capabilities because you can only query based on key. You cannot do range queries or other things. Okay, now another thing is like key value database often favor availability over strong consistency. We talked earlier about the cap theorem, right? We can only provide two of the three things in the distributed system where we know P is a required thing. So either we can do CP or AP. When we talk about key value database, they generally provide AP, that is they prefer availability over the strong consistency. Next thing is the common use cases of key value database is caching, session storage, rate limiting, and for other metadata. And two very famous examples of key value database is Redis and DynamoDB. So let me put it here, Redis and the DynamoDB. These are very famous key value databases. Okay, so this was about the key value database. Next, we are going to talk about the document database.
The very first question that comes to the mind is, what is a document database? So a document database is a type of NoSQL database which stores data as documents, usually in the JSON format. This is an example how data is stored in the document database. You can see this is in the JSON format. So here you can see we have information related to users. So we have user ID, username, email, and the addresses of the users as well. So all the information that is required related to user will be stored together in the JSON format. Now the important thing is each document is self-contained, schema flexible, and stored as one unit. Okay, so all the information which is required, which is related to that user, will be stored as one unit in the JSON format, and the schema is also flexible. Okay, so it's not like schema is fixed, it is flexible. Now let's see some of the properties of document database. They have flexible schema, as we mentioned it here as well, correct? They can have nested data, okay, because this is JSON format. Inside this you can keep like nested data. Okay, and these are good for horizontal scaling, like the basic property of NoSQL database. And we will use limited joins here because, as we discussed earlier, NoSQL databases are built in such way by design that we don't require joins. So NoSQL databases are not good for joins, right? So what are the use cases for document database? You can use it for user profiles. Like here you can see we have saved the user related information. All the information related to that user will be present in the document as a single unit, and it would have this flexible schema as well. Another use case can be product catalog, CMS systems, event metadata. So if in your system schema evolves frequently, then we can go for document database because we have flexible schema here. And as we discussed earlier, in NoSQL databases we try to keep all the related data together. So here also you can see we keep all the data as a single unit. So that's why as per the design it is built like this, that joins are not required. Now let's see some of the core characteristics of document database. Okay, so in document DB the data unit is document, and the format of document can be JSON or BSON. Talking about the schema is flexible in document database. When we talk about joins, document DB is weak in joins, or you can say it provides limited kind of support for joins because it's a category of NoSQL database. And then when we further talk about scaling, it is good in horizontal scaling. As we discussed earlier, by default NoSQL databases are good in horizontal scaling. That logic is handled at the DB layer, and that is automatic. And when we talk about the queries, so document database is rich in queries, not like key value database where you could only query based on the key. Here you can write the queries, but of course it is not at the level of SQL, because in SQL database you can write a very rich level of queries. right? So you cannot compare it with the SQL one, but yeah, as compared to key value database, document DB is much better in terms of queries. You can write a lot more queries here. All right, next let's discuss how data is stored internally in document database. So the step one is collection. So in document DB you have something called as collection. Like when we are talking about like users related information, like we stored user related data here, correct? So this will be one collection. Okay, so the next thing is we store a single unit as document, right? So each of the document has a unique ID. Okay, and then when we talk about the storage, it is stored on disk. It is indexed by ID, like this ID that we have for a document, correct? And then it is often compressed. Now I know that most of your understanding has been related to the SQL database, like we have tables, rows and columns. So let's try to visualize this in SQL format. So you can think of it something like this. When we talk about collection, it is something like a table that we have in SQL database, correct? So in SQL database, we store everything in the table format, correct? In similar way, in document database, we have collection. So like we have the users table in SQL, we will have the users collection in document database. Next, as we discussed, the data unit is document, correct? So you can visualize it as in SQL, we are talking about the row. Like in each of the row, we had the data, correct? So in similar way, in document database, we have the single unit as document. And in SQL, we have the columns, right? Like for example, this can be your user ID, name, address, right? In similar terms, we have fields in document database. But the important part is like in SQL database, structure or the schema was fixed. Whereas when we talk about document database, the schema is flexible. So the fields in document database will be flexible, right? So in document database, we have collection, document, fields. And then when we talk about storage, it is stored on disk, indexed by ID, and they are often compressed. All right. Next, let's discuss about the query compatibilities in document database as compared to key value database. So we saw earlier that in key value database, you can query only on the basis of key. So you cannot make any other queries. But when we talk about document database, it is much better in terms of query capabilities as compared to key value database. Like for example, we took the case here of the users, right? So this was an example of document database where we had the user ID, name, email, addresses, everything stored in the JSON format as a single unit document, right? So what we can do is like we can query inside this document. Like if we want to query for this address related to Delhi in this document, then we can write a query in document database something like this. You can write db dot users is our collection name, correct? And then we can do dot find. Inside that you can provide addresses dot city Delhi, because we have saved in the JSON document addresses, and inside addresses we had the city, correct? And this is the name of the city that we want to find. So I've pasted that example here so that you can relate it easily. Okay, so this was our users collection, and you can see this was the document in which all the data was stored, and we have done db dot users collection dot find addresses because we want to find inside this field, and then we have put dot city because we want to search for this Delhi city, right? And then we have provided the name for that. So the document database supports filters, sorting, range queries, and aggregations. So you can clearly see that as compared to key value database, the query capability is quite rich in document database. All right, next let's discuss about data modeling in document DB, which means how do you want to store the data so that it's efficient while reading? The golden rule for this is model data based on the access patterns, which means depending on what is the pattern that you access the data, you should model it accordingly. Let's try to understand this with the couple of ways of data modeling. So the first way of data modeling is embedding, which is the preferred way. Okay, so you can see this is the embedding way of data modeling in document database, in which you can clearly see all of the complete data. It's stored in the single document as a single unit. Okay, you can clearly see we have the user ID, and when we talk about the orders, we have the details of orders as well, like order ID 1 and the amount is 500. Order ID 2, amount is 300, right? So we have details related to order ID as well. So what are the good things? You can get all the details in one read. Okay, the details of orders are also present in the same document, so you won't require any join here, correct? Because all the data which is required for this particular user ID related to orders is present in this one single document. Okay, the second way of data modeling is referencing, and we use it when it is required. So this is not the preferred way. Preferred way is embedding, where we have all the complete information in the single document, but the second way is referencing, and we will see when it is required. Okay, but this is the format in which you store. You can clearly see we have the user ID here, same thing. But when we talk about the orders, we don't keep the complete details here in the single document. We have just kept the order IDs here, 1 and 2, but we have not kept the detail related to that order. Like for example, we maintained the amount as well in the first case of embedding, but we have not kept the amount or whatever detail was present for that order ID here. Why? Because this is used when your data grows too large. Say for example, in this document you had huge amount of data. Okay, so you can't keep everything in a single document, correct? It would be like everything has a limit, so you can't make everything in the single document. So the case where your data grows too large, okay, so instead of embedding we will use referencing there. So we will only keep the important information in it, like the order IDs, and then if required we can find out the details of the order IDs from a separate document. Of course, you clearly see these were the use cases of embedding which we might not get in referencing, correct? But again, we will use it when we have independent life cycle. Kind of a state you can imagine, like we would only require the order IDs, but we don't always require the details of those orders. Okay, it can be something like on UI you have a screen where for the user you can simply see the orders. Okay, like order ID this, order ID this, order ID this, and then when you click on a particular order you show details of that order, correct? So for this screen you can say this would be fine as well, right? So as per the requirement you can pick referencing, but of course embedding is the preferred one. So these are the basic two ways how you can model the data in document DB. Okay, so depending on the requirement, like what is the pattern of your access, you need to model your data. Okay, next let's discuss about joins in document database. Of course, we know that in NoSQL joins are weak, correct? Because overall NoSQL are designed in that way that you don't require that much joins. Now when we talk about specific to document database, some of the document database like MongoDB, it supports joins. Okay, so for example in MongoDB you can use lookup. Okay, but it happens at the query time. These are not optimized for scale, and cross shard joins are expensive, right? We already know all this information, and that's why we also know denormalization is preferred in NoSQL database and also in document database. Next, let's discuss about horizontal scaling or sharding in document database. So as we know, document database is type of NoSQL database, and we have already discussed some of the things in NoSQL database. Like NoSQL database are good in horizontal scaling, and that is kind of the automatic feature because it is handled at the DB level. So same for document database, it happens at the DB layer. Okay, so one of the example can be, say user ID is your shard key, and based on the user ID you'll do the consistent hashing, you'll get the partition, and through that you'll get the node. So all of the data for a user stays together, the same things that we discussed earlier. Okay, now for shard key we discussed earlier as well. I'll just repeat, like good shard key is where you have the high cardinality, even distribution, and it is used in the queries, whereas bad shard key will be something with low cardinality and which create hot pods. Next, if we talk about like cap theorem in the document database, as we already know, like when we talk about distributed systems, either we can follow consistency with partition or we can follow availability with partition, correct? When we talk about document database, most of the document database follow consistency with partition tolerance. Like for example in MongoDB, CP is by default. So consistency is given more preference than availability in document database. So as I mentioned MongoDB here, so MongoDB is the most famous example of document based databases. Okay, MongoDB is quite popular and you might have already used it as well. Okay, so it is a type of document database. Okay, so if we talk about document database in summary, so document database stores semi-structured data as JSON like documents. So the data unit is document and the format is JSON. Now document database provide flexible schema, rich querying and horizontal scalability. Okay, now instead of joins they encourage denormalization and data modeling around access patterns, right? So we will mostly use embedding related data modeling so that all of the data is present in the single document only, so you don't require any joins. Okay, so document database is equivalent to JSON native database optimized for reads. All right, so this was about the document database. Okay, next, let's discuss about wide column database. So the question that comes into mind is, what is a wide column database? So basically in wide column database, we have concepts like row key, column families, columns and values. So corresponding to a row key, you will have like column families and columns, and corresponding to that you will store the values. It looks like a table, but it's not a relational table. Okay, so think of it like each row can have millions of columns, so that's why it's called wide column. So every row can have millions of columns, but the important part here is the schema is not fixed. The columns are created on the fly. So the rows do not need to have the same columns. Different rows can have different columns. Don't worry about it. We'll discuss more about wide column database and you'll get the complete clarity. Okay. So for now, let's see why wide column databases exist. So basically in wide column databases, the data is stored like the rows with dynamic columns, correct? And they were created for massive write throughput. So wide column database is optimized for write heavy workloads. Okay. Apart from that, they are also created for time series data. We'll discuss about it more. Then for event logs and for analytics at scale. Another thing about wide column database is that they are not good for complex queries. So complex queries are hard in wide column database. All right, now because we said in wide column database, we said like we have the row keys and we have the columns. So you might confuse it with SQL. So let's try to understand like how wide column database is different from SQL. Okay. All right. So first what we need to do is kill the SQL mental model when we talk about wide column database. So in SQL table, we used to have like fixed columns, schema was fixed and joins are supported, correct? But when we talk about wide column database, we have dynamic columns. Okay. And it is schemaless. So schema is not fixed and there are no joins. So if you think table, you'll get confused, but you need to remember in wide column, we have dynamic columns and without any schema. But again, you'll say, we talked about row key, column family, columns. So what are they? So for that, let's try to understand the core concepts in wide column database. So the first concept is row key, or we can also say it as the partition key, which means everything for the same row key is stored together. So for example, user ID 101, this is acting as a row key and corresponding to it, we'll keep all the data for it together. So this was the first concept. The second is the column family. Okay, basically it's a logical group of columns. That is why it's called column family. So for example, user profile, user orders. Each column family is stored separately on the disk. So a logical group of columns is column family. Then the third concept is columns. And as we said in wide column database, columns will be dynamic. So the important part of columns are that they can be added anytime. So these are the example like order underscore 2025 underscore 01. So basically we are using the timestamp, you can say, and corresponding to that we have stored the value, say 500, and for next we have stored 300. And the fourth thing is cell. So each of the cell will contain the value corresponding to the row key, the column and the timestamp. Okay, based on these we will have the value stored in the cell. Now you can clearly see we have mentioned the timestamp here, and that's why we mentioned that wide column database are created for time series data as well. Okay, so here you can see in the cell we have like row key, column, timestamp, and based on that we are storing the value. Now let's try to understand this with an example. Okay, so here you can see the row key is user ID and we are talking about user with ID 101. Okay, so the column families are order. Okay, so this is the information related to user ID 101. Order 1 value is 500, order 2 value is 300, order 3 value is 900. Now when we talk about another user with user ID 102, so the row key would be user ID 102. Column family again orders, but here you can see we have put order 7 200. So clearly you can see we have different number of columns per row, and that is totally fine in wide column database. Now earlier we mentioned that wide column database have high write throughput. So let's try to understand why writes are extremely fast in wide column database. Because in wide column database there are no updates in place, there are no joins, no constraints, no transaction. Everything is like write, append and done. So basically you are appending the things, and that's why it's perfect for logs, metrics and events. Next, let's discuss about the query model in wide column database. So the query model in wide column database is quite restricted. Why? Because in order to make a query, you must know the row key and the column family. You cannot do arbitrary filters or joins or full table scans. Okay, so that's why overall in wide column database query model is quite restricted. You must know the row key and the column family, and overall the wide column database is not for complex queries. Okay, because we have discussed about the query model in the wide column database, now let's also talk about the data modeling in wide column database. So the rule here is you have to design the tables for queries and not entities. Okay, based on what kind of queries you get, you have to design the tables according to it. Now this is the bad modeling example because we are following the SQL mindset, right? You would have like users table, orders table, and then you will join it later because we used to do it in SQL. But this is bad modeling when we talk about wide column database. And this is the example of good modeling when we talk in terms of wide column mindset. Like we have made orders by users, orders by date. Yes, there will be data duplication and that is totally fine in this NoSQL based wide column database. Okay, so because we are querying in this fashion, so we have created the tables in that way only, so that overall queries are quite efficient and we can store everything together. Next, if we discuss about the horizontal scaling in wide column database, it is very similar to what we have discussed till now in NoSQL database. So data is partitioned by row key. We discussed about the row key, right? And then based on consistent hashing on the row key, we get the partition and then we get the node, and there is automatic rebalancing. So each row is stored together and replicated. Now apart from this, if we talk about the cap theorem, right? As we know, we can either follow the consistency with partition tolerance or we can follow availability with partition tolerance. So in case of wide column database, we give more preference to availability with partition tolerance. Or you can say it's a tunable consistency. More preference is given to availability. Now few of the very famous examples of wide column database are Cassandra and HBase. Next, let's see when to use wide column database and when not to use. So you can use wide column database for time series data, IoT metrics, click streams, event logging and write heavy systems. And when not to use, for complex queries, as we saw that the queries are quite restricted in wide column database, as you need to know the row key and the column families. Similarly, not to use it for joins, financial transactions and for small data sets. So if I give the brief summary of wide column database, they store data by row key and the column families, and they allow rows to have millions of dynamic columns. They are optimized for massive write throughput and horizontal scalability, but restrict query patterns and avoid joins. Okay, so these are the few of the things that we learned about wide column database. Okay, so we mentioned here that wide column database are used for time series data. So one question that comes into mind is why wide column database is used for time series storage. Okay, so first let's try to understand what is time series data. So time series data means you have the same entity but values keeps on changing over time. For example, CPU usage every second, user activity events, stock prices, sensor readings. Some of the key properties of time series data is these are append only. These are ordered by time and these are mostly read by time range. Now let's see why other database would struggle at time series when we talk about huge scale. Okay, so example is we need to store CPU usage every second. So if we talk about SQL database, we have to keep like time, CPU, memory. So because this is like time series based data, we will have a lot of events. Say we have to maintain the records for every second. You can imagine that after a year, there will be huge number of rows per server and overall the writes will become quite slow. Now let's see how the wide column database will handle it differently. So the wide column database will group time based data together and in this we will just perform like append. Okay, so when we talked about SQL, it would have been like one row per event, but when we talk about wide column database, it would have one row per entity and many columns over the time. I know it might be still confusing, so let's take an example. Okay, so say we have to store CPU usage of server ID 101 every minute. Okay, so for wide column database, we can say like Cassandra, we will have the table as CPU metrics. Okay, and the primary key will be server ID and the timestamp. So server ID is the partition key and timestamp is the clustering key. So overall the data would be stored something like this because we talked about like row key, column family, columns and the values. So I'll show you in that way only. The row key will be the server ID because we were talking about SRV 101. So that will act as our row key. Okay, and when we talk about the column family, it would be metrics. So in that we will use the timestamp. You can clearly see this is the date and this is the time, and corresponding to it we have kept the value, and again the next minute we will store another value, and you can see at 10:02 another value, 10:03 another value. So basically we have one row per server and columns are ordered by time. So corresponding to this row key, which is your server ID, we will keep all the data based on the time, and this is already ordered by time. So that's why it's following the needs which are required for time series data. Now this is how the data will be stored in wide column database. So why wide column database is perfect for time series storage? Because of the following reasons. Number one, the writes are append only. Okay, so we are not performing any update operation here. We are just appending the data in the same row key. Okay, so we are just appending. Okay, you can clearly see there is no update operation here. So whenever there is new timestamp, there is a new column. So clearly you can see these all are the columns. So after every minute we are creating a new column. So next would be this time and then 10:04, and corresponding to that we will have the value. So that would be the new column. Okay, and the most important thing, there are no updates. It is just append only and there are no locks. Now the second reason is data is naturally sorted by time. So our clustering key is the timestamp, correct? Like we saw here, the partition key is server ID, the timestamp is the clustering key, and you can clearly see the data is already sorted, right? So that's why the range queries are fast. Next, the reason number 3 is reads are localized. So we will have query something like this: get CPU usage of server 101. This is our row key from this time to this time. So because we are mentioning the row key here and data corresponding to one row key will be present in one server only, so that's why only one partition is touched, and that's why we are saying reads are localized. So you do not need to pick data from multiple partitions, you'll just pick the data from one partition. Now because we said like only one partition is touched, we also come to point number 4, which is no cross server queries are needed. So each server's data lives together. So you are just picking data from one place. So no cross server queries. Okay. So due to all of these reasons, wide column database is good for time series storage. Next, let's take one more example so that you get more clarity. So in this example, we'll track the user activity events. So our wide column design would be something like this. Our table is user activity. Primary key is the combination of user ID and event time. Now let's see how data is stored. So we will have row key as user ID. So for example, user ID is 101 and corresponding to this, we will have the columns. Okay. At 10:00, we have the login. At 10:05, we have the event of view product. At 10:07, we have an event of add to cart, and at 10:10 we have the event of logout. So based on the new time, we'll create the new columns. Now further, if we talk about the query, it would look something like show user 101, which would be the row key, correct? And then activity today. It will simply hit the single partition because data is stored based on the row key, correct? And all the data corresponding to row key is present in one partition. So basically in wide column database, the partition and clustering makes the time series magic. So the partition key would be the group's entity, like it can be your user ID. The cluster key would basically order by time. Okay. And internally it uses LSM tree, due to which we have fast appends. And another thing that it uses is SS tables, due to which we have sequential disk writes. And these are the reasons that the wide column database become the natural choice for time series data. So we saw the example of user activity events using the wide column database. If we do the same using SQL or any other database like document database, let's see what all problems do we face. Okay, so if we store it in SQL, okay, so we will make a query like select star from activity, which will be the table name, where user ID is equal to 101, correct? Because we have to figure out data based on the user ID, and then we will provide time between. Basically we will provide the range. Now the problems at scale are there will be huge index scans, there will be random disk IO, locking overhead, and if the data is huge, they can be part of different machines, then basically it can create more problems. Okay, now similarly if we compare it with the document database, in document database we will store it something like this. Okay, so we will have the document ID, and inside the document we'll store it in the JSON format, right? So we will have the user ID, and then we will have the activities. Inside the activities we will maintain like time is this, event is this, and then further time is this, event is this. So inside the activities you will have all the data. Okay, now what are the problems? First problem is the document grows forever because you have to keep on adding the data based on time, right? First you have 10:00, then 10:05, 10:10, and it goes on, correct? So your document will also grow forever, and because of that eventually it will hit the size limit. We saw in document database there are two ways to model the data. One would be the embedding way, where you would have everything inside the document itself, but because due to the size constraints, if the data becomes huge, then you cannot follow that way, correct? Then you just keep the IDs out there, but that won't be helpful here because we want to keep the data corresponding to time as well. And another important point here is when you keep on adding the time, it is kind of like updating or rewriting the whole document, because inside the document you have to add this new value, right? So that's why it's not that great. But when we talked about like wide column database, you can have thousands or millions of columns, and those are dynamic, and it is kind of append only operation. Okay, before moving to the next one, which is the graph database, I want to cover one thing. When I was studying all this, so I had a doubt, so I would like to share that with you, and after that let's move to the graph database. Okay, so the question was, what is the difference between wide column database and document database? Okay, because both of these like appeared bit similar to me in the beginning, so I had this doubt. So maybe you also have this kind of doubt, so let me clear this for you. So first of all, like how they store data or overall their model is completely different. In document database, you store the document, and generally the format would be JSON, and you will assign ID to that document. So there will be complete document. Whereas when we talk about wide column database, it is special for like the number of columns can be huge. Okay, you can have like thousands or millions of columns, and those will be corresponding to a row key. Okay, and different row keys can have different amount of columns, so the columns are completely dynamic. So both of these are completely different, but let's try to understand more about it. So the first thing, like we discussed, in document database we will store it like in the document. So there will be one document, it will contain all that information. Okay, so say for one user ID we will have one document. Okay, when we talk about wide column database, for one user ID we will have one row key, and inside that we can have thousands or millions of columns. Okay, so how data is present in both is completely different. All right, so the basic unit for document DB is document, whereas for wide column DB it's like the row key. Inside the row key you will have like a lot of columns. Okay, the format, as we said, it stores in document. The format of document will be mostly JSON or BSON, whereas for wide column database, corresponding to the row key, we will have the columns. Okay, when we talk about the schema of document database is flexible. When we talk about wide column database, it is semi flexible, because you saw like for the user ID we have like columns related to the time, right? So the total number of columns can totally vary based on the row key, but still it's kind of semi flexible, we can say. Okay, when we talk about the data shape, in document DB it is nested, as we saw, like it's a JSON inside, so you can have nested things inside the JSON. Okay, when we talk about flat column DB, it is flat but wide, of course, like because we are talking about columns, so there is no nesting, but there can be huge number of columns, so wide in that way. Okay, next, when we talk about columns per row, in this, of course, the wide column database can potentially have like millions of columns. Okay, so these are the kind of differences between document DB versus the wide column DB. All right, now let's try to understand this more with an example. Okay, so we will take an example and see how the data is being stored in like document database versus the wide column database. So in document database we are picking like MongoDB, which is a very famous document type database, and in wide column database we are picking Cassandra, which is also very famous. So corresponding to user ID 101, we are basically storing the orders. Okay, so because in document DB we have the document, in single document will store everything, so you can clearly see this is the JSON. Inside this we have stored the user ID, we have stored the username, and then we have also stored the information of the orders of that particular user with user ID 101. So the first order related information is order ID 1, amount is 500, then order ID 2, amount is 300. What are the characteristics? It's easy to read because you can see everything in one document. It's a JSON document, so quite easy, and in one read you can fetch all of the information, right? So this is like embedded style where all of the information is present in the single document, correct? So in one read you will be able to get all the data. Okay, the same information, how we will store it in wide column database, let's see. So we will have the row key, correct? So the row key is the user ID, which is 101, and then we will have the column family orders. Okay, so clearly you can see the same thing, we are storing it like order 1 and corresponding to that value is 500, and then order 2 and then the value is 300. So these are the different columns that we generate. Here you can see this data is stored in the nested level. Okay, and this was a starting of JSON, and you can see this is the nested level where we have provided all the information of the orders. When we talk here, this information comes in the column. So if you have another order, a new column is created here. Okay, so what are the characteristics of wide column database? Very fast writes, as we discussed, because this is append only. It can handle huge number of columns, so all the data which keeps on coming, that we will keep on creating new columns corresponding to that, and it is ideal for append only data. That's why it is quite fast in terms of writes. So this was about how data is stored in document database versus in the wide column database. So next, let's also see the difference in the query capabilities between both of these databases. So the first feature is filter by field, right? So you have the field Can you filter by the field? In document database, of course, you can filter by fields. In the document, you have the fields, right? So in the query, you can mention which field you want to filter by, and based on that, you can filter it by the field. When we talk about wide column database, we cannot filter by field. When we talk about the range queries, in document database, we can do that. And in wide column database also, we can do that by on clustering keys. We saw that example where we use the timestamp as the clustering key, and based on that we can perform the range queries, right? Next, when we talk about aggregations, aggregations are good in document database, but it is limited in wide column database. Okay, talking about joins, document database are weak in joins, whereas joins are not at all supported in wide column database. And next, when we talk about the query flexibility, document DBs have high query flexibility in terms of when we talk about NoSQL database. Of course, SQL are much better when we talk about query flexibility, but when we simply talk about NoSQL databases, document database have high query flexibility, but wide column database have very low query flexibility. So clearly you can see the writes are very fast in wide column database because it is doing append only, but when we talk about the query capabilities, document database is better in that. Next, if we talk about what do they use internally, okay, so the document database internally uses B tree, whereas wide column database uses LSM tree. When we talk about update pattern in document database, that is in place or rewrite pattern. When we talk about wide column database, it is append only pattern, and due to append only pattern, the writes are quite fast in wide column database. And when we talk about disk IO in document database, it is random plus sequential, whereas in wide column database it is mostly sequential. You don't need to remember all of this. I just gave you the brief insights, like what is the difference between those. You should be aware of that very clearly. By now we know wide column database is the write operations, the update pattern is append only, so it is very quick in writes, right? Whereas the query capability in document database is better. Okay, the style in which both of these store data is completely different. That's why these are the different categories of NoSQL databases. Another difference is when we talk about the cap theorem. Now, because we know either we can have CP or AP, by default the document database follows CP, so it gives more preference to consistency over availability, whereas when we talk about the wide column database, by default it gives preference to availability over consistency. Okay, so it gives you AP, that is availability with partition tolerance by default. And the asset properties, we know those are more specific to SQL because SQL tries to provide you the asset properties overall. But when we talk about basic atomicity operation, so document database will provide you atomicity at the document level, because in a single document you will have all the data, right? So atomicity will be at the document level, whereas when we talk about wide column database, it provides you atomicity at a row key level, because we have the row key and corresponding to it we have the family column and the columns, right? So it will provide you the atomicity at the row key level, which is limited though, but still it is at the row key level. And as we discussed earlier, document database provides you slight support for joins, although it is weak, but still you can have multi-document related transactions. But when we talk about wide column database, there is no support for join. So this was in complete detail. Now, the very basic question that comes to mind, if we have to talk in summary, when to choose document database and when to choose wide column database. So here is the answer. Choose document database if your data is object-like, because it will store the data in a document with JSON format, right? And choose if you need flexible queries, because we saw the document database provides you much better read query support. Okay, and choose it if your reads are complex, whereas choose the wide column database if you have massive writes, because we have already seen the wide column database is really good when we talk about the write operations, because it is append only and because of the data structures and everything that it uses. Okay, and also choose it if your data grows continuously. In document database, it can create an issue if your data keeps on growing, because your document has kind of size limit. After that, you cannot follow the embedded pattern, correct? And if you don't follow it, you don't have all the data in one place, right? If your data grows continuously, then it's better to use the wide column database, because it has the support for like 1,000 to millions of columns, and columns are dynamic. As your data grows, you can keep on growing your columns, right? So that is supported in wide column database. And again, use it if your query patterns are fixed, because the read query support is weak in wide column database. Okay, so based on your pattern or the requirements, you can choose between document DB or the wide column DB, right? So I hope that clears the doubt. Until now, we have covered in NoSQL database the key value database, document database, and wide column database. Next, let's discuss about graph database in NoSQL. Okay, the first question that comes to mind when we talk about graph database is, what is graph database? So a graph database stores data as nodes, edges, and properties. You might have read about graph data structures when you read about data structures and algorithms, right? So we have nodes and edges in graphs. Similarly, in graph database, we have nodes, edges, and properties. So here nodes represents the entities. So if we want to relate it like the SQL database where we have tables, so node will be relating to the entities. Okay, the edges relate to the relationships, like this is the node and this is the edge. Okay, so these nodes act as entities and the edge is acting as the relationship between the entities, and then the properties are the attributes. So one example of graph database is, like if we talk about social network, like we talk about Facebook, Instagram, so in that you have like two people friends of each other, right? So Alice and Bob are friends. So this relationship is stored directly using the graph database. Now, because in social networking apps, you have mutual friends and then friends of friends, right? Like in LinkedIn also. So instead of computing all that information through joins, you can get that relationship directly using the graph database. So graph database is good for storing things like where you have relationships which are deep. Okay, so example is social networking apps. Now you may think like, because there is relationship out here, why not use the SQL or relational database here? So let's discuss about that, why graph database exists. So basically the relational database struggle in the following cases: when the relationships are deep. For example, we talked about the social networking apps, right? So you can have friends of friends of friends. In that case, you have deep relationships and the queries would require a lot of join operations, because you have to take data from multiple places. And another thing is, when the relationship patterns can change, then the relational DBs can struggle in that. So in these areas, instead of relational DB, you would like to use the graph database. Okay, because graph database is dealing based on the relationship only. Now, because we mentioned in graph database we have nodes, edges, properties, so let's try to understand each of these in detail in the core components of graph database. So the first one is nodes, and nodes represents the things, or you can also say it is similar to entities. Example can be user, product, city. Now the good part of graph database is both the nodes and the edges can have the values or the properties. Okay, so let's take an example of node properties first. So you can see this is the node user, and inside this we have the properties like ID is 101 and name is Rahul. So for node user, we have defined the properties like the ID of this user is this and the name of the user is Rahul. So after nodes, the second one is edges, which define the relationships. Okay, so edges represents the connections, like this is one node, this is another node, this is the edge, and this defines the relationship or the connection. So example of edge is like this is one node, this is another node, and the edge is this relationship which is friends. Similarly, you have a node user, another node is product, and the relationship is bought, that user bought product. So edges are directional, as you might have also checked that in the graph database. In the similar way, we in the graph DB we have the edges which are directional. Okay, and edges have types and can have properties that we have already discussed, that both nodes and edges in the graph database can have the properties. So this was an example of node having properties, and now let's see an example where edges has the properties. Okay, so this was first node user, this was another node user, so the relationship or the edge was friends. So if we see here, this friends is representing the edge. Okay, but it can also have the property, so you can clearly see it has this property since 2020. So this is defining this user and this user are friends since 2020. Okay, all right, so apart from nodes and edges, the third thing is properties, and we have already discussed that both node and the edges can have the properties. Okay, so they can store key value properties like this. You can see ID 101, this is the key, this is the value, name is the key, Rahul is the value, since is the key, 2020 is the value. Okay, so both nodes and edges can store key value properties. Alright, next let's see how graph database stores data. Although graph database also talks about the relationships, but it is different from SQL. Okay, in SQL you define the relationship between tables using the foreign key, right? Whereas when we talk about the graph database, relationship is the direct pointer, because you can clearly see the nodes are connected via edges which represent the relationships, and relationships can also have the property. So it's kind of a direct pointer in the graph database. So for example, in graph database, if you have to go from node to neighbor to next neighbor to another neighbor, this traversal is O1 per hop. Okay, so you can directly move to the next one because it's a direct pointer. Let's try to understand this with an example. So we took the example of social media, social network, right? So for example, you have to go like friends of friends in social media. Now this example of friends in social media can be quite painful in SQL. So you have to apply multiple joins user 1, then join users 2, join users 3. Right? So a lot of joins in the query. Whereas when we talk about the graph database, it is built for this kind of thing. We can do something like match. This is the first node which has the property ID 101, and then we are telling the edge. Okay, this is like friends, which is defining the relationship, and then basically we are providing like we have to go friends of friends. Like here you have to do the join operation thrice. Here you are using the direct pointers for that. Okay, so this complete query basically will return you this friend. So overall every hop is like O1, right? So the performance in this will depend on the depth, how many levels are you going, and not the data size. So one of the famous example of graph database is Neo4j. Okay, so this is a famous graph database. So apart from this, the graph database are really good in traversals. Okay, so you might have already seen the graph related traversals when you might have worked on like data structures and algorithms. But in similar way, graph database excel at like shortest path in recommendations, fraud detections, and network analysis. So an example can be find shortest path between A and B. So graph database can use BFS or DFS for this, which is very fast. Next, let's talk about the data modeling in the graph database. So the rule for data modeling in graph database is we have to model the relationships and not the tables. Let's try to understand this with an example. So if we take example of e-commerce, the nodes can be user, product, category, and the edges can be user node is connected to product node via edge or relationship viewed, that user viewed product. User can also be connected to node product with edge or relationship bought, that is the user purchased the product. Okay, and product is connected to category with edge in, so product is in this category. Okay, so based on the relationship you model the data in graph database. So the relationships are really important part of graph database. Next, let's discuss about the scaling in graph database. Now although in most of the NoSQL database the scaling was not that difficult part, it was kind of automatic and quite easy thing, but when we talk about the graph database in NoSQL, the scaling is bit hard. This is because the graph database are excellent on single node, but they are hard to shard. Okay, why is that? Because the relationships across partitions is difficult to handle, because the traversals would happen on the network calls and that would be quite slow. Talking about some of the strategies to handle it, it can be partition by community, so that you do not have to check for the relationships across partition. you are then able to handle the things in the same partition only. Another strategy is hybrid systems and read replicas. Now for all of the databases, we also checked about the CAP theorem, right? So as we know in CAP theorem, we can either provide CP or we can provide AP, right? So when we talk specific to graph database, by default, graph database provides strong consistency. So it gives preference to consistency over availability. So if we talk about graph database in summary, graph database store data as nodes and the relationships, allowing fast traversal of complex relationships without expensive joins. Okay, so it is used when we have deep or complex relationships, and because it connects the nodes using the edges which represent the relationships, so it is based on the relationships and you can go from one node to another as a direct pointer. So graph databases are ideal for problems where relationships are deep and complex. Okay, and the pattern matching matters more than the raw data volume. Okay, so overall for graph database, we can simply say it's like relationships stored as pointers. Alright, so now that we have discussed about the SQL and NoSQL databases, let's see with an example how data is stored in SQL versus all different NoSQL databases. Okay, so we will take an example and we will see how the same data is stored across different databases that we have discussed till now. So let's say this is the data. Okay, so we have user and orders. So for user ID 101, we have these two orders, order 1 with amount 500 and order 2 with amount 300. So first, let's see how this data will be stored in SQL database. So this is how the data will be stored. We will have a users table, correct? Because in SQL we have tables and then we connect the tables using the foreign key, and in the queries we use the joins, right? So we will have the users table for user. In that we will have the two columns like ID and name. We will store the information 101 and the name as Rahul. Okay, and another table would be the orders table. Inside that we will have ID, user ID and amount. Okay, ID here would be the primary key of this table orders. It can represent the order ID, whereas user ID can act as the foreign key, because using this column we can connect users table with orders table. Okay, and then we have amount column. So we will store data like this. Order ID is 1 and user ID corresponding to it is 101 and amount is 500. Another order is with ID 2. The user ID is again 101. The amount is 300. Okay. So this is how the data will be stored in SQL. So next, if we talk about the query, it would look something like this. Like we will use select star from users u. This is the table users, and then we will use the join here because we need data from both of these tables, right? So this was the left table and this is the right table orders, and then we provide the matching condition using on keyword, and we do it like u.id is equal to o.user id, right? So based on this, we have provided the match conditions of join, and then we have also provided where u.id equal to 101. Okay, so it will do the filtering after the join because we want data only of user ID 101. Right now, let's see when SQL is good and when is it bad. Alright, so SQL is good when we need the strong ACID transactions because SQL provides strong ACID support, right? We discuss about ACID properties, atomicity, consistency, isolation, durability, right? And then the next thing is SQL is really good for joins. So the joins are powerful. You can clearly see we have used the join operation here. Next, SQL provides you strong consistency. So when data consistency is required, you want guarantee on that, you can use SQL. Okay. So these were the good things for SQL. Now let's talk about the cons of SQL. SQL is hard to scale horizontally. That is, the sharding part is quite difficult and that is managed by the app level logic. Another thing is the joins become slow at scale. Okay, so if you have many joins, it becomes difficult and it will be quite slow. Third thing is schema changes are painful in SQL. Okay, so this was in SQL database, like how data will be stored, how we will query, good things and bad things. But apart from SQL also, we discussed about NoSQL, and inside NoSQL we checked about the 4 categories, right? So let's discuss how this data will be stored in all of those 4 categories of NoSQL as well. Okay, let's start with the first one, which is the key value database, right? So the famous examples of key value database are Redis, DynamoDB, correct? So let's see how the same data, this one, will be stored in this key value database. All right, this is how the data can be stored. You can see the key we have maintained as user 101. So basically it is telling about user and this is the ID, and corresponding to that we have stored the information. Like you can clearly see we have stored inside the value name as Rahul, and the orders information also we have stored. We had like 500 and 300, so we have also put that inside the value. Okay, so this is the key. This complete is the value corresponding to this key. Next, this is how you can read from this data. Okay, so this was your data, and if you want to read, you will simply do get and then pass the key, because the key was here user column 101. So we have passed the key here, and corresponding to it, it will return you this value. So like in SQL, we saw what are the good and bad things. Let's see same for the key value database. First, talking about the good things, the key value database is extremely fast. Okay, so basically your query is just using the key and you pass the key, you get the value. It is very fast. Then because it's a NoSQL database, there is easy horizontal scaling. So horizontal scaling was a con in SQL, but it is totally fine in this key value database. And key value database is perfect for cache and the sessions, because there you can keep the data in key value format and it will be very quick. Okay, so these are the good things of key value database. Now let's see the bad things. So first bad thing is you cannot query inside the value. So you can simply query for the key, like you give the key and you get the value, but inside the value, say for example we have this orders, you cannot query for this. So you cannot query inside the value. Okay, next thing is you cannot do any joins in the key value database. It's not supported. And another point is it is poor for complex data. Here you can see everything is present in this value part and you cannot query. So if this becomes complicated, overall this is not sustainable. But this is how you store the data in key value database, and this is how you get the data or read the data. Okay, so this was the first type of NoSQL database, key value database. Next, let's discuss about the document database for the same example. So one of the most famous document based database is MongoDB. So this is how the data will be stored in the document database, because in document database you store as a document, correct? And the format of the document is generally JSON or BSON. Here we have used the JSON. You can clearly see this is the JSON and this is the complete document. Inside that you will have the user ID 101, name as Rahul, and then you have this orders. Inside this you have all the information: order ID 1 amount 500, order ID 2 amount 300. So this is an example of embedded modeling style of document database where everything is present in the single document. Okay, so this was how we store the data, and this is how you read the data. You will do db.users and then inside that you do .find and you pass the user ID here. So basically you can find inside the document as well. Okay, so users is kind of your, you can say, the overall document. Okay, or in SQL terms you can say it is kind of your entity. Inside that you can basically find. So you can find based on user ID. You can also find for the orders here. So that's a good thing in document database. Okay, so talking about the good and the bad things related to document database, the good thing is it has the natural JSON structure, as you can clearly see here, in which we store the document is generally JSON, and it has the flexible schema. So as all the information is stored in the single document in a single place, you'll get all the data in one read. So that way it is fast, and overall it provides you the support of joins, although that is kind of weak support, but as compared to key value database, it provides you at least support for the joins. Okay, these are the good things. Talking about the bad things, so one thing that you can clearly see, because we are keeping all the data in a document, if your data keeps on increasing, your document can become really large, and of course it has a limit. Then you cannot keep all the data in one document. then you have to do other modeling style that we discussed earlier. Okay. And then another issue with it is like, although it supports the joins, but the joins are quite limited and weak in document database. So yeah, of course, as compared to key value database, it's better because at least it provides the support for joins. In key value database, you don't have any support for joins. But when we talk in comparison to SQL, we have like limited or weak joins in document database. Similarly, the transactions are weaker as compared to SQL. Next, let's discuss about the same example in wide column database, which is the third type of NoSQL database. We discussed about key value database in NoSQL. We also discussed about the document database in NoSQL. Now, the third category of NoSQL, wide column database. And a very famous example of wide column database is Cassandra. Now, because in wide column database, we have the row key, we have the column families, columns and values. So here the data will be stored using the row key, which is user ID 101. So the row key here is user ID and we are talking about ID 101, correct? And the column family would be orders. And in that you will have these columns: order 1 having the value 500, order 2 having value 300. If you have more data coming, so more columns will be generated. So in wide column database, you have dynamic columns and you can have thousands or millions of columns, right? And this is how you can read the data in the wide column database. Select star from orders where user ID equal to 101. So basically you should know the row key and the partition. Now let's see pros and cons of wide column database. It is good when you have massive write throughput. Okay, so it is good in like write operations because we only do append only. It is also perfect for time series. In ascending order, we already have the data related to timestamp, so it is good for storing time series data. And it is also good when you have huge amount of data, like the data keeps on increasing, because here the columns are dynamic. You can create more columns and you can have millions of columns, and that too dynamic. Different row keys have different amount of columns as well, so it's totally fine. So these were the good things of wide column database. When we talk about the bad ones, you have very limited queries. You can clearly see in the queries you need to know the partition and you also need to know the row key, and based on that only you can query. Okay, you don't have any joins in the wide column database. There is no support and the data modeling can sometimes become bit hard. Okay, so this was the wide column database in NoSQL. Now let's see how we will deal with the same data in the fourth category of NoSQL, which is graph database. Alright, one of the famous graph database is Neo4j. Okay, now let's see how we will store this data. Okay, so this is how the data is stored. User is the node, orders is the node. Okay, as both node and edges can have the properties. So here user has this property 101, and here corresponding to order we have this 1 and the amount 500. Okay, similarly in second one, user is 101 only, order is 2 and 300. These are the properties. So these are the nodes and the edge or the relationship is placed. So user placed order. Okay, so this data is stored in this way in graph database. Now how can you read this data? So you can read in this way. Match, you provide the node and then provide the ID, and this is the relationship. Okay, and corresponding to it we get this output. So basically we are trying to find the match for user ID 101, and this is the edge or the relationship, and corresponding to it, it will return you both of the orders because user 1 placed 2 orders. So both of these things match for these 2 orders. Now let's see the pros and cons of graph database. So graph database is good in relationship queries because graph database is based on relationships. Okay, so the relationship queries are good. So if the relationships are deep or complex, then you can use the graph database, because if you use the SQL database, there will be a lot of join operations there. And hence the graph database is really good when we talk about social network apps, okay, where you have to find the connections of the connections, so friends of friends kind of thing. So these are the good thing. When we talk about the bad, although graph database is type of a NoSQL database, but it struggles in terms of horizontal scaling, similar to what we have in SQL. Okay, apart from that, graph database is good for complex or deep relationships, but it is not great if you have to do simple CRUD operations. Okay, and it is slower for bulk writes as well. Now that we have discussed about SQL and all the four categories of NoSQL database, I have a brilliant question, and I think you also might have the same question in your mind, which is what is the difference between SQL versus key value database versus document database versus wide column database versus graph database. So these are four categories of NoSQL database, and this is SQL database. So what is the difference? So let's try to understand this. Okay, first of all, if we talk like how all of these database store data, so talking about the structure, in SQL, we follow the tables. Like you have the Excel, right? You have the rows and columns. In similar way, SQL, we have the tables. When we talk about key value database, we store it in the structure of key and value. So you have the key and corresponding to that, you store the value, right? Then we have the document database. It stores a unit as document and the format is generally JSON. Okay. When we talk about wide column database, we have the rows. Generally, we keep the row key and corresponding to that, you have dynamic many columns. It can go even in millions of columns. Okay. Next, we have the graph database. In this, you have the nodes, edges, and the properties. So this is how all of these store the data, and you can clearly see there is difference how they store the data. Next, if we talk about the schema, as SQL is relational database, it is known for the strict schema. Okay, when we talk about key value database, there is no schema. When we talk about document database, so it has flexible kind of schema. Talking about wide column database, it has semi flexible schema because you have the column families and columns. Okay, so it's kind of semi flexible because different row keys can have different amount of columns, but of course you have the columns, like you define the family, right? Whereas when we talk about document database, you just have the data in the document. So in document, you can keep any format or any schema. So in that way, document database is more flexible. Okay. Talking about the graph database, we have the nodes and edges. So it is also quite flexible. Next, when we talk about the joins, SQL is known for the joins, right? Because relational database is like you have multiple tables and those tables are connected or have relations using the keys, like the foreign key, right? And because you have different tables, when you read the data, so you would require the joins. So SQL is strong in joins because it's kind of the core feature of this database. When we talk about key value database, there is no support of joins here. Okay, because it's a NoSQL database. It's not known for the joins. Talking about the document database, it provides a support for the joins, but overall it is quite weak or limited support for joins. When we talk about wide column database, there is again no support for joins. And in graph database, there is support for joins, so you can say good in joins, but of course SQL is best when we talk about the joins. Okay, next, talking about the scale. Okay, in SQL it is quite hard to do the horizontal scaling, or you can say the sharding part. We discussed in detail about that earlier in this video, because SQL is known like it was like built before all these distributed problems. It is quite old. It was built in a way like you will have one kind of database and you will keep on increasing. It's more about the vertical scaling. But when we talk about the horizontal scaling, which would be required if you have a huge amount of data, because you cannot have all the data in complete kind of system, right? So when you have different shards, right? So of course there are many problems. Joins also become distributed. There are a lot of issues in that, right? There will be network calls, it will become slow, and it is difficult to maintain the ACID support, strong ACID, which is the key feature of SQL when we have different shards, right? So what we do in that case is like we handle the sharding logic in SQL at application level. We try to keep all the data which is related in one shard so that we don't have to make like distributed joins and the problems that we discussed, right? So that is handled at the app level, and hence it is quite hard when we talk about horizontal scaling in SQL. Now, the NoSQL databases are generally built in a way that horizontal scaling is not that big of the issue. So when we talk about key value database, it's very easy. The horizontal scaling, it's kind of built-in kind of automatic feature. Talking about document database, again, it's easy. In wide column, it's very easy. Just you can say an exceptional case, graph database, it is hard to have like the horizontal scaling, because if you have like different partitions, it has to check the relations. If it is in the different partitions, it will become difficult. So the horizontal scaling is bit difficult when we talk about the graph database as well. Next, talking about the transactions, as we just said, SQL provides strong support for ACID properties, atomicity, consistency, isolation, durability. Key value database, it doesn't provide ACID support. Okay, talking about document database, it has limited kind of support for this ACID properties. Wide column database, again, no support. For graph database, because it is based on the relationships, and you can see bit of the similarity with SQL, although graph is a NoSQL database, but it provides good support for ACID properties. Okay, last, talking about the query power. In SQL, we have very high, or we have very rich queries that you can write. We also have joins, right? We discussed about different types of joins actually in SQL. So in SQL, you have very rich queries. You can query based on all the fields, properties, joins you can apply, right? When we talk about key value, the query power is very low. Why? Because you can simply query based on the key. You cannot even query inside the value. So it's very low capability of the queries or read operations. Talking about document, it is kind of medium, much better than key value, because you can even query on the field inside the document. So in that way, it's good as compared to key value, but of course not matching what we have in SQL. Okay. Next, wide column. Again, it's very low, because you need to know the partition and the row key for the queries, and it works on that way. So yeah, very low in wide column. And when we talk about the graph, it is mostly about the relationship based, like we saw, like it just match this relation. So in that way, it provides some of the capability. One more point that would be related to the write operations or the write throughput. In that, the wide column database is amazing, because it follows append only that we discussed earlier, and because it can have dynamic number of columns, it can even go in millions, right? So the write throughput is amazing in wide column database. Well, of course, you have like relation between the tables. It provides like table structure, different tables connected via foreign key, amazing in ACID support, right? Strong consistency. So this is used in most of the, say, banking applications, or where you need financial related transactions, because you need strong consistency there. So you always choose in that case SQL. When we talk about key value database, it is known for the fast lookup. Okay. So for the support like cache or sessions maintaining that, you generally use key value. You might have used or heard about Redis cache, right? So it is very famous, and like it provides like very quick support, because you simply query based on the key, and it provides you the value of that key. Okay, so fast lookups is for what key value database is known for. So if you have object like data, because it stores everything in the, you can say, in a document, say the JSON format. So in those kind of things, document database is good. Also in NoSQL database, if you need kind of good query support or read operations, so with flexible schema, document database is good for that. Talking about wide column database, it is used for storing time series data. It is good for that, and also it is really good for high write throughput, right? So a dynamic number of columns which can grow. So if your data keeps on growing, for that, like wide column database is really good. So known for the high write throughput and for time series storage. Next, the last category of NoSQL database is the graph database. It is known for like relationship based. So mostly if you talk about like social networks, like friends of friends or connections to connections to connections, first level, second level, third level. So if you have deep relationships, graph database is used for that. So you can clearly see this is SQL and these are the type of NoSQL database. Okay. So overall, as we already discussed, SQL has the good things like schema is fixed, good for joins, very rich queries, strong asset support, strong consistency, but it has its issues like the horizontal scaling is difficult. But in generic, NoSQL is good when we talk about the horizontal scaling because both has like different features. NoSQL is not known for like joins, for a strong asset support, no, because it is designed in that way. It is solving different kind of issues, whereas SQL is providing different kind of features, right? So in that way, you can clearly see both are different, and we also discussed about each of the database, how they are different. Yeah. So overall, SQL is like structured data, strict schema, tables, good for joins, rich queries, strong asset support, strong consistency. Whereas NoSQL is for flexible data and most important, automatic horizontal scaling, which is handled at the DB level. So till now we have covered about SQL database and NoSQL database. In NoSQL database, we have also covered all the categories of NoSQL like key value database, document database, wide column database, and graph database. Now SQL and NoSQL are basically the major databases which we use. But apart from that, we also have some other databases which are required for some specific operations. So let's discuss about some of those database. So the first one is search database. So a simple question that would come to your mind is, what is a search database? So search database is a separate category. It's not SQL, not even NoSQL, but they store the data. It is used to find or search the results from the large set of text or data. Some of the key usages of search database is Google search or the product search that you do on Amazon, log search, and autocomplete suggestions. What the search database care about is text relevance, partial matches, and the ranking. Now a simple question comes to mind is like why normal databases are bad for this kind of search. So basically SQL or NoSQL, they can do something like this. You can search with the where clause and put whatever field is there and then put the value, right? So if you want to search for iPhone in the database, both SQL and NoSQL can give you that kind of data. So something you can say like exact matching. So you can also do like a wildcard kind of matching in SQL NoSQL, but of course the time complexity of that would increase. But when we talk about the search operations, they don't just need this exact word. Apart from this, they would also need something like this where the user has made some mistake while typing, or in a sentence that basically word is present. All these kind of things are required when a person is searching, right? Now when we talk about all of these things, these require tokenization, ranking, scoring, fuzzy matching, and the regular databases like SQL and NoSQL are not built for this. Now the basic question comes like how the search database is able to do all this. The answer for that is using inverted index. Now what is inverted index? Let's try to understand that. So basically when we talk about normal index, it would be something like for a specific row you have a value, okay? But when we talk about inverted index, for a particular word we will keep the list of documents. I know it might sound confusing, so let's try to understand this with an example. Let's say we have two documents, okay? In the document 1 we have this sentence iPhone 14 Pro Max, and in document 2 we have this sentence Samsung Galaxy phone. Now basically these will be the inverted index that we will form from both of these sentences, okay? So what we will do is like we will pick each of the word. First is iPhone, right? So we will put it is present in document 1, correct? Then 14, it is also present in document 1. Then Pro, it is present in document 1. Then Max also, I think we missed the entry here, but for Max also we will have like this is the word, and corresponding to this we have like doc1, okay? Same as other words. And after that in the document 2 we have Samsung, so corresponding to Samsung we have kept document 2, then Galaxy, document 2, then phone, document 2. So you can clearly see for each of the word we have maintained like list of documents in which this word is present. So for now, all of the words were unique, so those were present only in specific document. So of course we will keep the original thing like this sentence, of course we will keep that, but apart from that we will also maintain the inverted indexes and some of the metadata. Okay, next let's see some more things related to the search database. So let's first see what are the types of search queries which are supported by search database. Of course, first of all, the full text search, it is allowed in the search database, but apart from that also we have many other things because this is also present in the SQL and NoSQL databases, right? But apart from the full text search, what we also require is partial match, like something like this. You have IPH and after that you can say it's a file case search. Okay, so partial search we should be able to match. Although this kind of thing we can also do in SQL, like in the rich queries, you can provide the while star operator also, and there are many other things that you can use, but of course the complexity increases for that. Next type is the fuzzy search, like for example, instead of iPhone, you mistyped it IPHNE. Okay, even for this, it should be able to show you the result because you might have seen when you try to type something on Google and you mistype it, it gives you a suggestion. Did you mean this word? Right? So it is able to search iPhone from this keyword also. Next is the phrase search. Okay, so from any phrase or sentence it should be able to fetch the word and provide you that search result. Next is the filters. Okay, you can also apply kind of filters like price is smaller than 50,000, and another thing is the aggregations. So all of these types are supported as search queries in search database. So like we discussed SQL, NoSQL, in SQL we have like rich queries. So SQL would be more used if you have to search for exact things or range, right? But the search database will be used for text similarity. Okay, it is also able to search for all of these things, which is an important criteria when you are doing searching. All right, next let's see some of the popular search databases. The most famous one is the Elasticsearch. You might have heard about Elasticsearch, right? So this is very famous, popular, and it is used widely when we talk about search-based databases. Few more are like OpenSearch, Solar, and Mealy-Search. Next, talking about the consistency model of the search database, they follow eventual consistency. So they don't provide like very strong consistency, it's eventual consistency. So the search databases are optimized for reads. So whenever you make a write, there will be index update and that will be searchable after delay. Okay, so you may not always get the most updated data. Okay, so it provides you eventual consistency, not the strong consistency. So as we discussed earlier, the search database, we use it for, you can say, when you have to perform the search operations, right? You have to do all these kind of operations. You have to use for like autocomplete, or you have to do like product search, or even for log analytics, search database can be used. But next, when not to use the search database, it cannot be used as like primary database. As primary database, you would use either SQL or NoSQL. So this database is specifically used for the search operations. Okay, so one thing that you need to remember is like when we design a complete system, okay, inside this you may have multiple microservices where each of the microservice is performing different tasks. Okay, and there might be also a possibility that you might be using multiple databases. It's not a must kind of thing that you would have to use only one type of database. One type of database can be useful for one kind of service that you provide, whereas other database might be better choice for any other operation or service that you provide. Okay, so for example, we talked about what SQL and NoSQL are good for and not good for, right? So when we talk about basic authentication, and if you have to keep like user specific information which is structured, then you will prefer SQL. Okay, if you have to see in some of the services about the right scale or horizontal scaling, then in that you would use NoSQL. Okay, even though you might be already using SQL. Okay, you can have one more database, like you're using SQL, you're also using NoSQL. But apart from that, say there is some feature or service that you provide which requires a lot of search operations. So for that you will use the search database as well, but the search database will not be used as your primary database. It's kind of like for the secondary operation where you are providing something like search related service. Okay, for that you can use it. And next, when not to use is for transactions and when you need strong consistency, because we just saw we get like eventual consistency in the search database, so it cannot act as your primary database. It is specific for the search related services or operations that you provide in your product. So basically you can imagine as a primary database you might be using SQL or NoSQL, and then this search database, if you're using, it can act as like the secondary database. So it will pick the data from your primary database. Many models are there, like you can say through the events or something else, it will be getting the data, but the search database is not your source of truth. Okay, it is just used to provide a very smooth experience related to search operations. So we discussed about the search database here, but I know you might still have confusions about it. So let's take an example, and through that let's try to understand more about the search database. All right, so this is the example that we will see for the search database. Okay, so you can see in both we have like the documents as a JSON. You can take it as like we are using the document based NoSQL database here. Okay, so these are the two documents that we have. Inside that we have the information like doc ID, title we have, description we have, price we have, right? Now, what all things we will store? Of course, first the original thing, the documents will be stored. But apart from that, when we talk about the search database, there are two more things that are stored. First is the inverted index that we will create now, and second is the metadata. So clearly you can see there are a lot of words which are present in the title and description of both of the documents. Okay, so it will create the inverted indexes from these. Now how does it form the inverted index? Let's see the process. So the step one would be tokenization. What we are going to do is like break the text into words, so you can see the complete sentence or text here. Similarly for this, similarly for this and this, what we will do is like break it into words. So we have Apple, we have iPhone, we have 14 Pro. So all of these are present here. And then in the description we have best camera phone. So you can see best camera phone here. Basically from the text we have found out the words. Similarly for document 2 we will create the tokens. First for the title, Samsung Galaxy S23. So you can clearly see these are present here. And then from the description we have Android flagship phone. So you can clearly see that as well. Okay, so from document 2 tokens we get all of these. So now as we have the tokens available, what we'll do now is create the inverted indexes. Here you can see we have built the inverted index from the tokens that we have got. Okay, first token was Apple and that is present in document 1 only. Then iPhone, document 1, 14, document 1, Pro, document 1, best, document 1, camera, document 1. Phone is something which is present in both of the documents. You can see in document 1 as well and in document 2 as well, right? Next we have Samsung, which is present in document 2 only. Galaxy, document 2. S23, document 2. So for S23 also we will create something like this, S23 and 2. Okay, because that is only present in document 2. Then we have Android. So Android, document 2. I think we missed out here. Similarly for flagship we will create like document 2. Okay, then phone we have already covered here. Okay, only the phone keyword is present in both of the documents, right? So this is how we create the inverted index, and they really help to make the search fast. All right, so apart from storing the documents and the inverted index, what we also store is the metadata, and metadata helps us in ranking and filtering. Okay, so for example we have like title and description present in the document. So in the metadata we can define what will be given more priority or more weightage. So like title will be given more priority as compared to description, you can say. All right, so the basic point here is we store three things. Of course we store the original document which we have here. Second thing is the inverted index. You can clearly see how we build the inverted index, and then we will store these inverted index. And the third thing is the metadata. which will help us in ranking and filtering. Okay, so now what I'll do is I'll remove some of the information from here because we want to see how the search operation is performed. Okay, all right, so these are our original documents. These are the inverted index. Of course, few of the inverted index are missing here, like flagship is missing, S23 is missing, but it's okay. I mean, you got the main idea how we are building the inverted index, right? So I've kept the inverted index here, and then we have this as a search query. Okay, the user has searched iPhone phone, right? So now let's see how the search database will search for this query. Okay, the step one is tokenize query. Just like we tokenize the documents, in which we basically fetched out all the words which are present in the document, right? In similar way, now we will tokenize the query. So all the words which are present inside the query, we will tokenize, or we will fetch out the words from it. So the words that we get from this one is iPhone and phone, because there are only two words in this query. Then the next step, step 2, is lookup inverted index. We have already created the inverted index here. So now we also have the tokenized query, correct? So the keywords which are present in the query, so we will search them in the inverted index. So clearly we will search for iPhone and phone in this inverted indexes. What we will get is like iPhone is present in document 1 and phone is present in two documents, document 1 and document 2. So you can clearly see we get this result, right? Quite easy because we have already built the inverted index here. So we just had to look up for the words in the inverted indexes. Okay, after this, the step 3 is find matching documents. So if our query was something, we have to find intersection, like both of these words should be present, we need to just return those documents. Then the answer would have been document 1, because in document 1 we have both the keywords, we have iPhone as well and we also have phone in document 1. So if we had to find out the intersection of all the words in the query, then it would have returned the document 1. But in case we have applied OR operation or the union instead of the AND operation or the intersection, then we would have returned both the documents, document 1 and document 2. Why? Because iPhone is present in document 1 and phone is present in both the documents, document 1 and 2. Now we have like applied the OR operation, like any of the keyword is present in the document, return that document, then the answer would be this. If we were talking about the AND operation or the intersection, then the answer would be this. Correct? All right, next, the step 4 is scoring the documents or the ranking. We earlier discussed that we store the original documents, the inverted indexes and the metadata. So metadata helps you in the ranking, in providing score to the documents, correct? So here you can clearly see the iPhone was present in title. So this was present in the title of document 1. And when we talk about phone, that was present in the description of document 1. Now in metadata, we store this kind of things like what should be given more weightage. So like I said, in the metadata, we decided to give more weightage to the title. So document 1 will have high score because iPhone is present in the title and phone is also present in the description, although description is given low weightage, but both of the keywords are present first of all, but very high weightage because iPhone is present in the title. Okay, and when we talk about the document 2, it only contains the keyword phone, right? And that too in the description. So document 1 will get higher score or ranking. Why? Because one of the keywords was present in the title, and in the metadata we defined title will be given more weightage than the description. Okay, so this step happened after step 3, where we found the matching documents, and based on what we got, we performed scoring of documents on that only, because here we are taking example of union. So we had both the documents, so that's why we did this step where we are scoring the documents, because we have to rank the documents as we have to show the result to the end user, right? It would be like you are giving the ordering, kind of, you are showing the results based on the priority or the ranking that your system generates. So this step provides you the ranking. So till now, if the query was this and then we were following the OR operation or the union, then document 1 would have higher ranking as compared to document 2. Okay, but after this we have another step, which is apply filters. That can be optional because it depends if the filter has been provided in the query or not. But let's say in the query we were also provided a filter related to price. Say user has said the price should be less than 1 lakh, or you can say price should be less than 100,000. So if we apply this filter now, because we have like both of the documents, if we see, although document 1 till step 4 had like higher ranking, but if you see this filter, it doesn't match here. Okay, the price of this device is more than 100,000. Okay, whereas when we talk about document 2, the price is less than 100,000. Or if we talk about like price, here you can see is more than the filter amount that we have set, whereas when we talk about document 2, the price is lesser than the filter amount. So this fulfills the criteria, and that's why document 1 is out due to this filtering and document 2 is in. And next we will have the last step, which is the step 6, where we will sort and return the result. Okay, of course the final result depends on the query and the filters that we apply. Okay, if there are no filters, then till step 4 document 1 had more ranking as compared to document 2. So say the query was simply iPhone phone and we were applying the union here, so the end result would have been document 1 and then document 2. Document 1 has the more priority. So the search database would have returned document 1 and then document 2. Now after that, what to show, like it depends on what you want to show. That can be at your backend logic. Like say you simply show the title, then you will return that, and on UI you can bold that kind of text. Or if you have to show both of the things, the title and the description, you can send that. So all those things you can manage at backend, and how to show you can handle that at front end, like bold the characters or whatever. But the search database will basically send you the document IDs. So first it will send you the document ID 1 and then document ID 2. But let's say if the query was this iPhone phone with the union, and apart from that we have also applied the filter like price should be smaller than this amount, then as we saw, the document 1 doesn't fulfill this filter because the price is greater than whatever amount we mentioned, and in document 2 this filter was fulfilled. So in that case, if we say this in union with this filter, then it will only return document 2 because document 1 is not fulfilling the filter. Okay, so it will send document 2 ID, and then of course your backend logic what to show, and on the UI you can make your logic how to show that thing, right? So I hope from this you got the idea. We have mentioned all the steps here. It's not that complicated. You will first try to find out all the words from the query, then you will simply look in the inverted table, you will get the documents in from that, and then you will apply the logic of finding the matching documents based on if it's an intersection or union. And once you have the documents with you, you will score the documents doing the ranking using the metadata. Fifth step would be apply filters if there are any, and in sixth step you will sort and return the data. So this is how the search database stores the data and how it searches for the data. So here we took example of the normal complete keywords, but we also mentioned that the search database is also capable of doing the fuzzy search or even for the partial match. How does the search database do that? It is able to do that using the prefix tree or n-grams. So it is able to identify the partial words using this. Similarly, for the fuzzy search, it can edit the distance and find out the result for you. But let's not go deep into that because more important was like we wanted to understand how it works for normal kind of search things, and we have talked about it. All right, so this is how the complete flow would look like. Okay, user will type the query like we said, this query iPhone phone. So the user will type the query, then the backend will call the search database. Now because the microservice already knows that we have specific database, the search database for these kind of operations, so it will redirect to the search database, and then search database will return the documents and the scores. How? We just discussed all the 5 steps here, right? From this, your search database will return the document ID and the ranking of those document ID or the scores. Okay, now it's up to the backend how it wants to format the response, right? And then on front end it will show whatever it wants to show, and it can also highlight the things, like it can make the search query in the results as bold, right? So this is how the complete end-to-end flow for the search query would look like. Okay, so this was about the search database. After this, let's talk about one more special case, which is time series database. All right, now let's discuss about time series database. Now you might think, hey, wait, you said that in wide column database we can do time related storage. Yes. So what is the difference then between time series database and the wide column database? Don't worry, we'll discuss about it. But before that, let's discuss in detail about time series database. So a time series database is optimized to store and query data points ordered by time. Okay, every record has time as the most important dimension. Some of the examples where time series database would be used are like you have to store CPU usage every second, stock price every millisecond, app request count per minute, or temperature from sensors every 5 seconds. All of these look like corresponding to time, you have the value. So time is the most important dimension here. So if we take example of CPU usage every second, it would look something like this. Time was 10 hours, 0 minutes and 1 second, and we have data corresponding to it, like CPU usage was 60%. Then at next second, the CPU usage was 63%. Then next second it was 61%. So time always increases, and because you have so many writes, so writes are append only here in the time series database. So you are just appending the data. So this thing here, for example, the CPU usage or stock price or app request or temperature, so this is the metric, right? Next, as we said, the time is the most important dimension, so this is timestamp, right? So we have already written timestamp here. So this is a very important part of time series database. So I have created a border across the timestamp because it's a key concept of time series database. So we have metric, we have timestamp. Next, this thing like host or the region, they come under tags or dimensions. So basically in tags or dimensions, we have things like host and region. And then finally we have the value. So these four are the core concepts of time series database. First is the metric like the CPU usage. Next we have the timestamp where you have the time. Then we have the tags or dimensions which tell about the host or the region. Then you have the value, like you are storing the value 60%, 63%, etc. So this is how it looks internally. You can see we have the metric as CPU usage. We have tags like host, server 1 as like whatever region it is. And then region provides the information of the region, and then you have the time. Corresponding to time you store the value. For example, like we have this data, so it appears something like this. This is the time, this is a value. So at second 1 we have 60 as a value, second 2 we have 63 as value, and second 3 we have 61 as value. All right, after this, now let's see how the time series database is different from normal database like SQL and NoSQL. So if we talk about storing this kind of data in SQL or NoSQL database, then you will have too many write operations, because you can clearly see with every second you have new data, correct? So it will keep on increasing as the time always keeps on increasing, right? So you will have too many write operations. There will be huge indexes because you have the indexes for the read queries, right? But when you write, indexes make read query fast, but they make write operations slow, because when you write, you have to write in database. Also, you have to update the indexes. So the data of indexes will keep on increasing as well. And next thing is you will have expensive deletes, because your data keeps on increasing. Of course, you need to delete it as well. So that would result in an additional operation. And another point is in SQL NoSQL, you have slow range queries. Of course, in NoSQL, there is one database, wide column database, in which you can store time series data. But we will discuss about the difference between wide column database and the time series database later. Okay. So this was why normal SQL or NoSQL database is not good for time series kind of data. But now let's see why time series database are good for this kind of data. So they are optimized for massive kind of write operations, because they strictly follow append only. Okay, next they are optimized for time range queries, so you can perform time range queries here. We'll see an example later. And it is also optimized for aggregations over time, so based on the time duration you can do the aggregations here. And lastly, automatic date expiry, so you don't have to deal with the delete operations. So as we said, like time series databases are optimized for massive write operation. So let's see how write operation work in time series database. So in time series database, we perform append only writes. Okay. So whenever you get the new data, it is appended at the end of file. So there are no updates, just the new data is appended at the end of file. So this gives you very fast writes. Next, let's see how data is stored internally in time series database. So the first thing is time based partitioning. So in partition 1 we will have data from time 10 to 11, and in partition 2 we will have data from 11 to 12. So when we talk about the read operations, only relevant partitions are scanned. Okay, because we know like in this partition we have data specific to this time period, and in this partition we have for this time period. So whenever you get the query, based on the required time we scan the specific partition. Okay, the second point is it has column oriented storage. So instead of storing it as time host value, it is stored as time is this and value is this. So you have column oriented storage. So from this you can directly get this time, and this allows faster scans. So you can clearly see corresponding to time we have the value. So time is the most important part of the time series database, and through this you get like faster scans. Another point related to time series database is that it enables compression as well, because in time series database you have ordered timestamp and similar kind of values. So it uses compression tricks like delta encoding, which stores the differences only, or run length encoding. So based on that it compresses the data. Okay, for example the data was 60, 61, 62, 61. So it will store the deltas plus 1 and minus 1, because this value is greater than the old value by 1. Again 62 is 1 more than 61. When we talk about 61, it is 1 less than previous value. So like this we are simply storing the deltas. So because we have compression in time series database, the storage is cheap. So these are some of the examples of the query for time series database. For example, average CPU time in last 5 minutes. So you'll do average CPU usage where time is greater than current time minus 5 minutes. Okay. Similarly, max temperature per hour. So max temperature group by hour. So all such queries are performed for time series database. Another key feature related to time series database is downsampling. So basically it will summarize the old data. Okay. For example, we get the raw data every second, and after 7 days it will form 1 minute average. After 30 days it will form 1 hour average. So like this there can be multiple downsampling that can be done, and this saves storage and speeds the query because you already have that information, so the queries will be fast. Now apart from downsampling, we have one more important feature in time series database, which is retention policy. We saw that in normal generic database like SQL or NoSQL, deletes will also be expensive. You have to take care of that. But we have retention policy in time series database, so it will have something like keep raw data for 7 days, keep hourly data for 1 year, delete older data automatically. So basically there are no manual deletes. Time series database is handling it automatically using the retention policy. Okay, now let's see some of the popular time series databases. Because we have discussed a lot about time series database, now let's see some of the famous time series databases. First is InfluxDB. So this is a pure time series database. Second is Prometheus. This is also quite famous and it is monitoring focused. Next is Timescale DB. This is a mix of SQL and time series database. Another one is OpenTS DB, which is built on HBase, is a NoSQL database. And one more is ClickHouse. Okay, so all of these are time series databases. Now come the main question, when should you use time series database? So use time series database when data is time ordered, because time is the most important dimension in time series database. Next thing is when there are lot of write operations. So writes are more than reads. When your data is mostly append only and your queries are time range based, because we saw an example like how the queries look like for time series database, right? So when you have these kind of things, then you should use time series database. Now when not to use time series database, when you have frequent updates, because in time series database writes are strictly based on append only, okay? And you should not use time series database when you have complex joins. Another thing is you should not use it when you require strong transactions like strong asset properties, strong consistency, which we see in SQL. Okay, so if you require these things, you should not use time series database. Alright, we have discussed a lot about time series database. Now let's move to an important question, which is what is the difference between wide column database and time series database? We mentioned earlier that wide column database can be used to store time series data. So then why do we have time series DB? So basically wide column database can store time series data, as we said earlier, but time series databases are built specifically for time series data. Okay, so yeah, wide column database can be used to store it, but this is built specifically for the time series data. So you can think like this: in wide column database like Cassandra or HBase, I can store anything at huge scale, because wide column database is also good when you have massive writes, as in this you have dynamic number of columns and the columns can be in thousands or millions, right? So I can store anything at huge scale including time based data. Okay, so yeah, you can store time series data in wide column DB, but when we talk about time series DB, examples are InfluxDB, Prometheus. So this says I exist only to store and analyze time based data efficiently. Okay, so this is giving you an option. Yeah, you can store time based data as well, but time series DB is specific. It exists only to store and analyze time based data efficiently. Okay, let's try to understand more about it. Okay, so when we talk about like data modeling, right, in wide column database like Cassandra, schema would be something like this: primary key contains device ID and the timestamp. This is your row key, device 1, and corresponding to it we have the columns, right? So these are the columns and it can contain a lot of columns. As the time keeps on increasing, we can keep on increasing the columns as well. Now the important part to see here, the good thing is time is part of the primary key, as you can see here, and in wide column DB we have data sorted by timestamp, as you can see here. These are the good things, but time is not the first class concept. Correct? So you have the row key and inside that you have the columns where you store the data. Right? Now let's see data modeling in time series database. Example is Influx or Prometheus. So you will have something like this: CPU usage is the metric, host and region are tags, and then you have value corresponding to the timestamp. So when you see the data, it would be like time. So corresponding to time, you will have the value. So time is mandatory, central, and optimized at every layer. So this was the difference between wide column database and time series database in terms of data modeling. Next, let's see the differences between both of these in terms of storage engine. Okay, when we talk about like the storage in wide column database, it is based on row key and the family columns or the dynamic columns, right? Corresponding to the row key, you have the column family and then the dynamic number of columns. Whereas when we talk about time series database, it is a combination of columns and time blocks. Talking about the time awareness, it is basic in wide column database, whereas it is native or the most important thing in the time series database. Talking about the write pattern, as we discussed earlier in wide column database, in general it is append, but in time series database it is strictly append. When we talk about compression, it is generic in wide column database, whereas it is time aware compression in time series database. So everything is specific to time in time series database. Talking about retention, retention is manual or TTL kind of expiry that you give in wide column database, whereas when we talk about time series database, it is built in. We saw the retention policy, right? So that is built-in feature in time series database. And lastly, when we talk about the downsampling, it is manual in wide column database, whereas it is built-in time series database. Alright, so earlier we saw differences in terms of data modeling. Next, we saw differences in terms of storage engine. Now let's see the differences in terms of query capability. So first, when we talk about wide column database, if we make a query like get last 100 readings for device X, so it will be hard. Few more examples are average over last 5 minutes, group by 1 minute, rate of change. So all of these require app logic and they require Spark or analytics layer. Okay, so apart from wide column database, we would require another layer there like Spark or any other tool which would help in performing all these queries. Next, if we discuss about time series database, if we make query like average CPU where time is greater than current time minus 5 minutes, then it's easy for time series database as it has built-in time windows, aggregations, rates, and percentiles. So many of the things or data related to time is already built in. So it's quite easy for time series database to give result of such queries, right? So these are the differences between the wide column database and the time series database. We saw the differences in terms of data modeling, like how data is stored. Then we also saw like differences in terms of storage engine, what they follow, like time awareness, write pattern, compression, retention. For example, in wide column database, you have to handle the deletes in manual way or using TTL, whereas this is built in time series database, also the downsampling, right? And next we saw the query capabilities difference, right? So if you have to make queries like this, it's quite easier when we talk about time series database, whereas when we talk about wide column database, apart from wide column database, you have to use another layer like Spark or any other analytics layer to help in these query, because it would require some kind of aggregations and all those support which are already built in time series database. Now you may have one question in your mind, like if we have time series database which is specific for time series data, why would companies still use wide column database for storing the time series data? The answer to this question is because company might be already using wide column database like Cassandra. Okay, then instead of using another database specific for particular operation, it uses the same one. Another reason can be it needs extreme availability. Now time series database is good for specific operations related to time series data or querying that part, but wide column database is better in terms of like extreme availability or other features, because wide column database is generic NoSQL database which is used more frequently for primary kind of work, right? So they might be already using it and they would like to just extend the role of current database like wide column database for storing another operation related to time series data, as wide column database can store time series data, right? So instead of using a new one, they just extend the role of the current database. So for that, what they need to do is, like as we saw, they would need another layer like Spark or any other analytics layer to handle the queries like this, correct? So they are okay with writing that aggregation logic or using the tools like Spark or some analytics tool for that logic, right? So that is one additional step, but they feel it is better than using another database specific for some operation, right? All right, now let's discuss in terms of interview. So if in an interview you are given like a high level design question which requires time series data related operations, something like a monitoring system, then you have two options, correct? First one is using the wide column database, which is type of the NoSQL database like Cassandra, right? So how will you handle time series data? It can store time series data, so it can store the raw metrics, and then you will use Spark for aggregations. Like we saw, the wide column database would require additional step because it is difficult to handle these kind of queries for wide column database, right? So we will use Spark or any other analytics layer. Okay, so apart from wide column database, we will use Spark for aggregations. So we will handle deletion using TTL, right? Because deletion part or retention part is not built in feature of wide column database. Okay, or the other option is you can directly use time series database like Influx or Prometheus. So it will store the metrics, the aggregations are built in, the retention is built in, and you would require less code. Okay, now coming to advise what answer to give, like if the interviewer asks you specifically which database will you use. Okay, so it depends, like if your question is very specific to time series data related design, then my choice would be to go with time series database, because it shows that you have good knowledge about the databases. Like time series database is built specific for that kind of functionality. So if in your system design interview the interviewer is asking specific question related to time series data and then asking which database will you use, I think better option is to say time series database like Influx or Prometheus, and then you can tell why, right? But as you know, the system design rounds are quite open ended. Okay, so in case you see the interviewer is not aligned with you, or the question was bit more generic, like you had to design few components and time series data was just one more operation or another thing that was required here, then you can also go with this option. You can tell you can use wide column database like Cassandra, and then you will use the Spark for aggregation, and then you will use the TTL for deletion. Okay, the good part here is because we are understanding the things here and we are not just remembering, okay, do this, do this, do this. You can explain the logic, right? And that will show that you have good knowledge about the database layer, right? And that would be quite impressive, to be honest, because a lot of people might not even know about time series databases or the name like Influx or Prometheus. So if you tell that, it's a really good impression that you have knowledge of the deep concepts out there, right? So you can say this, but if you see the interviewer is not aligned with you, you can say, okay, what we can also do is like we can use this kind of option where wide column database and use the Spark for aggregation. Okay, but if the overall system is like you need extreme availability, if you need massive writes, and for generic operations in that system also you are already using wide column database, then of course you can put these as additional steps because your current database can handle time series data. Okay, so depending on the question and the situation you can choose between both of these options, but the good part is you know about both of these options and you can tell. So I don't think that will be any problem if you know the concepts, right? So this was about time series database. All right, next let's discuss about another concept, which is OLTP versus OLAP DB. Okay, so it's a very famous interview question. What is the difference between OLTP versus OLAP database? Okay, first let's see the full forms of both of these. OLTP stands for online transaction processing. So OL means online, T stands for transaction, and P stands for processing. Whereas when we talk about OLAP, the full form is online analytical processing. So OL stands again for online, A stands for analytical, and P again stands for processing. So clearly the only difference that you see is transaction versus analytical. Rest both have online processing, and the common part is online processing. Just the difference is transaction and analytical. So OLTP is used for your transactions, basically running your business, whereas OLAP is more on the analytical base, like you try to understand the business based on analytics or the metrics, logs, all such things. So first, if we talk about OLTP, the purpose is to handle day-to-day operations in real time. So as you can see, it contains transaction. So the real business it handles. So day-to-day transactions which are happening, it is handled by OLTP. Some of the examples can be placing an order, booking a ticket, transferring money, updating user profile. So all the major operations that your product provides, that is handled by OLTP. So if we talk about some of the characteristics of OLTP, then it's, so in this we will have many read and write operations, we will have short queries, we will require consistency, we will require high concurrency. So both SQL and NoSQL databases that we discussed can be part of OLTP category. So this is kind of a category, you can say. This is not a separate database. These are just kind of categories. So in OLTP, you can say both SQL and NoSQL databases can come, which handle your day-to-day operations, right? So here we have a query example for OLTP, like select star from orders where order ID equal to 101. right? And one more example is update orders set status equal to paid where order ID equal to 102. Okay, so we have already seen such of those queries in SQL and NoSQL, right? And these are fast, these are index based, the result can be single row or multiple rows. So here we discussed about OLTP. Now also let's discuss about OLAP. Okay, so what is OLAP? The full form is Online Analytical Processing. So as you see in the full form, it contains analytical. So this category will be used more for understanding the business, like the analytics, metrics, logs, etc. So the purpose is to analyze large volumes of historical data from which you will understand the business, like what's happening overall, correct? So examples can be monthly revenue trends. So you can create some metrics by analyzing all the data and you try to collect monthly revenue trends, or user behavior analysis through which you'll get an idea like what most of the users are using in your product. You'll get more understanding like where to expand your product, what people are liking, what people are not using, all such kind of things. Another example is sales by region, like which region is giving you most sales, where your product is not doing well. So you will analyze all those things from here. Another example can be average order value per week. So clearly you can see when we talked about OLTP, in the examples we talked about the transactions that are happening, or you can say all the operations which are running your business, like booking a ticket, placing an order. Whereas when we talk about OLAP, here basically we are trying to understand the stats, or we are doing the analysis, how user is using, which region is doing well. So you are just understanding the analytics, the metrics, the dashboards. So you are just trying to understand where your business is going, and according to it you can take more actions. Now some of the characteristics of OLAP, we have most of the operations are read. We will have large scans because you will have a lot of data, right? And you will analyze that large volume of data, so you will have large scans. You will have complex aggregations because you are trying to do all such things here, right? So you will have the complex aggregations, and you will have less frequent queries. Now an example of OLAP table could be something like this. Here we are talking about the sales fact. You can see we have the date, we have the product ID, we have the region, and we have the revenue. But there will be huge amount of data. Okay, so there can be millions or billions of rows here. Now let's see one of the query examples of OLAP. Okay, so here we do select region, and then we do a aggregate operation here, sum of revenue from sales fact. Sales fact was our, you can see the table here, right? And then we say where date is between this and this. So we have given the date range. So we had this field date, and here you can see we have given the date range, and then we have said group by region, correct? So this is an example query for OLAP. So OLAP queries are generally long running, they have heavy CPU and disk usage, and they have large scans. Okay, now let's see core architectural difference between OLTP and OLAP. Okay, first talking about the purpose. OLTP is used for transactions, whereas OLAP is used for analytics. Clear, because only difference in the full form is also between transaction and analytics, right? Then talking about the query size of OLTP is small, whereas for OLAP the query size is large. Talking about the read writes, in OLTP we have both read operations and write operations. When we talk about OLAP, we mostly have the read operations, because as you have to do the analysis of all the data, right? Talking about the concurrency, it's a very high requirement in OLTP, because OLTP is used for the transactions, like you have to book a ticket. So say there is only one ticket left and two users are trying to book the ticket. If you don't have the concurrency control there, then both of the users will book that ticket, and that will be a big trouble. Now if we talk about OLAP, the concurrency is moderate in it. When we talk about data size of OLTP is in GBs. But when we talk about OLAP, the data size is in TBs or PBs. So you can understand we have really high volume of data in the OLAP. So because you have all the historical data, and then you have to analyze that. So clearly we are not performing any of updates or delete operation here. We are kind of just appending the data and then doing most of the read operations on that huge amount of data. So the data in OLAP is huge as compared to OLTP. Now when we talk about the response time, it is in millisecond for OLTP because of course the end user is using your OLTP, correct? Because the transactions are happening through OLTP, so it needs to be fast. It's just like you want to book a ticket, okay? If it will take a lot of time, the user experience will be really bad and user will not even use your product, right? So it needs to be very small in milliseconds. But when we talk about OLAP, this is mostly for analytics. Like your developers are kind of using it to analyze the data, to create the dashboards, metrics, which are further used by other people in the company, right? So in this, the response time can be slow, and that is totally fine because you have to scan a huge amount of data, right? So response time in OLAP is generally in seconds or even in minutes. That's totally fine. It's like a long running operation, and through that you get your data, and it's fine because the user for this OLAP is your kind of developers or other employees in the company and not the end user. But when we talk about OLTP, the user is actually the end user who is trying to book a ticket or buy a product or something like that, right? So in this, you need to provide the features like very less response time, high concurrency, reads and writes, right? So all those things are provided by OLTP. OLAP, you can take some time in the response time, like even in minutes. Data size is high, concurrency is moderate because it's okay in that part because it's not the end user who is actually using your OLAP. So these were the differences between OLTP and OLAP on architectural level. Now let's see the differences in storage format. So when we talk about OLTP, we have row based storage in it. For example, in your row, you have the order ID, user ID, amount, status, created at, just like we saw in SQL or NoSQL, right? So when you fetch a row, you get all the data corresponding to that row, right? And why do we have row based storage? Because through this, you'll fetch the whole row data fast, and it is perfect for point lookups and updates. Examples are MySQL, Postgres, Oracle, the SQL, or even some of the NoSQL database. They can be used as OLTP. Now, when we talk about OLAP, we have column based storage in this. Like for example, here we had all the data in the row. Here we have column based storage. So order ID is one column and corresponding to that you have data. Amount is one column and all the data is in that amount column related to amount. Then region is one column. Now why do we use column based storage in OLAP? Because we have to scan only required columns here. Like in OLTP, we generally try to fetch the row through which we get all the data which is present in the row. But here in OLAP, the requirements generally are specific to one of the fields, okay? And we store the fields as a column. So basically, when you fetch a column, you get all the data specific to that column only, right? Like here in the row, you would have order ID 1, user ID say 2, amount is 300, status is like anything you can say 200, right? And created at some time. Next row would be some other data. So when you fetch, you get all of these fields for a particular row, because mostly your requirement related to transaction is like that, because you want to know user ID, what was the time, and what was the amount, status, all such things. But when we talk about analytics basis, you generally have the requirements to scan data related to particular column only, and you store as column based. Okay, so you will scan say for amount, so you'll get all the amounts, and through that you will do some aggregation and find out what is in generic your the amount value, the average, or whatever you want to calculate through that, right? Similarly, if you query for region, you will get all the regions, and then you'll get to know which regions you have more business and in which region your business is bit lacking. So because analytics has more requirement or queries like that, so we do column based storage in OLAP. And other points is we can do better compression and faster aggregations in column based storage. Some of the examples of OLAP are Snowflake, BigQuery, Redshift, ClickHouse. Now next, if we talk related to schema, then for OLAP, we have denormalized schema. Like in SQL, you might have seen we tried to normalize the data, correct? But in OLAP, we follow star schema. What is star schema? Something like this you can see. So all of the data would be present together. So we have the fact table, in that you have the region dim, you have user dim, you have date dim, and you have also product dim. So you can see it contains data related to all of the things. Now why is it required? Because as we said, in OLAP we will have most of the read operations, right? And if your data is across multiple tables, then you would require joins. So using this star schema, you will have fewer joins, you will have faster reads, because most of the operations here are read operations, so you want faster reads. So that's why you keep all the data kind of together, and you have simpler queries because you don't have to apply joins here. It will be more simpler that way. Okay, one more important thing here is, as we said, like OLTP is used for your running the business and transactions. So OLTP acts as your source of truth. Okay. But when we talk about OLAP, the data in OLAP that usually comes through OLTP only. Okay. Because OLTP is used for your transactions running the business. So it will have the data. And then from OLTP, we give the data to OLAP for analytics operation. And how do we do that? We do that using pipelines like ETL or ELT, or you can also use batch or streaming jobs. So here a message queue like Kafka can also be used. So basically you will get the topics here, and then those can be consumed by OLAP. Okay. But we will not discuss about Kafka in this video, because this video is specific to database. If you want to know more about say Kafka, put that in comment section. I'll create a separate video that for you. But I have talked about some of the concepts related Kafka in the system design video. You can refer to this and you'll get more idea. Next, let's discuss why you should not mix OLTP or OLAP. Like why not to use OLTP for analytics and why not to use OLAP for the transactions. Okay, say you think like you can use OLTP for both your transactions and also for running the analytics. Then what will happen is like it will slow down the production traffic, because a lot of bandwidth will be consumed for the analytics operation as well, right? And OLTP, say we take example of SQL, so it follows ACID properties, it has strong consistency, it provides good concurrency support, so it will lock the tables and there will be a bad user experience. Okay, and if you use OLAP in running the transactions, then you will have slow writes, because OLAP is designed mostly for the read operations. So you will have slow writes, you cannot have proper transactions. Like if we talk about SQL, it follows ACID properties, high consistency. In OLAP, you don't get that. And due to OLAP, you will have poor concurrency. So there can be a case two users got a single ticket which was left, and it can create a lot of issues. So overall, as a summary, OLTP systems are optimized for fast concurrent transactional operations. Okay, using the row based storage. Here we have the row based storage, right? And normalized schemas, while OLAP systems are optimized for large scan analytical queries using columnar storage and denormalized schemas. OLTP is used for transactions running your business, while OLAP is used for analytics to understand the business. Now in modern times, we also have some of the hybrid systems in which some of the database try to do both of the things, like OLTP plus OLAP. Some of the examples are PostgreSQL, which is of type of OLTP. It's mostly a type of SQL, but it can also perform light OLAP operations. Then we also have ClickHouse, which is of type OLAP, but can also do fast inserts. We saw like most of the OLAPs can do are used for mostly read operations, but ClickHouse can also do some of the fast inserts. Then we also have HTAP, which is a hybrid one. It is mixed type, both OLAP and OLTP. But the point is, these are still not ideal for heavy workloads. Okay, so basically, if you are asked in a system design interview question, okay, like if your some operation is related to analytics, then you should choose OLAP category database. Okay, and if you have to perform like transactions, okay, so this was like analytic purpose, and if you have to perform some transaction, then you should choose OLTP category, right? So with this, the interviewer will get to know that you have clarity about these categories as well, like OLAP and OLTP. Like, you know when to use OLTP for like day-to-day transactions related to your business, where end user is using the product like booking a ticket, whereas OLAP is used by the developers or other employees in your company to read huge amount of data and to analyze that. Okay, so let's summarize it for OLTP and OLAP. So OLTP DB is like source of truth because it is handling all the transactions, it is running your business. When we talk about OLAP, it is like a copy because we get this data from OLTP only, and this is for analytics purpose. So OLAP is not your source of truth. You get this data from OLTP using some pipelines or some jobs or through message queue topics. Any of the medium, you get that data in OLTP as a copy, and it will be used for analytics purpose. Now, one more thing is like both OLTP or OLAP can use SQL or NoSQL database. Like OLTP, it is very clear because it is used for day-to-day transactions, and we see SQL is used. Some of the NoSQL databases are also used in OLTP. Similarly, for OLAP, some of the databases related to SQL and NoSQL, depending on their properties, how they perform the task, what are their characteristics, they can also be used for OLAP. So these are just kind of categories, but databases, we generally use SQL and NoSQL in these. So here are some of the examples. When we talk about OLTP database, for SQL, we can use MySQL, Postgres, or Oracle. When we talk about NoSQL, we can use DynamoDB, we can use Cassandra, we can use MongoDB. All of these can be used for OLTP. When we talk about OLAP, some of the examples are related to SQL based OLAP. We can have BigQuery, Snowflake, and Redshift. When we talk about column store based, we can use ClickHouse and Druid. For search, we can use Elasticsearch, which is for analytics use, and we can also use time series database like Druid, Timescale, Influx. Okay, so here you can clearly see the two categories that we discussed just before this one, the search database and the time series database, which are a separate category from SQL and NoSQL. These two also are used as OLAP. These two are not used for OLTP because search is specific for searching something. It's not good when we talk about day-to-day transactions, right? Running your business. Similarly, time series database is specific to time series related data storage and performing well in those queries. Okay, so both of these, search and time series database, these are good for OLAP and not as OLTP. But overall, in both OLTP, OLAP, you can use both SQL and NoSQL database depending on what features that database provide. Okay, and overall OLAP can be used for like analytics, for creating metrics, dashboards, analyzing the logs, to get the aggregated data, to check the history. So this is the overall flow. So user will use your product via app or the web browser, right? And in this we will use OLTP because end user will perform the transactions like booking a ticket or buying a product. So for that we will use OLTP. OLTP we can use both SQL, NoSQL, like we can use MySQL here, like we mentioned this one, right? We can also use DynamoDB, which is type of NoSQL DB. So you can clearly see OLTP is acting as source of truth here, right? And from OLTP, we will get the data as copy in OLAP. How? We can use the jobs, we can use the pipelines, or we can also use the message queue like Kafka we mentioned here, correct? So from OLTP DB, the events or the topics are present in Kafka, and those will be consumed by OLAP DB, and hence OLAP DB will get the copy of data which will be used for analytics, right? Some of the example can be ClickHouse, as we mentioned here. This is column store type. Then we can also have BigQuery, which is type of SQL OLAP, And then root is also one more type, which can be of type like time series or column store. Okay, because you have a lot of databases present in both of the categories of SQL, NoSQL, and then also other categories of search DB and the time series DB. All of these databases have their different properties, and based on that they can be used as OLTP or OLAP. Okay, and then using the OLAP, because you have all the history of data here, you can use those to create like dashboards or create the metrics or to analyze things, to do the aggregations and much more. Okay, but mostly when we talk about OLAP, we don't do delete operations or update operations. We just keep on appending the data, so it has a lot of data, and then we just perform the read operations or aggregations on that whole data. Okay, so this was about OLTP versus OLAP, which is a very famous interview question. Okay, all right, now let's discuss some of the concepts which may be asked in the interviews. Okay, so one of those is NewSQL. So basically we discussed about SQL first, right? And then we also talked about NoSQL, correct? So in SQL we get strong asset support, atomicity, consistency, isolation, durability. We have rich SQL queries, we have normalization, we have joins, and much more features. But majorly SQL is used for strong asset, strong consistency. So that's why it's used for financial transactions, banking apps, correct? But there are issues as well. It is really hard to scale SQL horizontally because it would require sharding, and if your data is present in different shards, when we talk about joins, it will become distributed join. Okay, and across the shards it will be really difficult to maintain asset properties, right? So that's why that sharding logic is handled by app level, and overall the writes don't scale easily, correct? So we have some good things about SQL and some issues with SQL as well. Now when we talk about NoSQL database, the good point is horizontal scaling is kind of automatic feature in NoSQL. These are designed in this way only. So the issue we had in SQL is automatically fixed in NoSQL. So this logic of horizontal scaling is handled at the DB level for NoSQL, which was handled at the app level for SQL. Okay, apart from that, there is high availability, writes also scale easily, but there are some issues. In SQL we got strong asset support, and that is bit of missing in NoSQL. Okay, so we have weak transactions, eventual consistency. Talking about consistency, we had like strong consistency in SQL, but in NoSQL we have eventual consistency. Next thing is, as we saw in SQL, it is designed like you have different tables and which are related to each other via foreign keys, and because you have to interact with different tables, joins are there in SQL. But NoSQL is designed in such way to give this feature of horizontal scaling that there is weak or no support for joins in different types of NoSQL databases. So we can clearly see there are some good points in SQL, but there are some limitations as well. Similarly, in NoSQL, there are some good points, but there are some limitations as well. So NewSQL provides the positives from both SQL and NoSQL. So we will get strong asset properties support from SQL and easy horizontal scaling from NoSQL. So NewSQL is a combination of good properties of SQL and NoSQL, hence the name becomes NewSQL. Now let's see what are the things that NoSQL is trying to fix. Okay, so first talking about the SQL support. In old SQL, of course, we get that's a main feature, right? But talking about NoSQL, we don't have that SQL support. In NewSQL, we get that support. Okay, so it has picked something from SQL. Talking about strong asset support, in old SQL or normal SQL, we of course have that because that's a main property of SQL. In NoSQL, we don't get that support, but in NewSQL, we get that. So another thing that is picked from SQL. Now talking about horizontal scaling, in SQL this is an issue because of all the reasons that we discussed. In NoSQL, horizontal scaling is quite easy, and in NewSQL, horizontal scaling is easy because it is picked from NoSQL. So earlier 2 points were from SQL. This one NewSQL picks from NoSQL. Similarly, when we talk about distributed system, like it is quite related to horizontal scaling, so it is same as the above one. And strong consistency is what we get in SQL, it is missing in NoSQL, and NewSQL also provides it. So you can clearly see NewSQL picks some of the good properties of SQL and some of the good properties of NoSQL. Then we mix both of these to form NewSQL. Alright, now let's see some of the examples of NewSQL database. Okay, so first we have Google Spanner, then another example is Cockroach DB, then we have TIDB and much more. Okay, so you can just remember one or two examples of NewSQL database. Same is for other, like when you talk about SQL, you should know one or two examples of that. Similarly, when we talk about NoSQL, we had four categories, right? Key value, document based, wide column, graph. So you should know like one or two database example for all of these. So similarly, you can remember like Google Spanner or Cockroach DB as an example of NewSQL database. Now a question may come into your mind. We said that NewSQL has the good part of SQL as well as NoSQL. So the question is, why not always use NewSQL? The answer is NewSQL provides you features of both SQL and NoSQL, but you have to pay for that price in terms of cost, latency, and complexity. So NewSQL provides you support of strong consistency, but the trade-off is higher latency. So let's discuss more about this higher write latency part. So when we talk about traditional SQL, it is formed in a way that you have single node. Okay. When we talk about NoSQL, there are multiple nodes and it handles it in a different way. Basically, we'll do replica async, which means asynchronous way. Okay. In NewSQL, in order to provide support for both SQL and NoSQL, it becomes even more typical. So in NewSQL, as there are multiple nodes, so it would need multiple nodes to agree, and each of the write takes more network hops. So overall, the write latency will be higher in NewSQL. Now going to the next point, the benefit is auto sharding, right? Which is picked from NoSQL, because in NoSQL we have automatic horizontal scaling, as that logic is handled at the DB level. Okay, but the trade-off is we have complex internals. So the answer to this question is, although NewSQL provides you great benefits, some from the SQL and some from NoSQL, but with that there are some trade-offs as well. There is higher latency, we have complex internals, expensive writes, and the operational cost is quite expensive. So you can clearly see, of course there are benefits, but at the same time there are trade-offs as well. So it totally depends on what you actually want in your system, and based on that you can pick, because it's not a good idea to pick NewSQL for every operation, because that would result in higher latency, complex stuff, and a lot more increase in expenses. Correct. So if your system can be handled by SQL or NoSQL, so of course you will go for that. In case you really need NewSQL, then of course you can go for it. And as I told earlier, in the system, as you have different features that you provide in your complete product, so there is no such requirement that you have to just use single database. You can have multiple database. Okay, depending on what feature you are providing, based on that, whichever database is best for you, you can choose that. So your complete system can have multiple different databases. Okay, so based on what requirement it is, you can choose SQL, NoSQL or NewSQL. Now that I have mentioned that we can have multiple database, so let's discuss a bit on polyglot persistence. Now the basic question would come, what is polyglot persistence? So this is not a database feature, it is more like a core system design mindset. Now what polyglot persistence means is, you can use multiple databases in your same system. Okay, and each one of these will be used for a specific problem. So as we discussed, like we have SQL, we have NoSQL, we have Elasticsearch, we have time-based database, and we also have NewSQL, correct? So in your system, you can use multiple databases because your system provides a lot of features and functionality, correct? And depending on what problem you are trying to solve, you can choose a specific database depending on the requirement. So for the same system, we can have multiple different database used in it. Now the question can be, why do you even need polyglot persistence? Answer to this is, as we saw, SQL provide different features, but there are some issues with it as well. Similarly, NoSQL provides some good features, but there are some issues. When we even talked about NewSQL, it provided the combination of good features of SQL and NoSQL, but again, there are some limitations. So every database is optimized for something, but it is also bad for some other thing. So in your complete system, you may have different features. correct? And based on all of the features, there can be a case that a single database is not able to fulfill the requirements of all the features, correct? So in that case, we will choose the database specific to the feature, correct? If a particular problem is not getting solved by your current database, you can of course use another database to solve that problem, and keeping the old database in the system as well, as it is working fine for rest of the features. So in technical term also we can say different data has different access patterns, and that would require different storage. So we can imagine something like this. You have your front end, correct? It can be a mobile application or your web development where user is using the browser, correct? And from front end you want to interact with backend, correct? And that happens through APIs. If you want to know the basics of system design, how things work, you can refer to this video, you'll get the complete clarity. Okay, so this is your backend, but here is your database part, and you can see you can have different database for the same system. You can use SQL for some of the features where strong ACID properties are required, and for some other features where you see a lot of writes happening, you need horizontal scaling, you can use NoSQL. And then if you have a feature where you have to perform search operation like product search in Amazon, so for that search database you will use. And similarly, if you have to do some time series data based analysis, that can be for your metrics, dashboards, collecting logs, so you can use time series database for that. Apart from these, if in your system you require handling time series based data, like for example the click events on advertisements, you have to track those, so maybe for that you can use time series database. So these would come into your OLTP because these are for your major transactions which are handling the business. And then you can also have OLAP related, which is more for analytics. So OLAP also you can use like to checking logs, you're collecting all the logs, right? For dashboards, metrics, so all that you can have, like you have single complete system, but in that you can see you are using multiple different databases, and that is this concept polyglot persistence. Now let's try to understand this scenario with simple examples. Okay, like just imagine you have a system like Amazon. Okay, so of course you have user related information and they place orders, correct? So when we talk about orders, it is kind of like you are making financial transactions, so you require strong ACID support, correct? So for that you would either use basic SQL, or just in case you require you can use NewSQL, but most probably I think you'll go for simple SQL here. Why we need SQL here? The strong ACID support we need for financial transactions, because we need strong consistency here. We cannot do something like this: user has made the payment, so money deducted from user's account, but order got cancelled. So in this case you can see user is also not getting the product and money is also deducted. Of course you will find a way for it, but it can get really frustrating for the end user. So in order to make a smooth user experience, we want strong ACID support here, so that's why we would need SQL database here. Next feature can be product catalog. Now you can imagine there are a lot of products out there, correct? And each of the product may have different features, correct? When you talk about television, there are different properties related to television. When you talk about mobile phone, it has different set of properties. When you talk about washing machine or your microwave, it has different properties. So if you use like SQL here, it can become really difficult. Why? Because in SQL you have like fixed kind of schema, but here you can have different properties as per the product. So here we would like to use the document database, which is type of NoSQL database. Why? Because as I said, it will provide you flexible schema. Okay, so you can clearly see just for these two features we have already used two different types of database. So that is what we are discussing in polyglot persistence. Okay, next of course you would have the product search, because you have so many things to sell, so of course you should provide the feature of search, otherwise how would user reach to specific product, correct? So for search you neither use SQL nor NoSQL, correct, as we discussed earlier. So in this you would use search DB because it is much faster, it uses inverted indexes, and here you using the search index you can also do fuzzy search, partial search, rather than just comparing the exact word, correct? So here you can clearly see we are using another separate DB. So for inventory counts also we can use NoSQL. We have already discussed about NoSQL here. Next, if we talk about click events, say you have to capture the data related to click events so that you get the complete understanding like what most of the users use in your product, and it can also be related to some of the advertisements, correct? You get paid based on the click rates, correct? So you need to have that data, so it is time sensitive data, correct? So you can use time series database for this, which is specific to time series related operations, correct? But of course, if you are already using say wide column database, you can use that, because in wide column database also we can store time series database. But of course, time series database is specific for this, so it is even more efficient and optimized in terms of time series related data, correct? So you can clearly see we have another category now. And when we talk about analytics, because like you have such a big complete system, you also need all the things like you can see the logs, so you have to store all the logs, so you have huge amount of data in that. So for that you would use OLAP, correct, related to analytics, where you can perform aggregations. This is useful for checking the logs, dashboards, metrics. So clearly you can see in your system you have different features, different requirements, and based on that you select different database. And this is what Polyglot Persistence is about. Okay, now let's see how data flows between databases, because now we have said that we can use multiple database for in the same system, right? So we also need to know how data flows. So basically SQL or NoSQL, they act as your kind of primary database, because these are used for running your system. These are taking care for the transactions. So once you have the data in SQL or NoSQL, which is your OLTP, which is handling all your transactions, correct? Then after that the events or topics are now present in Kafka, or you can say CDC. So CDC is a kind of mechanism which says like, which picks any differences, new changes, you can say whatever has happened in the database, and picks the changes, and then through that it can use those changes, correct? So either through Kafka or CDC or some pipelines or some jobs, through that this data will also come to OLAP related database. Now in OLAP we handle the things related to analytics, correct? So for analytics operations, OLAP comes. Even the TSDB, that is the time series DB, or the search DB, they are also part of this category, OLAP. So OLAP gets copy of data. The source of truth remains SQL or NoSQL, which is your OLTP. Okay, but the main point is data is written once. It's not like you have to write data in all of the different databases. So data is written once, but it is read differently everywhere. Okay, so we are not talking about Kafka or CDC in this video, but if you want to know more about Kafka, put that in comment section. I'll create a separate video on that. But in short, if I have to tell, Kafka is like you can create the events or topics in Kafka. Okay, and it is like the event is published here, and now from Kafka multiple consumers can consume the event. Okay, and each of the consumer can consume at its own pace or rate. So it is totally fine if you have one event present in Kafka and one of the consumer consumes it now, another consumer consumes it after some time. Okay, that's totally fine. And in Kafka you can retain your data for like multiple days and even for weeks. So 7 to 30 days you can say the data remains retained in Kafka, so which is long enough duration, and during that time all of the consumers can consume those events. So you can just imagine when the data is written, events kind of created in Kafka that would stay there for like 7 to 30 days, and different consumers like OLAP, which can be used for analytics or even for search related operation or time series related things, all that consume that event from Kafka at their own pace. Okay, so that's why we said data is written once. All right, but now as we are using multiple database, one question that may come would be regarding the consistency, correct? So how about the consistency, because we have multiple databases? So what happens is like we have strong consistency within a database, because we have multiple DBs, right? So within our database, we will have strong consistency, but there will be eventual consistency across DBs, correct? So similar to what we discussed here, when you make a write operation in your OLTP like SQL or NoSQL, of course there will be strong consistency in it, but that data won't be immediately visible in OLAP related database, correct? So that would come after some time, right? Because this has to consume the events from like Kafka or CDC, that would take some time. So there is eventual consistency between the different databases, but when we talk about the specific database, there would be strong consistency in that database. Okay, so for example, a user placed the order. So because we were using the SQL database for orders related thing, because it required the financial transaction, strong asset support, strong consistency, right? So that would be immediate. Okay, strong consistency in that database where you are performing the operation like your OLTP DB, right? But when we talk about search index update, that would be asynchronous because that is part of like this OLAP, correct? Search DB. So that would happen in some time. So in that way, there is eventual consistency between the databases. But when we talk about the database where the transaction happened, there will be strong consistency in that. Okay. And similarly, other OLAP related operations like analytics update, that would also take some time. Okay. And that is totally acceptable, right? Because when we talk about analytics like logs, metrics, it is totally fine if it is getting reflected after some time. So eventual consistency is totally fine there. But eventual consistency is not fine when we talk about like user has placed an order and we are saying we are not showing anything to the user. It can create like anxiety to the user, like what happened because my money got deducted and I don't see like order getting placed. So where is my money? Will I get my money back or not? So that is a very bad user experience. So you want to handle that thing properly. Okay. Okay, one more thing, like when I said like data flow, it doesn't mean that each of the database will have the data, because that's not what we want, correct? Like for example, if you are using both SQL and NoSQL, okay, both of the databases, for one of the feature that you're providing, you will have your SQL, and another feature you may be using NoSQL. So there is no need that the data which is present in SQL should also go to NoSQL. No, that is not any requirement here. The good part of this complete logic of using multiple databases is that you don't need to share the data, and because the different data would have different needs, and that can be handled by different DBs. So it's not like the data will go to all of the databases. In this example, it happened because like OLAP databases of course take the data from the OLTP ones only, because the work of OLAP is different from what we have in OLTP, correct? So it gets like copy of data from that, but it doesn't mean at the same time that all of the data should be flowed in all of the databases. That is not the requirement. So overall, the meaning of polyglot persistence is that because in the complex system you may have multiple different features, and each of the feature may have different requirement because the data is completely different. So instead of forcing one database to handle all those different kind of scenarios, we can pick different databases in the same system that can handle the specific features in more efficient way. So some features like payment or purchase of products, you need strong asset support, you can use SQL. For search, you need like search DBs. For time series data, you need time series databases. For like product catalog or high horizontal scaling, you need high writes, you can use NoSQL database. So in that way you get like flexibility to use the best database based on your requirement of the feature. All right, so till now we have talked a lot of things related to database, all the concepts we have covered, but now let's talk in terms of interviews. So if you are asked a question related to high level design or HLD in interview, it's generally that you will be asked only one question, okay, and you have to spend like 40-45 minutes on discussion of that specific high level design question can be something like design Instagram or design WhatsApp or design tiny URL or design Google Drive, anything like that, right? So in that you have to talk about things like what all components would be there, like the microservice, the message queue like Kafka, the APIs, and apart from all these, you also have to talk about the database. Which database will you use for this? And when you tell the database, of course, you should also have the reasoning for that. Why did you choose this specific database? Okay, so now the question is, which database will you choose for, say, WhatsApp? Or designing YouTube or designing tiny URL. Let's talk about it. So the first thing is, as we just talked about polyglot persistence, which means same system can use multiple databases. In similar way, when we talk about big systems like Instagram, YouTube, WhatsApp, they can also use multiple databases as the system has multiple features. Let's first talk about Netflix. So in Netflix, if we talk about user profiles and subscriptions, because you have to take the subscriptions and of course the user profile using the login or sign up flow. So for that, we will use SQL database. Why? Because for user profiles, you have structured data, and for subscriptions, you would require strong asset support, billing correctness, which means you would require strong consistency, and that is provided by SQL database. If we talk about the next feature, which is viewing history or viewing recommendations data, for that we would use NoSQL. Inside NoSQL, we have four categories: key value, document base, wide column, and graph. So here we would use wide column database. Why? Because this data will be at huge scale, because you have to show the option of history and recommendations to all of the users, and there will be massive reads and writes. So because huge scale and massive writes, so instead of SQL, we prefer NoSQL here. And because there can be massive writes as well, so wide column is good in that, as the data may keep on increasing, okay? Also, as we can keep all the data in one place, so there would be no need of joins here. So wide column database is good for this feature. Next, if we talk about search related functionality, because in Netflix, you would search for movies or some specific shows, right? So for that, we will use search database like Elasticsearch. Why? Because this is text search, and in search we also want things like partial matching or fuzzy matching or searching inside the sentence. So all those things are part of the search functionality, and for that search database is really good. Also, as we saw earlier, search database provides you ranking and filters, so that's why for search feature search database is the best. Now these are not just specific to Netflix. If any other system is also using, like you can say, user profiles, then you can simply use SQL there. You already know the reasons, right? Similarly for search, if it is any product like even Amazon or YouTube, for search now it's like fundamental for us that we will use search database like Elasticsearch there. So after Netflix, now let's see which database will we use for Amazon. So the first feature, if we talk about, is related to orders and payments, and for this we will use SQL database. Why? Because from the beginning we mentioned that SQL provides you strong asset properties support, also strong consistency, and it is used for financial transactions and payments. Okay, so of course we would use SQL here. A very simple example that we discussed earlier as well. So if user has made the payment but the order got cancelled, using the asset support, the Atomicity, the all the operations which got succeeded will also be rolled back. So in a transaction, all of the operations will be either successful or all of those will be rolled back, right? So that kind of feature we require when we talk about payments or financial transactions. So that's why we will use SQL here. All right, next, if we talk about product catalog, as we saw earlier in example as well, we would use document database, which is type of NoSQL DB in this. Why? Because different products have different attributes. And in document database, you don't have any particular schema. You can simply keep all of the data related to a product in one single JSON. Like for example, TV would have different features and microwave would have different features. So the flexible schema of document database is really helpful when we talk about product catalog. Next, let's see what we will use for inventory count. So again, for inventory count, we will use NoSQL database. Now we have two options, either we can use the key value database or the wide column database. If two choices seem confusing to you, you can simply say wide column database. Why? We would have the fast updates and we would have high availability. And next feature, if we talk about the search, it would be same as what we discussed for Netflix. We would use search database. So as I said earlier, it is not specific to Netflix. Whenever you have the requirement related to search, you can simply use search database. Now let's see which database can be used for designing Facebook or Meta. So the first feature of Facebook is the friends or the followers, right? Because famous is all about networking. So for this, we will use graph database, which is part of NoSQL database. Why? Because this network related to friends, followers, friends of friends, this is relationship heavy, and graph database is based out on the relationships, right? You have nodes and edges, and both edges and nodes can have the properties. Now you may also say like SQL is also based out of relationships, right? You have multiple tables and they are related to each other via foreign keys, correct? But here if you have to calculate friends of friends of friends, something like that, it will require a lot of join operations when we talk about SQL database. But in graph DB, it can be done directly and quite easily. So we would have fast reversal using graph DB. All right, the next feature is feed data. The user feed that you see on your Facebook or Instagram or Twitter, you can say the people you follow, you can see any of the posts that they have created, correct, on your feed. So for this, we will use NoSQL database. As NoSQL has 4 categories, so here we will use wide column database. Now why are we choosing wide column database here? Because there will be huge write volumes. Say you might be following 500 or 700 people or even more than that. So that data will keep on increasing, right? And you might have seen in the user feed, the data is sorted based on the timestamp as well. So you see the latest data first and then you can see the older data, correct? So if a person whom you follow, if that person has made like 5 posts, okay, so in your user feed you will see the latest post first, then after that second latest, and in that order you will see the all of the posts, correct? So as there is huge write volume and time based data, so we can use wide column database here. As we discussed earlier as well, wide column database can be used to keep time series data, right? So that's why wide column database is a good choice when we talk about feed data. Now this is not specific to Facebook. This can be used whenever we talk about the user feed. It can be in Instagram, it can be in Twitter or any other place. Okay. Next, if we talk about messages, because Facebook has Messenger as well. So for that, we will use NoSQL database. Why? Because messages are on massive scale. On daily basis, there are like millions of messages. So you can imagine the huge amount of scale required. So in this case, NoSQL is much better, because when we talk about horizontal scaling, it is difficult in SQL, right? Now, which NoSQL we will discuss when we talk about designing WhatsApp, because in that also we have to take care of messages. Okay. So overall, in interview, when you are asked high level design question, of course, it is not possible to design the complete system of Facebook or YouTube or Netflix or Amazon in like 40-45 minutes. Generally you get like a specific feature to build. Like for example, you may be asked like design user feed in Twitter, right? So or you may be asked like design Facebook Messenger. Okay, you will be asked a specific feature and you have to discuss on that part in 40-45 minutes. So based on that, of course, you would say only this database if you're talking about user feed, correct? But the good part is here I'm discussing mostly all of the features. So you would have idea, okay, if this is the thing, this database can be used, this is the thing, this can be used. Okay, all right, so after Facebook, let's discuss about which database will be used in Google Drive. Now basically in the beginning we discussed about the database versus file storage, and I mentioned like if we talk about images or videos, such kind of assets are stored in the blob storage instead of the database, because blob storage is cheaper than the database, and the CRUD operation support or the indexing support that is provided by database is not required that much for images or videos. So for images or videos, the blob storage
or the file storage is better as compared to the database? The file storage, you can just imagine it as like the disk storage, like you store things on your disk on of your laptop, right? But when we talk about a file, as we said, like images, videos will be stored in the file storage. It can be something like S3, Amazon S3, but there will be also metadata related to that file, and that we will store separately. Let's talk about it. So first, if we talk about file metadata, like the name of the file, the size of the file, the type of the file, who created this file is shared with whom, all of those things are part of file metadata. And for that, you would generally use SQL database. Why? Because the file metadata is generally structured. So here we have factors like hierarchy, consistency, permissions, and for that SQL, the structured schema or data, is totally fine. Okay, after the file metadata, we have the file storage, because we have to store the images and videos. And as we discussed, that will be stored in like Amazon S3, which is file storage, and not in database. So for this, we are not using database, we are using file storage. Why? Because images, videos are quite large in size, and file storage is cheaper as compared to the database. And another thing, like database provides much more features related to CRUD operations and the indexing, but those are not that highly required for images or videos. So that's why file storage is much better when we talk about images and videos. Then if we talk about searching, it would be same like we discussed earlier. For searching, we will use the search database like Elasticsearch. Searching will be used to search the file name or to search the content. Alright, so after this, let's discuss which database will be used to design WhatsApp. Alright, the most important feature of WhatsApp is of course the messages, because it is used to send the messages as the main feature. Of course, it provides many other features, but main features is like the messages. And for this, we will use NoSQL database, just like we saw for Facebook Messenger, but we did not discuss what kind of database. So here we are saying we will use wide column database for the messages in WhatsApp. Why? Because first thing, massive writes, right? As I told earlier, in a day only there will be millions of messages, correct? So there is a lot of data and there are a lot of write operations. So for huge number of writes, as we discussed earlier, wide column database is quite good because the columns are dynamic. You can keep on adding the columns. You can have thousands or millions of columns in a row key, correct? Another important part is because the messages are based on the time, correct? And wide column database can save time based data, so we get the time ordered data. So that is why wide column database, which is type of NoSQL database, can be used for messages. One of the famous example which can be used is HBase. HBase database is used, which is type of wide column database for WhatsApp message. Next thing in WhatsApp, if we talk about user profile and auth, we have already discussed about it in the Netflix example, right? So same as we said earlier, for this we will use SQL database. Why? We need like strong consistency in authentication, and user profile is quite structured schema or data, and that can be handled by SQL. Okay, and overall the data related to user profile is small, because when we talk about messages, you have so much data and it keeps on increasing in such a big pace. But when you talk about user profile, the user profiles are still limited, correct? So it's a small set of data, and for that SQL is totally fine. And then the schema is fixed, strong consistency, strong asset support. So SQL is good when we talk about user profiles and all. Now next, let's see which database will be used to design Google Maps. So the first feature if we talk about is location and road data, because you would require all that data, and for that we will use graph database because there are a lot of connection. So you can see a lot of nodes out there and edges which connect to those nodes, and you can tell the properties for those nodes and edges. And apart from that, you can also use some custom special database because you have to store location and all those details. But graph database can be used because you can clearly see nodes and edges connecting those, and you have the properties for that. The reasoning can be roads are like graphs, and routing is similar to the graph traversals, like finding the shortest path. So all those things maybe you might have already read while you were studying the DSA, or you might have also solved some of the questions. Like graph has all those special algorithms. Next, talking about searching places, because it is related to searching,
of course we will use search database. Then if we talk about traffic data, for that time series database can be used because we want time based updates and we want to perform aggregation operations. So for that, time series database is the best. All right, next let's see which database will be used to design Google ads or click advertisements. One of my friends was asked this question related to Google ads and the click, like which database will you use for this click events, correct? And in this system design round, I think he gave a lot of good answers, but the database part he wasn't able to give the correct answer and he didn't get the offer. Okay, so you can see the value of this video. I'm telling you, for all of the systems, what kind of database can you use with the reasoning. Okay, so this can be really helpful and it can help you crack your dream company offer. Okay, so make sure you like this video, subscribe to the channel and share it with your friends and family. All right, okay, coming back, first talking about ad serving. Okay, for this we will use key value database, which is a type of NoSQL database. Why? Because we need ultra fast reads and we need low latency, like which ad to show. Okay, so this is the feature which was asked to my friend specifically, which database will you use for click tracking. Okay, the good answer I would say here would be time series database. Okay, and if you're saying NoSQL database, you have to specify which NoSQL database. We discussed about it, right? We can use wide column database because that can be used to save time series data, but that cannot do the aggregations or some kind of operations that are required for time series related data. So if you are saying NoSQL, first you need to elaborate that. You have to tell wide column database and you can tell an example of wide column database as well, which you can use. But apart from that, you will also have to say you will use the Spark or any other analytics job or pipeline through which you will perform the operations like the aggregations or the operations which are required for time series data, which we discussed earlier in this video, right? Like the difference between wide column database and the time series database. Okay, and I told you in interviews you can choose like which option. I gave you two options, right? And based on that you can tell when you're talking about wide column database, then you have to use additional layer of Spark or any other analytics related tool, correct? So it totally depends on the interviewer. If interviewer wants to listen more on time series database, because we are specifically talking about click tracking, you can go with this one. Okay, this makes more sense. But if you're already using wide column database, then you can keep on using wide column database. Alongside that, you would require a Spark or analytics related tool to handle other operations related to aggregations, right? But we already discussed both of the options. So if you know your choices, you can tell it properly, and interviewer also will get to know, okay, you know things. It's not just you are like remembering things and just saying those. You have your logic. Why will you use this or that, correct? So time series database, the better choice here because we are specifically talking about this feature. Other option is using wide column database, which is type of NoSQL, and alongside you have to use Spark. Okay, now why I said these, because first, for click tracking there is huge amount of data because a lot of clicks happen, correct? And this is time based analytics, so it is also, you can say, time critical kind of data as well. So these are the best choice for that. Next feature, if we talk about reporting, then as we discussed earlier, dashboards, logs, metrics, we use OLAP database because OLTP database are used for running your business, handling the transactions, whereas OLAP database is used for more of analytics, handling dashboards, metrics, logs, more on, you can say, development side to understand the business, correct? So because reporting comes into it, so yeah, we'll use OLAP database. All right, next let's see which database will be used to design YouTube. Now similar to what we discussed in Google Drive, in YouTube also we have videos, right, and thumbnails, which are images. So same as like Google Drive we discussed, all those things which are heavy like images, videos, those will be stored in file storage like Amazon S3 and not in database. But of course we also have the metadata related to the file, like the video metadata, it will be stored in SQL because most of the data is structured, so you can use SQL for that. Other option is document database as well, like if you want like more flexible stuff, but I think we don't need to make it over complicated. Let's keep it simple. For metadata you can simply use SQL, because earlier also we talked about it and we used SQL. So I mean SQL is totally fine for metadata. But of course if you see like there is huge amount of data and we don't want to go into sharding that much, then of course if the scale is too high you can go for NoSQL database. But yeah, I mean SQL is totally fine. If you say SQL, I don't think there would be any issue in this. Okay, talking about the next case of comments and likes, so we would use NoSQL database for it, because there will be huge number of like comments or likes. Like for example, for a particular video you get so many likes, right? So we have to keep the data, so there is huge volume, and it is like event like data because it keeps on changing, right? So for that we will prefer NoSQL database. Next we have search feature in YouTube, and of course we have already discussed we will use search database. There are also other features in YouTube, but I think some of those will match to what we have already discussed above, and the same database you can use for YouTube as well. All right, next let's discuss which database will be used for designing tiny URL. So the famous feature of tiny URL is that from the long URL you generate the short URL, and when you enter this short URL you will be redirected to the long URL, correct? So we need the short code mapping, and for that we will use key value database again, because it's simply like you have the key and corresponding to that you have the value. And why do you use that? It is very fast, so it can handle like extreme scale, and that too very quick. So there is simple lookup as well, because you'll simply pass the key which will be your short code, and you can simply redirect to the long one, correct? So for this we will simply use the key value database. There are other features in tiny URL as well, but I think most of the things we have already covered, so that can be used in similar way for tiny URL features. Next, talking about which database will be used to design Leetcode. So the first feature in Leetcode would be related to users and submissions. You can submit the code, right, for the users and the submissions, and for that we can simply use SQL, because it is like relational data and we want consistency in it. So basically you can get the information related to the user which you show on profile, so in that you can also see like submissions and all that data. So because that is kind of structured data, relational, and it requires consistency, so we can use SQL there. Next, talking about the problem content, because you see all the problems on Leetcode, right? And then you solve that problem. So if you talk about content of the problem, for that we can simply use document database, because each of the problem can have different kind of content, and document database provides you huge amount of flexibility, correct? So for this reason we can use document database, which is type of NoSQL database. Next, if we talk about searching the problems, again because it is related to search, so we will use the search database like Elasticsearch. So after this, now let's see which database is required to design Tinder. First feature, if we talk about the user profiles. Now for user related data, mostly we have said like SQL can be used, but here in Tinder you can provide different details for the profile, and in order to make flexible profile you may choose document database, which is type of the NoSQL database, which provides you huge flexibility. In one JSON you will have all the information related to the user, correct? So you can put it that way. But if it's like the simple user profile information which has like structured data, then of course you can use SQL database like we used earlier. So it depends what kind of flexibility do you provide in your user profile information. If it's like generic fixed kind of schema, then SQL is totally fine. If it is like very flexible data that you can keep on adding or add more details, then you can use document database. Next, if we talk about matches and swipes, right, because we have like left swipe, right swipe, and matches in Tinder, correct? So for that you can use graph database, because it's more about like relations, correct? And it is easier to handle that in graph database, as graph database also provides you kind of fast traversals between the connections. There are nodes and there are edges with properties, and then you have the algorithms which you can apply to find out the fastest way using BFS or DFS or any other further algorithms which can be used in graph database, correct? So relationship based and fast reversal, so you can use graph database for matches and swipes. Next, as we have recommendations in Tinder, so for that we can use NoSQL database plus ML systems. So we would require machine learning because recommendations is something like you analyze the data and based on that you provide the recommendations, correct? We would also require machine learning systems here, but apart from that normally you can use NoSQL database. Okay, after this let's discuss which database will be used for payment system. I think you already know this because we have talked about it multiple times. For financial transactions, for banking apps, we always prefer SQL because it provides strong asset support and then strong consistency, correct? And apart from that we also require audit and compliance when we talk about payment system, and that can be provided using SQL database. Next, if we talk about analytics related operation in payment system, for that we can simply use OLAP database, correct? Because OLTP database are used for handling the transactions for running your business, whereas OLAP is used for analytics to understand the business, correct? So for analytics, metrics, dashboards, logs, you can use OLAP. Okay, after payment system, let's see which database is required to design the ticket booking system like Bookmyshow. So you have to book tickets for movie or some events, right? So which database to use? So first, if we talk about users and bookings, we would use SQL because as we already discussed about the transactions, and apart from that it also provides the support for locking, correct? So we saw in SQL in order to provide the isolation, correct? So where multiple users are trying to book the single kind of ticket, so you can do it either via locks or the other was creating the different versions, correct? So that's why SQL is good when we talk about like bookings. Okay, next talking about the seat availability, because say a user is already making the payment for one of the seat, correct? So it should not be visible to any other user because otherwise the other user will also be basically trying to book the ticket and that would cause issues or bad user experience, correct? So you generally what happens is like once a user goes to the payment flow, so that ticket looks like blocked for now, kind of booked, but just in case it fails after some time that is shown again, right? So that kind of stuff of seat availability that can be handled by SQL plus cache. Now we haven't discussed much about cache here, but we discussed about key value database in NoSQL database. So for that key value database, one of the example was Redis. In similar way, Redis is also used for cache and it is quite famous or popular, and it is used on in most of the companies, right? Redis. So why this is required? Because of the isolation problem that we want to solve and the best user experience. Of course I can't discuss about the complete design here because we are focused on the database here. I'll create a separate video on the high level design of booking a ticket on platforms like Bookmyshow, correct? So, and through that you'll get more clarity, but of course for now we can say it's SQL plus the cache. And why is that? Because strong consistency and the asset properties that SQL provides, and cache here is used for faster access and to simplify the design, which we will discuss when I create a separate video on high level design for booking tickets on platform like Bookmyshow or any other. All right, so we have seen the database used for different systems, but here comes the best part. Now I am going to share with you a cheat sheet which can help you to identify the correct database, right? So first, if we talk about financial transactions, money related things, for that we'll use SQL because we need strong asset support and strong consistency. Next, if we talk about the searching case, like if you want to search product, you want to search events, anything else, for that we use the search database because it provides you the support of like partial search, fuzzy search, searching in the complete sentence, and much more, as it uses the inverted index approach and many other things that we discussed in search database. Now when we talk about events or any data which is at huge scale, correct? So for that we'll prefer NoSQL. Like for example, we talked about messages, correct? So there are huge number of messages every day, so for that it's difficult to use SQL because we already know it's difficult to horizontally scale SQL, correct? So for that we'll use NoSQL database. Next, when we talk about time based data, For that, if we talk specifically, we use time series database. Another option is, as we discussed earlier, can be the wide column database plus the Spark or any other analytics tool, correct? But more specific, if we talk about time based data, we can use time series database for that. Talking about relationships like friend of friend of friend, or like in LinkedIn you have like connection of connection of connection, you also see second connection or third connection, like that. So graph database is used for that because you have nodes and you have edges, and both nodes and edges can have some properties having the values, so it makes relationships quite easy. And then, as we know, in graph we can use BFS, DFS and other algorithms for faster access or traversal, shortest path, all those things. So graph database is good when we talk about complex or deep relationships. Talking about sessions, or you can say key value based data, for that we can use key value database like Redis because it is very quick. So like cache also we use Redis, correct? And when we talk about analytics, for analytics we use OLAP database, which is for analytics, right? Because it can perform aggregations and other things which are required for analytics, logging, metrics, dashboards in much better way. All right, so this was about database. We discussed in detail about a lot of things. We discussed about SQL, NoSQL, types of NoSQL database, then search database, time series based database, OLAP versus OLTP, which database to use for which feature, correct? So all those things we discussed. So if you have any questions, put those in comment section. I'll try to help you out. And I know because it was a really big video, you might not be able to pick all of the concepts in one go, and that's totally fine. What you can do is like revisit this video and go to specific part if you want to understand that. And yeah, once you keep on repeating the things, you'll get more idea. Okay, if you want me to cover any other topic in my next video, put that in comment section. I'll try to create a video on that part. If you found this video helpful, press the like button, subscribe to the channel and share it with your friends and family. All right then, this is Mohit Chabda signing off. Subscribe to the channel and thanks for watching.